I'm Brian Holt. Or Complete Intro to SQL. I know I'm going to get people upset about how to pronounce that. I will probably say both because I have no consistency in my life, but that's between me and my therapist. Anyway, let's click on the introduction here. Oh, first of all, actually, I want you to go to sql.holt.courses. That'll take you to this website here. This is literally all of my course notes. This is everything I'm going to be teaching you today. I have two computers here because I teach from this one and I read from this one. I have my notes up here. So if you fall behind, or if you want to review something, or if you want to share this with your friend, this site is open and free forever. Okay, so now that we've done that, we're going to click on the introduction. Just to show you how this kind of works, up here in the top right, you see Welcome Introduction. This is the name of the section. This is the name of the lesson, so that if you jump ahead, or if you fall behind, or if you just want to know where I am, you can just see the Welcome Introduction, Welcome Introduction. It matches up so you can kind of use a breadcrumb to find where you are. And with that, let's get into the introduction to this course. My name is Brian Holt. I've taught too many courses here. I literally can't count how many times I've been here. And I want to teach you about SQL today. So SQL it's a language. It's not necessarily a programming language, though you'll see here in a little bit, you can kind of turn it into a programming language. But there's an incredible amount of depth here. And I think that makes it seem a little unapproachable to people. It seems like they have to learn this entire new programming language, but in reality, you can get, I would say, almost all the benefit of SQL with a very small subset of knowledge. Don't get me wrong, there's people that have decades of experience here that can do wild things with it. We're not going there today. I'm trying to get you something really, really practical. And I guess that's the kind of one of the first points I want to hammer on. This is a course for developers. I'm not going to teach you how to replicate. I'm not going to teach you how to deploy. I'm not going to teach you how to manage instances of Postgres. You want to learn that from like a DBA or from an ops person, and I am neither of those. What I am going to teach you today is if you're a developer and you want to write queries to an SQL database, or you need to create some tables, or you need to model some data, that's stuff that we're going to talk about today. So yeah, here's kind of some examples of things you're going to learn: how to set up databases and tables, what's going to go into your tables. We're going to write up just the smallest bit of Node.js today, because I actually wanted to get you your hands on code querying a database. If you don't know Node, that's fine. You can just kind of follow along. Those kinds of things. So who is this course for? It's for you, hopefully. The things that I'm going to suggest that you know before you take this course that'll be really helpful. Just internet fundamentals. There's a great course from Jen from Front of Masters that goes over like how the internet works and a bunch of stuff like that. It's very good to have that done first. Some basic coding abilities will be really helpful. If this is your very first coding class ever, that's going to be hard. It's probably still possible, to be honest with you, but it will be hard. And then a little Node.js would go a long ways. And I linked 3 different Front End Masters courses here for you to kind of brush up on those. Yeah.
What about Gem's full stack?
What about Gem's full stack course? I mean, it's a great course. I don't think you need to take it before you take this course, but you could. I guess Gem does talk like a little bit about Node.js, right?
He talks about everything, like how the internet works, basics of sysadmin, all those kinds of things.
Yeah. If you wanted to go more in that direction, certainly that course would be really helpful. So your setup, I have tested this both on Mac OS and on Windows 10. If it works on Windows 10, it should work on Windows 11. And if you're doing this on Linux, you probably already know everything I'm about to tell you, so you can just ignore me at this point. But you can just follow, I'm kidding, you can follow the Mac OS instructions and that'll work for Linux just fine. You won't need a particularly powerful computer for this. I would recommend about 8 gigs of RAM. That's probably the thing that's going to like gate you the most, but you could probably do this on 4, or 2 would be hard, but you could probably do this on 4. You will need to use Docker. You don't have to know Docker. If you would like to know Docker, I teach a whole course on Docker for Front End Masters, but I will give you all the Docker instructions. This is not a Docker course. You do not have to use Visual Studio Code, though I will be using it, and I will show you a couple of tricks for it just throughout the course. I used to work on it, so I like it. People always ask me my setup, so I put it in here. But the font is Mona Lisa. I just use the default Dark Plus theme. I use iTerm 2, and then this VS Code icons extension. So if you want to come back later and you're wondering how I set things up, it's all linked there. Where to file issues, there is a repo here. So if you open this, this is the course website here. So here you can open issues, you can open pull requests. I'm going to ask you, if you have questions, don't message me, put them on the repo, because then later if someone else has the same question, they can Google it and find it in the repo. And pull requests are very welcome, particularly because I always have a ton of spelling and grammar mistakes in my courses. So there is another course on Front-End Masters, which I'll pull up really quick here, that I taught previously called Complete Intro to Databases. This is all still current and useful. This covers 4 different types of databases. This is more comparative of like, I'm thinking about this problem that I have, how should I model the data, right? And so it goes over an SQL database, which is Postgres, right? So this section here is going to largely overlap with what I'm going to teach today, but we're going to go into much more depth today. But this class also goes into graph databases, key value stores, as well as NoSQL databases. Specifically, it goes into MongoDB, Postgres. This is Neo4j, and then this is Redis. So this is much more like a higher level comparing. Use NoSQL for these kinds of problems, use Postgres for these kinds of problems, use Redis for these kinds of problems, right? Whereas this class is specifically teaching you in-depth SQL so that you can, work with an SQL. You've already decided to use an SQL database. This one's going to help you choose that you want to use an SQL database, if that makes any sense. My name's Brian, and I work at Stripe. Specifically at Stripe, I am the product owner of the Stripe SDKs, the Stripe VS Code extension, the Stripe React Native experience, the CLI, a bunch of developer tools, right? So that's kind of the theme of my entire career. For the most part, I've worked on developer tools. Previous to being at Stripe, I worked on VS Code, and I worked on Azure. I was the owner of JavaScript on Azure. And then before that, I was a Node.js and JavaScript front-end developer for like a decade. I worked at LinkedIn, Netflix, Reddit. I started teaching at Front-End Masters when I worked at Reddit, so that's been, we're coming up on a decade of me teaching at Front-End Masters, which is crazy to think about. I've written a lot of code and queries over the years. I started coding probably around when I was 10. My brother made me write code before he'd let me play video games, so I'm both still upset at my brother and also thankful, because here I am. But I'm going to tell you right now that you can learn these skills at like any point, right? You can be 60 and starting this. You can be 5 and you can be starting this. I don't know, 5. I don't know if I'm going to teach my 5-year-old how to write queries in SQL. I don't know, maybe if he's bad. When I really started writing a lot of serious SQL was my internship, where I had to like query these, really archaic and weird databases using SQL, which taught me a lot. And then over the years at Reddit, I wrote a lot of queries. At Netflix, it's kind of been a theme throughout all my career to use SQL and various incantations. I didn't really start using Postgres until I worked at Reddit. Before that, it was mostly MySQL. But you'll see that while most of the things that we're going to talk about today are very specific to Postgres, a lot of these skills are generally applicable across all and any SQL databases. And we'll talk about that in a little bit. I live in Seattle. I like to travel, hang out with my wife and my new kid. And yeah, that's me. Feel free to catch up with me on social media. All my links are there. And the last thing I always ask people is if you can give this repo a star, it helps people find it, which is cool. It also pads my ego, which needs help sometimes.
What's the secret of mastering all these skills like databases and front-end development?
That's a good question. The theme of my career is I've worked all over the stack, right? I went all the way from working on pure front-end applications sometimes. I did that at Reddit and Netflix, all the way to working on lower levels of the stack and doing back-end stuff. I did that at like LinkedIn and also at Netflix, all the way down to I worked on cloud infrastructure at Microsoft. right? And now I do product management stuff and business stuff at Stripe. And the thing that's been critical to my success and me learning all these various different tools is that I learn by teaching, and that's just kind of my learning style. When you are forced, or when you're teaching, you are forced to kind of reduce your knowledge down to a common vocabulary between the person that you're trying to communicate with, which means that you have to break down these things that you kind of hand wave over in your brain, and like you have to kind of open the box and see what's inside of it and understand really those primitives, because you know people are going to ask you questions and you have to kind of provide for those questions in advance. So in other words, a lot of it's from experience, and secondly, I've taught a lot of people, both teaching workshops to my coworkers and doing front-end masters and doing conference workshops. Doing all of that teaching really helped solidify these kind of basic primitives in my brain that I use to build back up into more complicated, higher level things.
Should I take the Intro to Databases course before this?
No.
Or?
No, so the Complete Intro to Databases, like I said, it's kind of a different approach to a similar thing, where it kind of teaches you how to model problems and what kind of database to use for each one of them. This one has no dependency on Complete Intro to Databases. This is its own thing, so you do not have to take that one before. In fact, if you take this one before, for the most part, you could probably skip the SQL section in the other one. This one is going to have more depth than the Complete Intro to Databases one. Yeah, Dustin.
Do I have to download Docker for this course?
You must download Docker in this course, and it's literally the next section. So, speaking of that, Docker. This is not a Docker course. I left a link here for you to my Docker course if you want to take a Docker course, which I suggest, because I think containers are really important for developers. But that's not what this course is. I'm going to give you all the Docker commands, but I do need you to go download Docker Desktop, or whatever flavor of Docker. But if you don't have a preferred flavor of Docker, you should use Docker Desktop, because that is by far the easiest one to use. So please go install Docker Desktop. I left a link here for you. It should detect whatever desktop you're on, and you can download it. They'll kind of lead you through all the various different steps that you're going to have to do to get that up and running. And then we are going to interact a little, actually quite a bit, with the command line. This is not a command line course. There is a command line course that I also teach that would be helpful, but again, not required for this. I will give you the command line commands that you are going to need. So in other words, you can basically just copy and paste all of my commands directly, and that should just work for you. If you're not familiar with Docker, Docker uses containers. A container is basically, you can think of like a mini operating system that they kind of put together for you to use. We're going to be using 2 containers, and actually kind of 3 containers at one point, but these 2 are the primary ones. The first one is just the vanilla Postgres container, and then the second one is this kind of one that I built on top of it. So the second one actually depends on the first one. So Docker will handle that correctly. You don't have to do anything about that. We are going to be using specifically Postgres 14 for this course. They actually do tend to change a lot between Postgres versions. So even if you're taking this way later from when this class was filmed and Postgres 15 or 16 is out, I will suggest that you still use Postgres 14. That way, everything that all the commands and stuff like that will work as is. You don't have to kind of do any translation. And then later after the course, then go learn what changed between 14 and 15 or 14 and 16. This second one here, you can click here. It's just a container that I put up on Docker Hub called Complete Intro to SQL. It has 2 different databases seated in it. It has the Open Movie database, which is a huge database with a bunch of movie stuff in it. And then there's another one for a website that you and I are going to build called Recipe Guru. Just know that I'm going to have you download some of these containers. They are quite large, so if you're on like metered internet, you might want to find someone that's not metered. Each one of these containers is about a half gigabyte, so I'm going to have you download about a gigabyte worth of stuff. You can run these now. This is actually going to go pull these containers. It's not going to run them yet, but it'll download them onto your computer. And then once you've done that, I want you to grab this command right here. And we're going to just paste that into our command line here. So I'm just going to paste docker run. You can see I give it a post. This is E means environment variable. So I'm going to give it a password of LOL because it's really easy to remember. Obviously, don't make your database password LOL in production. Not at all what I'm advocating. This is just something that's really easy for us to reference later. We're going to call it PG as in Postgres just because that's really easy for us to reference later. The --rm means once this container is concluded, remove all of the logs and stuff like that. Don't leave that stuff floating around. The -d is detach, which means run it in the background, don't run it in the foreground. The -p means expose this port, so we're going to expose 5432 to our local computer. Postgres is the name of the container, and the 14 is the version. So I just explained that all to you so you're aware, but you actually don't need to care at all. You can just copy and paste it and say, I don't care what Brian says. That's fine. You should get something like that. That's the hash of the container that's running. And now I should be able to say docker ps, and you can see here I have my container running. It's been up for 7 seconds. Its name is PG, and it is running on port 5432. So going back, I just want to give you enough Docker information to be dangerous. So right now we have docker ps. That'll show you everything that's running. If you want to stop it from running, you can just say docker kill pg, and that will stop it. So now if I say docker ps, it's gone. And again, I can run it again. That'll start it again. That's all goodness. The one thing that I wanted to say about running docker kill, it will delete everything that you've done. So if you've been following along the course and you're like halfway through it and you run docker kill, it's going to drop everything that you had. So just be aware of that. So that's both a good thing if you're trying to reset and start over, but it's a bad thing if you didn't mean to drop everything. Docker is really good about just running quietly in the background. So if I just close my laptop and come back, the Docker container typically will still be running. But if you restart your computer, for example, it will kill your containers. You could fix that by running volumes in the background, but I'm not going to show you how to do that today, so just be aware of that. The thing that you can always do, the complete recipe guru database that we're going to build up over time lives inside of this complete intro to SQL one as well, so you can just pull that one and start from there as well. Yeah.
What does it mean to run the Docker container in the background versus foreground?
That's a good question. I can just show you really quick. So if we do this docker run and I just take this -d out, it's actually going to start Docker in the foreground. Like you can see all of the logs running immediately right in front of me, right? Now I don't want to do this, right? I just want it to run in the background and not think about the actual execution of it. But if this is useful to you and you want to see all the logs from it, this is how you would do it. What's hard about this, if I say Control-C or if I close this window, it's going to stop the container, right? So you can see there I actually shut it down. It's not running it anymore. But if I do this and I come back here and I say -d, it just runs it in the background. And I can kind of just not think about it anymore. The last thing I want you to do here is just copy and paste this one, docker exec. If you run this, you should just immediately get a session of being connected to Postgres. So you should see this Postgres prompt here. If you do \l, it should tell you all of the databases that exist in your database, which we only have, the 3, Postgres, template 0, and template 1, which we'll talk about here in a second. So what that command did, this docker exec, this is basically saying, hey, run a bash command inside of the container. The -u means run it as the Postgres user. -it is interactive. PG is the name of the container, and PSQL is actually the name of the command that we're running inside of the container, which is the Postgres client, right? PSQL is the client to run queries against the database. So I can type exit here. and the container is still running, right? Because we're not actually ending the container, we're just exiting our session with the database. So anytime that you want to connect to it, you just run this docker exec -u postgres pg psql, and that'll put you inside of the container. Now that we've gotten over all the Docker stuff, let's go ahead and chat about SQL. So, Mark, you had a question?
Yeah, since Postgres is such a stable, long-running software, what kind of things would change between versions? Like, I'm assuming SQL is not going to change the language, but
Yep.
like what types of features would they be changing?
Cool. So yeah, like what's changing from version to version on Postgres? Super valid question. So the first thing to know about SQL and Postgres are kind of different things. SQL is a standardized language that exists across not just Postgres, but it also applies to SQL Server, Oracle database, IBM DB2, MySQL, MariaDB. There's a bunch of databases that all use SQL, and there's one single standard language. You can kind of think of it like JavaScript, right? JavaScript is a language, but there's different runtimes that run JavaScript. There's Node.js, there's the browser, there's Deno, there's now Bun, there's Rhino, there's JerryScript, right? They're all using JavaScript, which is the name of a written language, but something different is executing them. It is the same thing with SQL and Postgres. The interesting thing about SQL and Postgres and all these different permutations is they all kind of have their own flavor. Despite the fact that SQL is a standardized language, they all take their own different approaches to it, and they all add their own features to it. So a great example of this is we're going to talk about down in quite a few lessons. There's one here called like JSONB. This is not a part of the SQL spec. This is a Postgres only thing. So that's what changes between versions, is they're adding all these cool new features that are specific to Postgres, and they're making refinements and they're trying new things. Like once we get to JSONB, you're going to see like, why wasn't I teaching this the entire time? Kind of spoiler alerts right there. But that's what's changing, is they're adding new cool features, and they're still innovating at a pretty rapid pace. And particularly Postgres I feel like is leading the pack, which is why I chose to teach this one over MySQL mostly. So now's as good a time as any to address the SQL SQL elephant in the room. What is the correct pronunciation of SQL? Well, it depends on who you ask. I did a decent amount of research of this because I was positive that someone was going to ask me. The correct pronunciation of SQL, according to the body that defines SQL, is SQL. They pronounce it SQL. However, the people that make SQL Server, aka Microsoft, calls it SQL Server, right? One of the most well-known people that works on defining what SQL is and writes all these books about it, she calls it SQL. So in other words, SQL is probably, by the most definition of that, the defining body calls it SQL is probably the most correct, but SQL is equally valid. I call it SQL because that's just what I've always called it. There are other people that will always call it SQL. But I think generally my rule of thumb is if I'm talking about MySQL or Postgres or one of those, I generally say SQL. And if I'm talking specifically about SQL Server and Microsoft Stack, I will call it SQL because that's what everyone in that community calls it. Basically, Microsoft and Oracle have codified SQL. So if you're talking about Oracle as well, they call it SQL in their docs. Basically, everyone else that I'm aware of calls it SQL in terms of like it's PostgreSQL, MySQL, MariaDB calls it SQL. So they're both correct. Someone will get really opinionated about it, and you can just tell them that you don't care because it does not matter. We're both talking about the same thing. There's a really interesting history about it, but suffice to say that SQL was invented in the 70s. It was derivative from a language called Square. They tried to call it actually literally SQL, SEQUEL. That was some acronym. That was the name of some fighter jet or something like that, so they couldn't call it that, so they ended up calling it Structured Query Language, SQL, and we ended up with that. A fun fact is that my dad actually used to work on SQL databases. He worked on DB2, which is the IBM flavor of it. They still sell DB2 these days. And then he ended up being a technical salesman for IBM for years and years and years. So this is actually stuff I ended up growing up around, kind of unintentionally. It's really funny to my dad that he did all this stuff for all these years, and now I'm teaching it to people. So, fun fact. Hi, Dad. He might be watching. I don't know. Let's get into structured query language, SQL. And again, you can call it whatever you want. I will never correct you because I profoundly do not care how you pronounce it. And it's one of those things, those hills that people choose to die on for no apparent reason. So we are going to get started on tables, not inserts. So if you're not already, please get to running inside of your container. You should see something here like Postgres, like that. If not, you can go back to the previous lesson. It will show you how to do that. And let's start running some commands. So again, we are interacting with the Postgres database with a client called PSQL. Those are different things, right? One is a database, one is a client that is sending queries and getting information back. So I could be hosting one database and everybody else could be querying it with their own PSQLs, right? So you have one database, but you could have many clients to it. This client has a bunch of built-in kind of helpful commands, and if you forget what they are, you can hit \?. And this will just pop up a really helpful sort of help information that'll show you a bunch of stuff. I use it all the time because I can never remember all of them. But there's a bunch of stuff here. You can run commands out here. So if I do \!, that'll allow me to run a bash command and the underlying bash. Sometimes that can be helpful. You can like cat in files and things like that. We're not going to be using that today, but there's a bunch of stuff you can do with it. And anything that you see prefixed with a \, that's going to be a feature specifically of PSQL and not necessarily of Postgres, the database. The one that I find myself using a lot is \l. This will show me all of the databases that exist. And I'll use \d quite a bit. We haven't created any tables yet, so it will not find any. But \d will show you all of the tables and sequences and constraints and stuff like that. So that's a good place to get started from there. So we have a bunch of default databases. You can see here I have Postgres, I have template 0, and I have template 1. So the first thing to say is, what is a database? Aren't we connected to a database? It's a bit of a conflated term. In this particular context, when I say we're connected to the Postgres database, it means I have my Postgres server running, and there are multiple databases inside of this. You can think of a database in this context as a folder, right? It's a folder that contains many tables, right? Which you can kind of think of like spreadsheets, right? So Postgres here, or template 0, template 1 would be the name of my folder that I'm in. In a moment, we're going to create our own database or create our own folder, but a database contains many other tables and things like that. Okay. As you can see here, your database comes with 3 of them pre-created. So the Postgres one exists solely as the purpose as it's the default database that you connect to. If you don't give it anything that is like you're trying to connect to a specific database, it just exists for that purpose. It's the default one. You can technically delete it. There's no reason that you can't delete it. You also don't have to. That's up to you. So template 1 and template 0 exist for the fact if you are creating and deleting a bunch of databases and you want to have like a template to start from, you would use template 1. You would make a bunch of modifications to template 1, and that'll affect the default database that you create. If that gets all out of whack, what you'll do is that you'll then clone a new template 1 from template 0. You should never modify template 0. And this is basically all stuff that you can totally forget because I never use them. This is why they're there. This is why they exist. But I never use the templates. I always just create everything from scratch because I don't find myself creating and deleting a lot of databases, right? I generally just create my database and then just go from there, right? So, but I wanted to know why they're there. Okay, that being said, we are going to run this command, right? So I'm going to say create database recipe guru. So a couple of things to note here. Now I can say \L, and you can see here we have our recipe guru database. So we've created our own folder to work from. We're going to be doing, the first part of this workshop, we're going to be creating a recipe website, okay? Hence the name Recipe Guru. Now you might have seen there that I said in all caps here, create database like that. Why did I do it that way? Why is it all caps? Well, the reason why I do that is so that you can see the commands that are coming from SQL are always going to be in all caps when I do them for you, and everything that we do that's like optional user-controlled information, that's going to be in lowercase here, like Recipe Guru. That's a very common pattern in SQL, but there are also people that insist that you should never do caps, and it's really dumb, and people are wasting their time and pinky strength by holding shift down for so long. And again, it doesn't matter. I like it. Whenever I'm writing code, I tend to do everything in all caps, so it's really easy for me to glance at and say, like, okay, create database, that's a command, Recipe Guru, that's the name of the database, and it's really easy to parse that visually. But there's no requirement that you have to do that way. I will find myself when I'm just writing queries just to like write queries, I'll probably not do caps just because I'm lazy, right? So that is totally up to you, and it's one of those things like SQL versus SQL, it really just doesn't matter. So it's never worth getting into an argument with anyone over it. So I'm just going to throw out here one more note that if you kill your container at this point and you restart the container, you will have to recreate Recipe Guru again because it's going to give you another blank slate, right? That's just another word of caution that I'm putting out there. I do provide here this complete SQL file. You can actually download this. This will actually be the complete Recipe Guru. So this will give you actually the first half of the workshop already done, if you need that. Or you can use the container from Docker Hub, which is the this one here, the complete intro to SQL. And that will also give you the complete Recipe Guru database. So a database is a collection of similar tables. For all of our recipe apps, we'll be storing them in one database. People ask me frequently, when do I use multiple databases? When do I just shove everything into one database? That is a very you call to make. In general, I tend to shove a lot of things into the same database because I don't really see the use in trying to make them work across databases. In particular, if anything would ever have to be like related to something else, like I have my ingredients, I have my recipes, those obviously have to be connected to each other, right? Those have to be in the same database, no matter what. But let's say I have like user session information and I have recipes and ingredients. In theory, those could live in different databases because I would never have to like collate those two together, right? So it's a highly opinionated thing, right? It's kind of like asking the question, should I have two services or should I have one monolithic service, right? Should I have microservices or macro services? It depends on what you're doing. For your purposes, getting started, just throw everything in a database and in general you'll be fine. The question you can kind of ask yourself is, would I ever have to scale these things independently? Which is where it can be useful to be split across databases. So you can see here I created the Recipe Guru database, but I am still connected to the Postgres database. So I want to switch my connection. So I'm going to hit \C recipe, and then this actually does have tab completion. So I can hit \C Recipe Guru, and now you can see here I'm connected to the Recipe Guru database, which again has nothing in it. If you put \D, you will not find any relations yet. But we're going to go into the next lesson. We'll actually create some tables. So let's create our first table. We're going to be creating an ingredients table. So you can see here, let's just run it, and then we'll talk about it. So you can just copy this, or We can even just type it out a little bit so you can actually kind of get a feel of what it feels like to type it. Create table, ingredients, and it's going to have a couple of things in here. So we're going to have an ID, which is going to be an integer, or you can put integer like this, or you can just put int, it's the same thing, or int4. I don't know why that would ever be the one that you would choose, but you can choose that. Int, it is a primary key. It's generated always as identity. Okay, then we're going to have a title. It's going to be a varchar, and we're going to give it a length of 255. It is unique and not null. Okay, then we're going to close our parentheses and we're going to hit a semicolon. So first of all, the way that we know that it successfully ran is you see here it says create table. It's going to repeat back to you what you just did to tell you this worked, right? And now if I hit \D, you can see here I have a table and a sequence, which is what I'm expecting. And if I say \D on ingredients, it'll actually describe the table to me, which is an integer, of ID, and a title. So all this works. Let's actually break it down piece by piece of what we actually just did. So create table, we're telling SQL we would like you to create a new table. You can think of a table as basically just a spreadsheet, right? It's got rows and it's got columns. The columns are all represented here like ID and title, right? It's going to have an ID for every single one of these, which is basically just a unique identifier, right? That's literally what it is. And then we're going to have a title, which is going to be something like cucumber or flower or chocolate or whatever you want to think of there, okay? We're naming the table ingredients, and then we're going to give it all of the various different columns, right? You can basically think of, like, again, setting all of the column names in your spreadsheet. You have to tell it what type of thing it is. We're telling it the type of thing, the data type here is integer, so this can only be a number. If I try and put, you know, Apple into the ID, it's going to say this is not an integer, you can't do that. So it actually is going to verify and make sure that that's true. We're going to say that this is the primary key. Every table that you're going to create is going to have some sort of primary key, right? It's going to say like, this is how I'm going to index this table, right? So in this case, we're just saying that the ID is the primary key. That's going to be very common. It's not always true. I'll show you one later in the course that's not. But for now, most of these are going to be IDs kind of like this. And then this generated always as identity. If you've done previous versions of Postgres, they used to call this serial, S-E-R-I-A-L, right? Not the food. They actually, I think you actually still can do it. I think it still works, but it's been, if it's not been deprecated, it's at least been de-emphasized. This is actually more compliant to the SQL spec. That's why this is preferred now, even though serial was a bit more simple, right? But here we're saying basically, we want you to always generate this key for me, and I want it to be incrementing, right? So the first thing I'm going to create is going to be ID 1. The second thing I create is going to be ID 2. If I delete that one and then I recreate it, the next thing we'll create will probably be ID 3, right? So it's going to give everything across your entire app a unique identifying key that we don't have to keep track of. That's what this ingredients ID seek, this thing right here, that's what this actually keeps track of right here, is it's the next thing in the sequence, right? The next number that's going to be put into that ID, okay? So that is the first column. The second column, we're saying that we're creating a title, right? The varchar is a type of string, right? So text, right? Free text. And we're saying that this has a max length of 255 characters, right? So if you have a ingredient that's 256 characters, it's going to truncate the end of it, and it's not going to store that last one. We could put another one here called text. So it would just be title, text, unique, not null, right? Text is infinite length, right? It's variable length. But titles in general, like the title of your ingredients not going to be very long. This allows Postgres to kind of shrink that storage size a little bit, right? Keep it a bit smaller. And then the length is 255. That's a common one to pick just because that'll fit in some amount of bytes. I can't remember exactly how many, but it's pretty reasonable that we can expect the titles of our ingredients to be under 255 characters in length. And that is our first table. It's an empty table, but nonetheless, it is a table. So we've created our spreadsheet and we've put nothing into it, but we now have a place to put data. You're going to hear me a lot today use the spreadsheet analogy. It's because databases, well, basically a spreadsheet is a database. It's just a database that it's really easy to edit with Google Sheets or Excel, right? And it's not actually theoretical. You can actually use Google Sheets as a real database. You can write SQL queries that work against spreadsheets. So it's not theoretical, it's actually a true thing that you can do. I'm not going to recommend that you run your entire company on Google Sheets, though I've heard of people doing it. So we're going to talk about inserts more in the next chapter, but I want you to just copy and paste this bad boy with me, the insert into ingredients here. Mostly so that we can see what happened. So I inserted into ingredients, I inserted a bell pepper. So now if I say select star from ingredients, you can see there I have one thing in my database. I have a bell pepper. But notice here at nowhere did I specify the ID, right? The ID just came with it. This is what I was saying about this primary key generated always as identity. That's where that comes from, right? So it's going to just keep updating that. So you don't have to keep track of it. The database keeps track of it for you. And again, we'll talk about inserts in depth in the next chapter. I just wanted you to, as well as selects in the chapter after that, but I wanted you to see this is how stuff makes it into the table, and now we actually have something in our table. Yep, so they used to call it serial like that, but now the generated always identity is more compliant to the generic SQL one, and they're trying to be good citizens of the SQL world, so that's where generated always as always comes from. And so you should see something like that, which you saw. So I want to show you how to drop a table. So let's do that just for fun. Drop table ingredients. And now if I say \d, you'll notice that it did not find any relations. That's what drop table does. By the same token, you can say drop database, recipe guru. We could totally do that. I'm not, well, whatever, let's just do it. It's fun. Except you don't have to do this, but. And then now we can drop database recipe guru, and lo and behold, it is gone. So create database recipe guru. A note on semicolons. A semicolon means the end of a statement. Just like in JavaScript where you put a semicolon at the end of a line to let JavaScript know period, full stop, end of sentence. It's the same thing in Postgres. It is required here though. There's no automatic comma insertion in Postgres. It's going to keep going until you give it a semicolon to let it know that I'm finished with this. So it does mean that you can put multiple statements on one line. Right? Multiple queries. I'm going to use those terms more or less interchangeably, statements and queries. The one thing that you notice here when I do this \c recipe guru, I'm not putting a semicolon there. It's because PSQL doesn't care, right? This is not SQL. This is PSQL helper things, right? So it doesn't care about semicolons, but your SQL does. That's why sometimes you'll see it and sometimes you won't. Let's create our table again. I'm just going to copy and paste it this time. And let's now change a table. Sometimes you'll have to do this, right? So I'm going to say alter table ingredients, and we're going to add a column. Okay, and then we're going to add a column of like an image, right? Because we're going to want all of our ingredients to have some like representative image. So I'm going to say add column image, and we're just going to make it another varchar of 255, because for the most part, URLs are not longer than 255 characters. In our case, they definitely won't be. So alter table, you give it the table that you want to change. You tell it what you want to do. You can also drop columns. You can change columns, right, from one data type to another. These are all things you can do with an alter table statement. Okay, so now if I say recipe guru, not recipe guru, it's ingredients. You can see here it now has an image. By the same token, we can alter table ingredients, drop column, image. And now if we do that again, you can see here we had an image up here, and we no longer have an image down here. Yeah.
If you had kept the table with the data in it and tried to add a not null column, could you do that, or do you run into errors?
So the question is if I have a not null constraint, we are going to talk about constraints. You can see here that it says nullable, not null. And if I try and add something that has a not null, what happens? You have to tell it what to do. So I actually don't have anything in that like that in here, but if you just tried to do it and didn't do anything, it would error, right? Because it's like you're trying to do something, these all don't have anything to do. So in general, you're going to give it some sort of default value, or you can give it specifically like, okay, for all of these columns, give this one, this one, this one, this one, this, but you have to provide for that kind of thing. The easiest thing to just say is like, give all of them empty string or something like that, and then go back and change it.
Can we add a column that stores image content?
So I believe the question is like, can I read out the binary data, like actually dump the actual image, not just like a path to the image, but the actual image, and then store that in Postgres? You absolutely can. I'm going to say that 99.999% of the time, that is a horrible idea, and you should absolutely not do that. But it is possible. There is a binary data type that will store something like that. Postgres is not really made, it's made for fast querying and retrieving of information, and you're not going to query by binary data, so storing it there doesn't make a ton of sense. When there's something like, I don't know, Cloudflare or something like that that's much better at storing images and handling images. But if it really is like you're just putting some stuff in there because later you want to get them out, sure, that it does technically fit in there. So let's go back and look at where we were. We dropped image, which we did that. Just like we did above, you can add constraints like unique or not null. Unique will make it so that, for example, let's say we wanted to make sure that no two ingredients had the same image, right? I don't know if that's a constraint you have. You might have it. If you did, you would say add column image varchar unique, right? And that would put a unique constraint on it, which makes sure every insert is different from another one. You could also put not null. In fact, we're going to do that here in just a second with this one right here. But this is saying that it cannot be empty. You always have to provide for it, even if it's an empty string. You do have to provide for it. So let's go ahead and do that. We're going to alter table ingredients. So notice that I didn't put the semicolon here, which means that it's going to think on the next line. It's like, okay, you're continuing your query here. Add column image varchar 255. Add column type varchar 50. I'm making this one only 50 long because I know these types are never very long. Okay, this one I'm going to say that it's not null, so that everything has to have a type. Oh, and I have alter table ingredients, add column image. Oh, You know, I forgot a comma after the image here. So this one right here, you do have to, because I'm doing multiple add columns, I have to put a comma there. So it's usually pretty smart about telling you is like, hey, this is where the parser of SQL lost your train of thought. In this particular one, it's like I was not expecting to see add column type here, which means it came right before it. Okay, and now if I say describe ingredients, you can see here there's now a type, an image, a title, and an ID. These ones are all not nullable, whereas the image is nullable. We don't require it to have an image. Yeah, Dustin.
Are table names case sensitive?
Table names, I believe, are case sensitive. You know, honestly, good question. No, looks like they're also case insensitive. Today I learned. I've never tested that theory before. No, I'm inviting you to not test that theory either. There are so many data types in Postgres that I just don't even want to get started with how many there are, but if you want to look through them, these are all of the data types that you can have in Postgres. So many data types. And then, honestly, this is not even it, because you can actually add extensions to Postgres to add things like geolocation data, right? PostGIS, which will allow you to say how far is this point, in Seattle from this point in Minnesota, right? And you can do those kind of calculations using Postgres. That's an extension that you have to add to Postgres to get that. Today we're going to be going over probably 10 different data types, but just know that there's a lot more. So one of the things I wanted to show you here with this alter table, you don't have to do the add columns or drop columns or anything like that one by one. You can do like 5 different operations. I could have these 2, and then I could also drop another all-in-one alter table command, and that would allow me to do that all in one query. The reason why that's helpful, if you might imagine you're trying to modify something that's out in production, right? If it fails, you want it to fail all at once, right? You don't want 3 of them to succeed and 1 to fail. You want everything to fail so that you can go back and try again so that you have one holistic attempt. This is called it's transactional, right? It either worked or it didn't work. It doesn't partially work. So that's the advantage here of doing multiple things on one alter table. Yeah, Mark.
Me and a few other people in chat are getting the error column type of relation ingredients contains null values.
Yep. So this is the question that we were asked earlier. What happens if you try and add a column? So I imagine most of you probably didn't drop your table, right? If you didn't drop your table, that means you have something in there, right? Which will be a bell pepper. So basically here we're trying to add a column of the type that is not null, but there's something there that is null, right? Because if you add a column, that means it's going to add something and it's not going to have the ability to deal with that.
Start from scratch.
That's going to be easier. Yeah, that's probably what I would do. Drop table, ingredients, and then you can just create table, ingredients.
Yeah, someone just added the words default and then in quotes vegetable, and it was able to do that.
I thought it'd be something really simple like that. I could just not. Here's my thing with SQL. I did a lot of work preparing for this course and getting all these queries correct. I never remember this all off the top of my head. Absolutely never. I Google constantly when I'm doing SQL because it's very specific in terms of what syntax comes where, what quotes go where, what double quotes or single quotes. In fact, I imagine someone right now is probably having a problem of putting double quotes around something. You can't do that. You have to use single quotes when you're talking about values. We'll talk about that in a second. But if you're doing default quote vegetable, use single quotes, not double quotes. Let's just go ahead and see it because I think that might be a useful thing for people to see. Create that table. come back here, alter table, and then you default vegetable. And there you go. And I'm saying these have to be single quotes specifically. So that is the databases and tables. We're going to start getting into how to handle more data going in and out of your Postgres database. So we're going to go down here to the next lesson, and we're going to do inserts first. So now we have 3 different columns that we have to insert into. Well, 2 of them we have to, 1 of them we could leave blank. So let's go ahead and do that right now. We're going to say insert into ingredients. Okay. And we're going to insert them in the order of title, image, type. We don't have to do it in that order, but this is the order that we're going to do it. Okay, and then we're going to say values. Single quotes, again, I'm going to re-emphasize that. Single quotes, not double quotes. Red pepper, red_pepper.jpg. And we're going to make it a vegetable. Okay. Close the parentheses, semicolon, and there we go. We inserted 1 item into our database. The 0 means we didn't update anything. All we did was insert. So this is kind of a weird syntax. Why is it done this way? Well, we can actually comma separate these values, and we can insert multiple values at a time. So we can insert like 10 rows at a time, and we'll do that here in just a second. And then here, we're just telling it the order that we're going to put these things in. Notice that title was the first one, image was the second one, type was the third one, right? We can reorganize that. There's no sacred order here. So I could have image first, as long as I put redpepper.jpg first, right? And that is 99% of what inserting is into. You just do insert into, you tell it the table, you tell it the order that you're going to give it things, and then you give it the values. The end. So let's talk just a moment about single quotes, double quotes. This was confusing for me as a JavaScript developer, where it makes literally no difference, right? It does make a difference when it comes to SQL. So let's do this again. We're going to say insert into ingredients. Here, we can use double quotes. So I can say title in double quotes, I can say image in double quotes, and I can leave it off for type if I feel like it, right? This is letting it know it's the actual name of the column, right? So we're actually, I could even put ingredients in quotes. Let's do that. Anyway, you can put ingredients in quotes as well because it's the name of the table, right? So it's the identifiers that you can put into the double quotes. But notice here I'm doing it, here I'm not. It's optional, and frequently I don't. Almost never do I. And then here, again, because it's the literal value that I'm putting in here, I have to use single quotes. Broccoli, broccoli.jpg, and it is, I'm pretty sure it's a vegetable. Okay. So another thing to note here is that white space is not significant. Notice I'm just putting things on new lines, and I'm putting, if you read my notes, there's tabs everywhere. White space is not significant in SQL. You can put infinite space in there and it doesn't care.
Since type is a keyword, is there an issue having that as a column name?
It's a good question. Since type is a keyword, like you'll notice in my some of my highlighting, it'll show up as highlighted. It's not, right? You can see here in this particular case, there are things I think that are off limits for column names, but I think most of it is pretty fair game because it's usually unambiguous in the grammar of SQL. But yeah, people, I'm sure someone might take exception that I called it type, but I've called lots of stuff type in my career, so here we are.
So do you put single quotes no matter the value type, even if it's like a number?
So that's a good question. No, it's just for a string, the string types, yeah. So if I wanted to put like 5 there, I would just put the actual number 5, because if you put the quotes around it, it becomes a string, right? That's a good thing to point out. Good question. To do comments in SQL, so this will actually fail because we have a unique constraint. But notice here, I had the dash dash here. This is how you do comments in SQL, is the dash dash. Anything that comes after the dash dash is commented. And again here, right? This should fail, right? Because it's going to say this title key here, broccoli, we put a unique constraint on that so that the title is unique for that particular table. So it failed to insert that because I tried to insert it again because it's already in there, right? One of the things I like about Postgres is I think it has, for the most part, pretty useful errors, right? Key title equals broccoli already exists. That lets me know right away you violated the constraint around having unique titles. You can name these ingredients title keys, right? If I say it's -d, you can see, or maybe here if I do ingredients, you can see that this has an index on the title key. We'll talk about indexes in a bit, but you can actually name these whatever you want. But if you don't name them, it has really useful, sane default names for them. So I generally don't name them because I like the names that I would be typing out those names anyway, so I just let them name it for me. But if you see P key, that's another common one that you'll see here, stands for primary key.
Are tables stored like B trees?
Our tables are not stored as B trees. Indexes are stored as B trees sometimes. We will talk about that when we get to indexes. The actual physical manifestation of how Postgres stores them, I actually don't know, but it would not be a B tree. So I want to put a bunch of stuff in our table, and I don't want to type it all out. So you and I are going to copy this query right here. Yeah, right there. Feel free to copy and paste, too much typing. Okay, now if I paste this in here, it might get a little mangled because it might be too long for you can see that right here, it's kind of mangled there. It's fine, it's just my terminal is not emulating it correctly. If I hit enter, you can see that I had 29, that inserted correctly. The only interesting thing here is one, you can see here we're just comma separating all these values out, right? But the interesting thing here is on conflict do nothing. Or let's go look over here because it's probably easier to see. I had, for example, broccoli was in there already, and red pepper was in there already, right? That would have been a conflict because it's like, hey, you're trying to insert the title key again here. So basically on conflict do nothing is saying, if you hit any of these rows that you won't let me insert, just drop it. I don't care, just keep going, right? So I could actually potentially just run this again, and it's going to insert 0, but it's not going to crash, right? Whereas if I did it again, and I delete the on conflict part, and I just, is that correct? No, it's not. So we're just going to copy and paste to here. You can always hit Control-C, and that'll escape whatever query you're in the middle of. Now I do that again. So because I didn't put the on conflict do nothing here, it's going to immediately fail, and then nothing gets inserted, right? So you have to tell it what to do on conflicts. It's good if you're doing like massive inserts or like you're seeding a database with a bunch of information to give it those kind of on conflict things. Otherwise, if you have one error, everything crashes. So I just wanted to show you a different way of, or something else you can do with that on conflict. If I say insert into ingredients, and I say title, image, value, values, I say watermelon, you can see there that watermelon definitely already exists. And I want to give it the image of banana because I I don't live by the rules. And then I can say something of the type here, but I can just say this won't be updated. So you might wonder, why am I putting 2 quotes there? This is how you escape single quotes inside of the values, right? Because we can only use single quotes, we need some way of saying, like, what happens if I actually want a single quote inside of my query. The way you do that, it's not with backslash, which is what I was used to with literally everything else. In SQL, it's you put 2 single quotes next to each other. Okay, this won't work, right? I can actually just run it as is, and it's going to say, oh, it's not value, it's type. Okay, you can't put watermelon in here. I already have a watermelon. Heck off. I'm not going to allow you to do this. What if I want to say, if this doesn't exist, insert it. If it does exist, update it, right? So watermelon exists. What if I just want to update it? This is where onConflict comes in is helpful again. OnConflict, you have to tell it on what sort of conflict, in this case title. Then you're going to say do update set image equals excluded dot image. So imagine if I have 50 of these, right? And I wanted to just update it if it has some sort of conflict there. That's what the excluded dot image is. The excluded means the row that got excluded, and then I want you to pull the image off, and I want you to set the image on whatever one that conflicted on title. So just to prove my point from you, again, we'll talk about selects here in just a second. Select star from ingredients, where title equals watermelon. You can see there it did update it. I don't have 2 rows in here. I have just 1, and the one got updated. You will typically hear this referred to as an upsert, right? It's an update and an insert in one step. If you're doing something like MongoDB, they actually literally call it upsert, right? That's the name of the method that you use. In SQL, you're going to do this onConflict business. So if I come back and do this again, what happens? You can also just say that this would just get set to some string as well, right? And now if I do this, let's say I had 500 conflicts, right? All of them would get set to default.jpg instead of actually going and updating it. Updates and deletes. We saw an upsert. Let's just do a normal old update now. So I'm going to say update ingredients set image equal to watermelon.jpg, or we can go back to, I don't know, we'll call it strawberry, I guess. .jpg, where title equals watermelon. You can see there it did an update. So now if I say select star from, I can just do this again. In case it's unclear, you can hit up. It'll scroll backwards through the queries that you've done before, which is what I'm doing. Okay. So I've done this update here. You just say set whatever do you want, and then you give it a where clause to define which one. If I didn't give it a where clause, it would update literally every single one, right? Which might be what you're trying to do, right? You might want literally everything to have a picture of a strawberry. You have a weird recipe app, in my opinion, at that point, but it's possible, right? What if you want to see what you're doing, right? And this actually works on the inserts, this works on the deletes. What if you want to see what the result of your works are after you've done them? So we can say update ingredients, set image equal to watermelon.jpg, where title equals watermelon. And then I'm going to say returning And you can just ask for whatever you want back, right? In this case, I want back the title, the image, and the ID, and the type, right? So not only am I updating it, right? This is an update command, right? It's not a select command. But by saying returning this as like, hey, once you've done everything, give me back everything that you updated. I'm sure you can imagine this being useful. Like, let's say you're updating a user's profile. You want to confirm to the user that's like, hey, you set your new picture and you told me that you now live in Minneapolis instead of Seattle. So I'm going to update the database and ask for the new information back so that I can send that back down to the user to confirm to them, your stuff actually changed, I promise, I did it. So that's what the returning does. Now, this is kind of a burdensome thing to say. Let's say I literally just want to get everything back. That's what the star is for. So I can actually just say return star, which just means everything, right? Notice this one, it gave me back everything in the order that I asked for it, title, image, ID, type. This one will give it back to you, I think it's generally in the order that you created it, but I don't think you're guaranteed. So let's do another insert really quick. I want to show you that you can delete multiple things with one query. So we can even copy and paste this one directly out of it because there's nothing really new here. Let's scroll down and copy this one here. That one. So insert into ingredients, title image, not real one, delete.jpg, delete 2. That's actually, I think it's going to error because, oh, it's not, which is fine. Yep, okay. So we did look up what this 0 is. It's always going to be 0. So in modern Postgres, which is I think post 9, this will always return 0. It used to be like an identifier for object IDs, which they don't use anymore, but there's enough stuff that depends on that 0 being there or that number being there that they're kind of constricted by backwards compatibility for that always to be there. So in other words, ignore it. The second number is the only one that you care about. So now I have two titles, or I have two images where the image is delete.jpg, and I want to delete both of these with one query. So I can say delete from ingredients where image equals delete.jpg. For fun, let's just say I want to return all of them as well. Again, this returning part's optional. It's only if you want to see what was actually deleted. So now I had ID 100 and ID 101, title, image, type, vegetable. So again, that default vegetable is coming from our constraint here from \d ingredients. So this one has a default here of vegetable. If you didn't delete and recreate the table with me, you probably didn't get this default. In which case this first insert might have not worked. In which case you would just have to go back and add not real, and then you'd have to add another type here of vegetable or meat or something like that. But if you did add the default constraint, then it would work. So just to kind of show you what that would look like, I'm going to put, doesn't matter because we have no constraint on it for it to be valid. And then here you would have to put type. Okay, insert it again, and then we can do the same delete from returning star. And you can see here, notice that we're inserting and deleting here. Here was 100 and 101. This is 102 and 103. It did not reuse those old IDs, right? It's just continuing to increment. So if you delete something, that unique identifier is gone forever. I don't know about you, but like I feel like weird about deleting something and it's like never going to come back. I don't know why I get like nostalgic for that. I don't know if nostalgia is the right word for it. Attached? I don't know. I probably should ask a therapist about that. Like, the object permanence of unique identifiers in the universe. I feel bad for GUIDs that never are going to exist again. It's just therapy with Brian now. Anyway, so the delete froms are really similar to updates. We just don't have a set in there, right? All you're doing is just you're identifying where you're deleting from. You're giving it some where clause to say like delete these things, so you can kind of pick the things that you delete, and then you can return them if you're interested in seeing what you deleted. Otherwise, it'll just show you the number of delete to, right? Let's talk about select. I decided to go kind of out of order. Most people learn select first, and then they learn how these other things that I've been teaching you. But I wanted to show you how to construct data and model data before we started looking at data, right? So now we're actually going to start looking at the data. The most classic of them all is select star from whatever table you're looking at. And this is going to give you literally everything back in the table. If you had 10,000 columns in your table, this will give you back 10,000 rows. You can see my computer can't even show them all at once. But that is what this did, right? And so you can see everything that we've inserted in here. You can see it does skip some numbers here and there because that's stuff that we removed or deleted it or something like that. But here we are, and we have a bunch of various different ingredients. So select, you're telling it what you want to, you're going to pull things out of the database. Select does not update anything. All it does is pull data out. It just reads, right? Star is everything. Give me all of the columns. From, you're asking from what table you want it to come from, and you're telling it you want it from in the ingredients table. So that is it. What if I only need to see the title and the type? So notice there's no ID here and there's no image. I'm going to recommend that in general for your code, right? I'm talking about for like your JavaScript or Python or Ruby applications, you should specify what you want and don't just do star. Star is lazy. And it makes it more intentional that later when you come back to read your code that you know I was asking for these specific things. You're being very intentional and kind of self-documenting in your code that you're asking for specific things rather than just give me everything. On a side benefit, it is slightly smaller payloads going back and forth between your application and your database. It's a little less processing of what's going in and out. Not really the point. It's so menial and small for the most part that you don't really care. The bigger advantage is that you're being more intentional with your code. So if my JavaScript application just needs a list of types and titles but does not need the images, don't do the star, just do select title and type from ingredients. I'm asking that as your potential future coworker to help me out there. What if I only want 10 things instead of everything, which is generally the case as well? If you have, I mean, can you imagine trying to do like select star from Facebook's user table or something like that? It would crash all the servers, right? Literally billions of rows. So add yourself a little limit there, and that'll give you back however many things that you asked for. So I asked for 10 things, so this will give me back only 10 things, right? You can see there are 10 rows. That's a little bit better than a billion rows, right? So whenever you're doing selects, unless you really know that there's not going to be very many things, or unless you're intentionally trying to get everything out of a database, you are basically always going to have a limit. So I have the first 10 things. What if I want the next 10 things? Well, offset 10. So that now gives me the next 10 things. And if I want the next things, offset 20. And then so on and so forth. Eventually, it'll get to the last one. You can see we only have one in this. So even though I said limit 10, it's like I don't have 10 to give you, right? So you just get one. Now, what is a problem with this? Let's say like this is called pagination, right? I'm paging through my data. So a user queries my page like this, right? And they they're seeing all of these ingredients, and then let's say we have a problem and we decide to delete black pepper, right? So I delete from database black pepper. They then ask for the second thing. All of these rows have now shifted up. So what happens? Pineapple is actually going to come into here, right? Because there's one less row here, because I asked for, and then the offset is precluding that, right? So basically, the user is never ever going to see pineapple, which is kind of weird, right? Now, if we're talking about ingredients, it's probably not the end of the world that they skipped an ingredient, right? I don't know, actually, it might be, but I would imagine in most cases it's probably okay. So this is the dangers of offset. And there's kind of a dual danger as well. The first of all is that if you're paging through it, you might miss things because things are being inserted and deleted and things like that. So, and actually a better way of doing this sort of pagination is to use these IDs, right? So rather than say offset 20, I could actually just give it a where ID is greater than 32. Or let's do it after 23. Right, now if I delete something or something like that, we're anchoring on a row in the table rather than anchoring on some sort of offset. So if you're paging through data in your particular service, this is a better way. It's also way more performant, because think about it. If you ask for, give me 100 rows and give me an offset of 1,000, your database has to go organize it. It has to count 1,000, and then it gives you the next 100, right? If you keep doing that over and over and over again, it gets kind of expensive. Whereas if you're just saying, hey, give me everything bigger than this ID, it can just go right to that ID and then give you everything after that. Ends up being a lot more performant. So it's an optimization. You don't always have to do it. For our application that we do today, feel free to use offset. I just want you to know that that's a way better way of paging through data. Yeah.
So with PostgreSQL databases, people tend to use just numeric IDs versus like Mongo, it's this big like hash.
Yeah, it's a good question. SQL databases always in general, they're just numbers. And these numbers might get to be, 100 million or a billion or something like that. Like, I imagine your checking account ID, like with your bank, is probably their primary key in their Oracle database, right? That's probably where they get that, right? Whereas something like Mongo or some other databases, they give you like objects. It's not really a concept here of that sort of thing in SQL. It's going to be a number.
It's more like a UUID or something like that.
Yeah, exactly. There's probably other ways of doing it, but it's almost always just an integer identifier. There are instances where you don't need an integer primary key, and I will show you that once we get into joins. Basically, you'll end up having some sort of like other thing be a primary key, and then you will not have a use for an incrementing ID. But I can't think of a reason why I would like use a hash or something like that. That wouldn't make any sense to me. The ID would make a lot more sense. And the reason why I say that is like you want to join things between tables and things like that. It's way easier to deal with integers just mentally, and SQL is built for it, so there's no reason not to. Maybe stated a little bit differently from a Mongo perspective. Mongo, you really never want to do joins. And this is not a Mongo course, so we're not going to get too much into it. But you don't have two collections and then you try and join them together. If you're doing that, you're doing Mongo wrong for the most part. It's possible. It's expensive. SQL, you're going to do joins everywhere because SQL it's a relational database. What was it? RDBMS, Relational Database Management System. RDBMS is what people call these style of databases. It's literally built into the name that these are supposed to be relational, which means those keys are supposed to line up, which means it makes sense for those to be integer numbers. We did limit, we did offset, and I kind of hinted at the next thing that we're going to talk about, which is where. So we can give it clauses where like I only want to select specific kinds of things. So if I say select ID, title, wow, that was mangled, title, type, from ingredients, where, and I can say where type equals fruit. Oh, I put an extra comma there. Don't put the extra comma. This where is just basically like, hey, make sure that this where clause holds true, right? You're giving it some sort of conditional to filter on. There's a bunch of stuff you can do. I showed you, you can do like where, you can do numbers, right? Where numbers greater than, you could put greater than or equal. We can also say, like, let's say we want to, select everything that's not a fruit. This little symbol right there where it's just angle brackets put together means not equal. So now I'm getting everything that's not a fruit, vegetables, meats, others, those kinds of things. I can do things like select star from ingredients, where ID is less than or equal to 10. You can also put and, right? Or. We'll do and right now. ID is greater than 20, and then limit 10, right? So this is going to give you everything. Well, that's not what I wanted to do, rather. I wanted to do this. Or did I do that the wrong way? I did it the wrong way, didn't I? From ingredients where ID is greater than or equal to 10 or less than or equal to 12. Not like that. There we go. So this will now limit everything that I get between these numbers, right? So that's what these ands, both of these have to hold true. You can also put or in here. Right? So now this is giving me anything that's outside of those limits. Anyway, I had these all right in here. I don't know about you, but I always have to think about the alligator and like which one's greater than or equal to, and I have to like check 5 times. But I got it right here. There we go. So here I'm asking for where the ID is outside of the range of 10 to 20, right? Inclusive of those, right? So you can see this goes 1, 2, 3, 4, 5, 6, 7, 8, 10, and then it skips everything 10 to 20 because that's what this OR does here. And then, so there's a bunch of other like conditions you can do there. We're gonna like look at fuzzy text search and some other things like that here in a little bit. But just know that like it's not just like equals or less than or equals. There are others as well. Last one I wanted to show you here is select star from ingredients, where let's say limit 10 here for just a second. By default, these are generally going to be ordered by ID because that's going to be generally the order that they were inserted into. But just know, according to the SQL spec, it's not required to give you back anything in any order, right? Generally, it's going to give it back to you in the order of insertion, but that's actually not required, and you probably shouldn't rely on it in your application. If you care about order, you need to provide a order by. So in this case, order by ID would get you that same thing, but let's say you wanted it in descending order. So now it's 33, 32, 31, right? And it's giving you back in reverse order. That's what that desk means, descending, right? Just so you know, you can put ask in there, ascending, but that's actually just the default. It's just optional if that's important to you to be specific. But you can also put order by title in there, right? So now it's going to give it back to you in alphabetical order. Likewise, order by title, descending, it'll give you back watermelon, tomato, sugar, strawberry in that order as well. In other words, if you care about order, you should provide order, because while Postgres is generally consistent, it doesn't have to be. Okay, questions about order by? Yeah, Dustin.
Do you have any preference between the CLI or some kind of SQL client when you're working with an SQL database?
It's a good question. Do I prefer using the command line, or do I use something like, the other option would be pgadmin, which we will see in the second half of the course. I almost always use PSQL because I just always have. It's what I learned on, it's what I continue doing. It's not a good reason, but it's just my reason. There's other people that grew up using things like pgadmin or PHP myadmin for like MySQL. Also very common. And I think JetBrains has like a really good SQL client as well. I can't remember what it's called. There's like VS Code or VS extensions for querying databases that are like visual. I like writing queries and seeing the results, so this is what I do. But sometimes it's really useful to take that data and like make graphs out of it and stuff like that, and things like a client, some sort of GUI can help with that. Obviously, this doesn't help you with graphs, right? So you can also generate like CSVs and put that in Excel, and then Excel can generate graphs for you. I've done that a bunch, but I'm just used to doing it this way. We are going to talk about functions, and we're going to look at some text search. So the section we're on here is like and functions under the data section. So imagine you're writing something where people can like search for stuff, right? Imagine you're writing it so like someone can type a little text string, and then it's going to go search your database to find things like that. If someone searched for POTA, you would expect that to show up potatoes, right? I think that's pretty reasonable. So let's write that query. Select star from ingredients where title equals POTA. As you might guess, that doesn't work, right? Why? Well, nothing equals potatoes, right? Like it's actually doing like a full equality check. We need something that's a little bit more fuzzy, right? So the way that we can do that is with something called like. So you can say where title, instead of saying equals, you're going to say like. And then you have to say, where is it like, right? So if you want to search for everything where it's just like it ends in POTA, you would do this. You'd put the % here, and then it would give you anything that ends in POTA. Obviously, that's not anything. So if we put it here, that means that POTA shows up somewhere in the string, right? And there you go. This would also match this, right? Because it does actually start with POTA. And that is what like does. Like basically says like this is going to show up somewhere in here, and I'll give you some sort of pattern to match. And again, this won't show up anything because you're not giving it any space. Now there's still a problem with this. If I do capital P, like this. This capital is kind of making it mess up because of this, right? It's not matching that P. There's a couple options here of what things you can do. We could do something like so lower is a function that's going to take everything in title and make it lowercase, right? Same thing, you could do upper, and then you just have to make sure that your search string contained uppercase characters, and that would also work as well. That totally works. That's very okay, but there's actually a lot easier way to do that. You can just say I like, which is insensitive like, right? And then you get this, it works just fine. It doesn't matter we can make this all sorts of weird things. So that's actually what you're going to do. I wanted to show you how to use a built-in function because those end up being pretty important. In fact, we're going to use another one here in just a second. So, all right, we're writing our text box that people can search for stuff. If someone searches for fruit, would you expect cherry to show up? Probably, right? It's very reasonable someone would search for fruit and expect cherry to show up. So how would we do that? The type does not exist in the title, so how do we search across multiple different columns? A bunch of ways to do it, but I'm going to show you one of the most straightforward ways. Select stars from ingredients, where, and then we're going to use this concat function, and we're going to do title and type. And then we're going to say I like fruit. And there you go. This will search across all these, and because fruit shows up in the type, these are all showing up despite the fact that they don't show up in the title. And concat is exactly what you expect it to be. It's just taking two strings and shoving them together. Now let me show you why this ends up being a little weird. It literally is just putting strings together, right? So what happens if I search for something like RRYFRU? Well, you're going to get all the berries because the RRY and the FRU get pushed together and it's matching that string, right? Now, for the most part, if someone's searching for RRY, FRU, what the hell are they looking for, right? I don't know. You might as well give them something. But that is a little bit strange, so you have to be kind of aware that that's a little bit strange. And I did want to show you that you can use multiple of these together, right? That does work, and then you can do except yeah, we're doing lower, so that's why that doesn't match. But you can do multiple of those functions, and there's a bunch of those built-in functions to Postgres. Most of the things that you expect coming from like JavaScript and stuff like that exist. Like I think like now is one of them where you can actually get like the time it is right now. There's a bunch of them. And that's kind of a fun little trick that you can do with some of these built-in functions. You can select lower, it'll actually give you the results of some of these if you want to try them out. You just do select and then whatever you want to try. Yeah, and so I did leave you a link here in the docs. There's a ton of functions and operators to do here. We are not even going to like scratch the surface on how many of them there are. I think we're going to do coalesce here in a little bit because that one's really useful. But I showed you like now. You can do like regular expressions if you're feeling like you want to go in crazy. Like there's a lot of stuff you can do. Exists, that's another one. There's like arrays and such. But not the point. We're not going to go too much into those today. Just want you to know that they are there. Wanted to show you, so far let's look at I showed you the percentages, which basically means it matches 0 to many things, right? So for example, if I put POTA, on the front side of this is going to match 0 characters, right? On the back side of this is going to match a lot of characters. So it's 0 to many characters. What happens if I want to match exactly one character? That's what this underscore does. It matches precisely one character. So if there was a churi in here or something like that, it would also match that. But the underscore there will match exactly one character. So again, to drive that home, if you want to do like berry, this will match all berries, right? But this wouldn't match any of them because there's no A berry or B berry or something like that, right? So, and then again, using those built-in functions, you can actually get into full regular expressions if you want to, but we're not going to get into that because I do not want to do regular expressions. Now I'm going to give you a little project to do. The project's in Node.js, but I've done most of the Node.js programming for you, so you really just have to focus on the query parts of this, and ultimately I give you the answers as well, so don't feel too stressed out if you don't know what's going on. We're going to be using the PG package today. I linked you to the docs, which is node-postgres. This is the most common connector between Node.js and Postgres. There are others. You're welcome to choose whatever you want, but just to show you, it is like by far the most used, right? This top green line is how many times this is installed per day, which is on the order of 3.5 million times per day. So it's pretty common. One of the reasons I continue to use PG is it's just the one that I've always used, right? And the other thing is that it gives you access to the underlying query language, so I can actually write my own queries to go out to Postgres. Everything else is going to be more, well, not say everything else, but many other things are more ORMs, which are object relation managers. That sounds right to me, so I'm going to go with it. I don't remember.
Mapper, I think.
Huh?
Object relational mapper.
There you go. Object relational mapper. That sounds better. Basically, like you define a bunch of like configurations, and then it generates queries for you. I prefer to write the queries myself, but that is up to you. In any case, this is a SQL class, so you have to write the queries. So I'm just going to give you a tiny overview of Postgres or Node Postgres. This is mostly just so you can do okay in this part of the class. PG has two ways to connect to the database, a client and a pool. Today, I would invite you to use a pool. The primary difference is a client is one atomic connection to the database. So if I connect a client to the database, I have exactly one connection that I'm writing queries back and forth with and getting results with. And then as soon as I'm done, I close it and the entire connection is closed. A pool is something more that you'd use with a web service where you request a client from the pool, it gives you back a client, and then it'll put that client back into the pool, and it will not disconnect that client necessarily. It could. The reason why that's useful is imagine you have a web service that's doing 100 requests per second. The act of opening a client, connecting to it, handshaking, giving the credentials, establishing SSL, all those kind of different things, it's expensive to open and close those connections continually. So what the pool does is it recycles those connections between different requests so that it doesn't have to continually open and close sessions. You don't really have to care too much. Basically, you just have to do this. You require PG, and you make a new pool. You give it the username, the host, the database, and whatever port that you're going out on. But I'm pretty sure you could replace pool here with client, and I think it would still work exactly the same way. You would just have one client instead of many. Rule of thumb here basically is if you're writing a script where you're just like making a bunch of requests and then being done with it, use a client. If you're writing web services where it's going to be like long-lived and there's going to be many things making connections, use a pool. Or if you want something even simpler than that, just generally use pools. You can just kind of always use pools and be fine. Okay. So as long as you're following along, this will be the correct code here to connect you to a database from Node. Here I could just kind of give you some troubleshooting advice. Make sure the credentials are the same. Make sure that your Docker container is running. Make sure the port is exposed. Make sure all of your data is in there. Okay, and then this is how you actually are going to end up making a query to Postgres. So you're going to say await, because this gives you back a promise. The await will actually wait for the promise to finish, right? pool.query, and then whatever you want to send to the database here. You don't have to give it the semicolon. It will insert the semicolon for you. And then rows will be whatever you got back from the database. There's other metadata that it'll give you back from the database. This object that it gives you back has a lot of stuff. For the purposes of our course, I think all you're going to need is rows. This can be literally anything right here. Like this is going to be the raw query that gets sent to the database. Okay, I wanted to talk just a brief moment about SQL injection, because it's now that we're doing web services and dealing with user data, this is where SQL injection becomes a problem. You don't want to get hacked, right? That's kind of the gist of SQL injection. I would say SQL injection is probably, I think it's fair to say it's the most common way you get hacked. So let's say I have this query right here. Select star from ingredients where ID equals ID, and I'm getting the ID from the request query, right? So basically I'm selecting something from the ingredients table, and the user is providing me with the ID to do that. Why is this query such a bad idea? I'm passing this ID raw in from the user directly into the ID, which means the user can put anything there. Anything that will go directly into my query to my database. This is very, very bad. Because what happens if they put in this? What it would be running in your and do not run this. Well, I guess it wouldn't work, so it doesn't matter. But this is what it would actually get run against your database. Select star from ingredients where ID equals 1, colon, finish first query, second query, drop table users. This would drop your users table, right? And you would lose a ton of data. This is called SQL injection, right? And then the dash dash here, imagine I had other things after this, like a limit of 5, offset 10, right? It would comment everything out so the query wouldn't fail. This is just one way they could hack it that's destructive, right? They could destroy my database this way, but they could also write a second select query in here and then have that return from your database, or they could like add themselves as an admin. They could do a bunch of stuff that would be really harmful to your database. Again, this is called SQL injection. Have you ever seen the XKCD comic of Little Bobby Tables? This is where that joke comes from. So, did you really name your son Robert Drop Table Students? Right, because that would get input into their system and that would drop their database anytime that it got ran, right? We've lost your students, right? I hope you're happy, and I hope you've learned to sanitize your database inputs. I did not name my son Little Bobby Tables. Anyway, that's where that joke comes from. So, how do we make sure that that doesn't happen? How do we sanitize our inputs from our users? Node Postgres, the client that will do this for you as long as you use it correctly. So here I say await pool query, and then here I put this $1 where I'm going to put the user input, right? And then I just give it to it in order. In this case, I'm just giving it the ID. And then Node Postgres will take care of all the sanitization for you. You can just trust Node Postgres. So if I was putting like 3 things in here, I'd have $1, $2, $3, and then I would just put those here in order in this array that I passed to pool.query. I put this one in here just because this tripped me up when I was doing this app, so I wanted to clue you in on it. So if you need to put like the percentage signs in here, because you're doing like the kind of the fuzzy search there, you put it in here, right, inside of where you don't put it inside the $, because the percentage $1 percentage wouldn't work. So you have to put it into the array. So it would look like this. So you might have to do some string concatenation into what gets sanitized, is what I'm saying. So there is a repo here that I'm going to need you to go clone. It's called SQL Apps. And I'm going to give you just a little tour quickly of it. There are two different parts of the project. We're just doing the ingredients now, then we'll do a little bit more, and then we'll do the recipes one later. But for now, you can just worry about ingredients, okay? Click on that. There's a couple files in here. There's an index.html that basically sets up a bunch of stuff. There's a client-side JS. You don't have to touch this one at all. I did all of the client-side work for you. But basically, it's just adding and removing event listeners, and it's setting up some like nice kind of carousels. Everything that you are going to write for this particular exercise is just in API.js. This is all using Express. I just did it because that was the simplest thing, and I imagine that's one that there's the highest probability that you're familiar with. There's this part here where it says student code starts here, and then there's a part where it says student code ends here. So everything you have to modify is between these two comments. And I kind of left you comments of what I expect you to do here to make everything work. And then you'll have to delete these like res status 501 things, because 501 means it's not implemented. You're going to have to turn these into 200s. Basically, you're going to have to write a part where you connect to Postgres. You're going to have to write a part where you return all ingredients of a type, and the type here is coming in from the query. And then you're going to have to write a part where you do a search on some sort of term and some sort of page, right? So you can return 5 rows at a time of page 1, page 0, page 2, page 3, so on and so forth. Okay, so let me just show you a little bit how to get started here. I'm going to open a new tab here. Okay, I'm going to open this in code. So I've already cloned this repo from GitHub. And I'm going to open API.js from ingredients. So the same thing that you should be seeing here. Right there, API.js. Okay. This is all the code that you're going to write. There is, if you get lost or you want to see how I did it, I have the completed project inside of the completed folder. So you can look here, inside of ingredients, there's another API.js. That is the code that I wrote, and everything works, as long as your database is working, right, and it has data in it. There's no cheating on this. This is just a project. Whatever you need to do to learn, do that. If you want to look immediately at the code and you feel like that's the best way you're going to learn, then do that. I don't care. I care that you learn. In my opinion, the best way to learn, the way that I learn, is I take a crack at it and I hit the wall and I struggle and I learn a bunch of things, and then I go look at the solution. But if that's not how it's going to work for you, it's better than getting discouraged, right? If you're going to get discouraged, then just look at the answer. Okay? So if you're not familiar, the first thing you're going to do when you clone this, you're going to say npm install, just like that. It'll go install a few packages. Express, you don't even need image downloader, but it's there. PG, and then node daemon and prettier. Okay, and then you're just going to run npm run dev. Okay, this is going to run like a little watcher in the background, so every time that you save a file, it'll restart the server for you, so you don't have to do that yourself. And then you can just open this in localhost 3000. You should get a site that looks like this. Okay, you should click on ingredients. It should be relatively empty, right, because none of it's working. But if you click on answers, you should see something. This is your end goal of what you want it to make it look like. This is what it will look like once you have all of the things populating. So this is populating all the fruits. This is populating all the vegetables. You can see that they have little tags on them that identify what types they are. Okay, it's pulling all the images correctly from the images. Notice that, like, if this one, I don't have very many meat things in here, so it loops it back around. And there's a lot of other ones. Or there was. Oh no, we don't have that yet, which is fine. Okay, and then down here you have all the search ingredients. This will go through all of them. And then you can search for things like berry, and you'll get all of the berries. And then you can ignore recipes. We're going to do recipes in the next project, not this one. Some additional troubleshooting tips for people that are having issues just getting anything to work. The first one that one of the students did was they did all of their operations in the Postgres database and not the Recipe Guru database, which would be problematic because all of your data would be in the wrong database, and we'd be trying to query from something that didn't work. The way you can kind of diagnose that happened, if you go to your terminal, and here it should say Recipe Guru here wherever you've been doing all of your querying, and if I do /d where it says Recipe Guru, you can see I have my ingredients table. If it says Postgres right here, you're in the wrong database. So the way you connect to a different database, /c Recipe Guru, right? And now if you hit -d, if you do not see this ingredients, then you have to go and recreate everything here. Or for the sake of just this exercise, you can replace where it says Recipe Guru right here in database, you can just put Postgres there, and that'll connect you to that database, right? Either one of those will work. If you're this far and you've made all the tables and stuff like that, I probably would just go and replace this with Postgres. It's fine, and that would work. Another thing that I saw another student do is the port was blocked either from running a previous version of Postgres, or maybe you have some sort of corporate firewall that's not allowing you to host local ports. The way that you can tell if the ports are messed up, if you go to localhost 5432, which is the default port that Postgres is running on, the one that we have it running on, it should say connection was reset or error empty response. Chrome will say empty response. Do I have Chrome up here that I can show you? Yeah. Localhost didn't send any data, error empty response. This is opposed to if you see this is correct. This is what it should show. If you see something like this, where it says the site can't be reached and localhost refused to connect, that means that that port is not open and it's not exposed, right? Which means that you need to go figure out there's something amiss with your ports. The way that you might diagnose or fix that is maybe you didn't open the port in Docker, or you might have a corporate policy on your computer that doesn't work, or you might have to shut down like a different version of Postgres that might be running in the background. Those are all possible reasons. And again, what that looks like in Firefox here, it'll say unable to connect. If it says that, then you have a port problem. If it says connection was reset, that means it's working, it's fine, everything's working the way you think it should. Let's pop over to our code here in ingredients. I'm going to close this for a little bit. First thing here, where we connect to Postgres, we're going to say const pg equals require pg. Const pool equals new pg.pool. User Postgres host localhost database. Whatever you called your database, that could be Postgres, that could be, it should be Recipe Guru if you've been following along. Password is whatever you set the password as. I put mine as LOL because I'm a child. And port 5432, because that is the default port for Postgres. Okay, this will connect us to the database now, and we'll now have a pool that we can use. So whenever someone calls type, we want to return to them the ingredients of that specific type, right? So here we want to say const rows equals await pool.query something like select star from ingredients where type is equal to $1. Okay, and then here we're just going to provide type into the parameterized query here. await here is going to do the query. It'll pause the execution here, and then it'll wait for that rows to come back. So once that is back, then here we're going to say, instead of res.status 501, we'll do a 200. That's actually optional. You can actually just delete that because it does that by default. And then the status here, you can delete that because we don't actually need it. And then you can do rows here like that. Should work now. If we go back over to our Recipe Guru website, you can see so far this is working the way we expect it to. We have fruit, we have veggies, we have meat, and we have other. That all works. Your carousel won't work yet because the client-side code is erroring because that's how I wrote it. So let's make the other one work as well. So there's a bunch of ways that you could do this. I'm just going to show you how I did it. Delete that. We're going to say let where clause, say const params equals page times 5. So if page comes back as 0, that means you're on the 0th page. You want everything from 0 to the 5th or the 4th one, or it'll be the 5th one, but index 4, right? If it comes back with page 1, this will be 1 times 5, so it'll be 5. Offset will be 5, 10, 15, 20. Okay. If there's a search term, then I'm going to add my where clause equals to where concat, and I put title and type. If you just did title, that's fine. I'm searching across title and type. And then you're going to say I like $2. Okay. And then you're going to say params.push term. Again, it doesn't matter if $2 comes before $1 in the query, it's still going to go in the order that we tell it to, right? And then now I'm going to say let or const rows equals, rather, const rows equals await pool.query select star from ingredients, and then optionally I might need this where clause. So if they put a search term in there, then we want to filter by that like, right, this I like here. So we can do this where clause like this. If where clause is just an empty string, right, we can even put that here. Then this will just be nothing in white space, right, which is fine. So it'll either filter or not. And then we'll do offset $1, which is coming from this, right? And then we'll do limit 5. Okay, and then here we can get rid of this status, or you can put 200 there, up to you. Get rid of the status not implemented, and we can say rows like that. If you're not familiar with this rows like that, where I just have one, it's both the key and the value, right? Where I have the row key is going to be assigned rows that I get from right here. You can just do shorthand and make it rows like that. Okay, so if we go back over here and refresh, still getting a little bit of an error here. Did I crash my server? I did, probably. There is no one parameter. Yeah, Dustin?
Comment in the chat that no parameters are passed to pool.query.
That's correct. Thank you. So you have to pass in the params right there, or else it's going to crash, because it's trying to look for variables that you didn't provide to it. So now if I refresh, everything is coming in okay. And it's paging okay, which is great. So there's one more thing I kind of want to show you. We're kind of peeking ahead a little bit. Obviously, there are no more pages here, right? Because it only returned 1. So how do we know that if there are more pages or not? Well, we have to do something to kind of peek ahead in our query. So there's a whole section on window functions, but I'm going to show you really quickly how to do this. Select star, and then we're going to say count star int as total count. So what this is going to do is this is actually going to go and count how many rows total exist for this query. And it's going to return them as a number called total count. Let me just show you what that looks like. So if I refresh the page and I go to my network tab, and it crashed. Why did that crash? Yep, okay. Count star over parentheses colon colon int. Okay, not crashing. Network. I'm going to show you the results first, and then I'll explain to you why it happened that way. So we have this search. This is what's coming back from the API. Let's make this a little bit bigger. So this is our search one, the one that we were just implementing. You can see all the rows coming back here. ID1, red pepper, so this matches up to this one right here, right? Title, red pepper, we see that. Image, red pepper, we see that right there. Type vegetable, we see that right there. And then we have this count 31. That's how many total rows exist for this entire query that we have, right? And it's actually on every single one. Total count, total count, total count, right? And it's the same on every one of them. So this is what's called a window function that's selecting across rows. So there's a whole section on it, but the whole reason that we did that is so now if we paginate all of our information here, eventually it arrives to the last one, and it can know there's only 31 in this set, and we're way past that. I'm done, right? So that's called a window function. And just to prove to you that I'm not lying, we will explain that in depth here in window functions. We'll actually explain part of it as well here in aggregation, which we're about to do. But suffice to say, this part right here is counting how many results we have for that entire set. And it'll change, right? So going back here, if I type in berry, now we are too far away. Oh, did I crash now? I did. So this is fun. We're learning all the things now. My error here is that offset must not be negative. Neat.
In your solution for params.push in the where clause, you actually have the parentheses around the term rather than just pushing in term. You actually put in the like.
Oh yeah. Good point. Okay. So what you have to do here, which I have also not done correctly here, is you have to put in term like that, right? Which is what I was alluding to earlier with my note, that you have to wrap it yourself in the percentages. Okay, try that again.
Curious, if you just put % around the $1 in the query, would that still work?
No, which is why I specifically called it out there. So if you wanted to put it here, right?
$1 yeah, that's what I mean. That wouldn't work.
Pretty sure it doesn't work. Cool. So I wanted to show you search for Barry. Oh, did I? Now what did I do? Oh, you have to take these out again. All right, Barry. We get 3 berries there. And come on. Barry. Just to demonstrate to you, you look here at rows. Notice this count over, so the total count, it's only counting from that subquery, right? So including that where clause, there's only 3 rows that will be returned here. So that's what the window function does for you. Okay. So that was sufficiently fun and messy, which is, you know, all good code is worth being messy about. But I think we also kind of learned a couple. One of the things I really do like about Postgres is it gives you very good error messages. When something goes wrong, it's typically like, hey, you did something here and I don't get it, you should look at it, which usually is pretty close to leading you to a solution. So I'll frequently even say, like, you did this and you probably wanted to do this. Now we're going to talk about relationships and what happens when 2 tables love each other. So far, all of our queries have relatively been one-to-one. Not relatively, they've actually been one-to-one, right? Where I write a query and I get 1 row back for it. I look up something in a spreadsheet and I get 1 row back from it. That's kind of the methodology that we've been looking at. But now we're going to start thinking about recipes, right? A recipe contains ingredients. So you can think of something like a tomato. How many different recipes contain tomatoes, right? It's going to be on pizza, it'll be on spaghetti, it'll be in a BLT, right? So 1 tomato belongs to multiple recipes, right? But in the same direction, a recipe contains many ingredients, right? It's not that just 1 recipe is just a tomato. It's kind of a dumb recipe at that point, right? It has many ingredients in it. So a recipe has many ingredients. Ingredients belong to many recipes. This is called a many-to-many relationship. Does that make sense so far? You could also have a one-to-one relationship, though typically you wouldn't model that as multiple tables. Typically you would model that as just 1 table, right? Where a recipe has or let's say a ingredient has a type. It only has 1 type, so that's why we put it together in the same table. But in theory, those could be split into different tables if that made sense to you. We are going to talk now about a one-to-many relationship, which, let's think about a recipe, and a recipe has photos. It could have 0 photos, it could have 1 photo, it could have 15 photos. A photo is not going to belong to many recipes, though. A photo belongs to a single recipe, right? You can kind of think of this like an Instagram user, right? I don't post a picture and then someone else owns it, right? So there's no many-to-many relationship for photos. As a user, I post a photo, it is my photo, it only belongs to me. We're going to do the same kind of modeling for these recipes, that you have a recipe, it has many photos, and it belongs to 1 recipe. This is a one recipe, too many photos relationship. Well, how would you model this if you were doing a spreadsheet? Let's say I had a spreadsheet and I had ingredients in that spreadsheet, and I had 1 recipe that had 10 photos and I had another recipe that had 0 photos. Well, the way that you could model that in a spreadsheet is you would have 10 columns for photos, and then the one that has 0 photos just would have 0 things in those columns, and then the one that has 10 has 10. The problem is now every single row has this giant waste of space, right? You have to have a column for as many as the one with the most. It's wasteful. And it's confusing, to be honest with you. So the way that we can do this, thinking again in terms of recipe, is we can have a first spreadsheet that has just the recipes, and we can have a second table, a second spreadsheet that has just photos in it, and then we can use IDs to reference each other. So that's what we're going to do, is we're going to have two tables. We're going to have a recipe table, and we're going to have a recipe photos table, and then we're going to join them together. Let's go ahead and start a recipes table. Nothing here is unique or interesting to you, except maybe that we're using a text here for body, because bodies could be potentially very long, right? They're recipes, so that they could have, it could be a 1,000-word essay in here if we really wanted it to be. So we're going to use the unbound type of text. Okay, I'm going to come over here to my database, and I'm just going to paste that business, create table, recipes, recipe ID, integer, primary key, title, varchar, not null, and a body of text, which could be null, be kind of a dumb recipe, but here we are. Okay, I now have a table there, great. And nothing here is really rocket science. Let's go ahead and insert a few recipes into our little table here. So again, I'm just going to copy and paste these because I don't want to type all of that. Okay, so now I have star from recipes. You can see here I have 6 recipes. Pro tip, don't write a course while hungry. This is probably more for me than for you, but I got really hungry eating this course. I think literally the day that I wrote this, we ended up ordering dumplings because I really wanted some chow long bao. And if you haven't tried any of these foods, you should, especially any of these foods, you should definitely order those. Okay. So now we have a variable amount of photos per recipe, right? Imagine this is like all recipes or something like that, right? Where, users can post photos of their recipes, right? And we want to associate with that. How are we going to do that? We're going to create a second table called recipes photos. Again, this is going to have a photo ID, which is going to be a primary key. It's going to have a recipe ID, which is just going to be an integer. I know some of you are asking me right now, Brian, what about foreign keys? Just hold on to it. We're going to talk about in the next chapter. Again, we're going to do it the naive way first, and then I'm going to show you how to do it with foreign keys. Okay, create table recipe photos. Go ahead and do that for me right now as well. Just to show you, we have ingredients, we have recipes, and we have recipes photos. And then we have all of the IDs, which are, great. They're all there. Cool. And then now, we're going to insert a bunch of stuff into recipes photos. Okay, so copy and paste that. So select star from recipes photos. You can see here we have a bunch of IDs, photo IDs, and then recipe IDs, which obviously these are not unique because again, one, which is a cookie, right, can have multiple photos. It does. It has 5 photos. You have something like jollof rice, which just has 1. You have something like khachapuri that has 5, and then you have something like jiao long bao, which has nothing, right? It has no photos in here. That was ID 6. So let's say I have shakshuka, and I want to select all of the photos for shakshuka. So what I can do here is I can select star from recipes photos where ID equals 4. Sorry, where recipe ID equals 4. Cool. Good. Now, I was able to do that just because I happen to know off the top of my head what the ID is for shakshuka. Obviously, your code is not going to know that, right? You need to have some sort of way to query the first table for the shakshuka to grab its ID and to use that ID to query the second table. You could say that we need to join our data. You should say that because that's what we're going to do. Let's go ahead and do that. We're going to do that, and we're going to type that out so you can kind of see that happening in real time. So let's write this query together. We're going to say select, and we want to get the title, the body for all these recipes, and we also want to get all of its photos, right? So how are we going to do that? We're going to want to get the recipe title. So I'm going to say recipe.title, recipe.body, and photo.url from recipes photos. Recipes photos is the name of the table, right? And I'm going to give it a nickname just for this query as photo, right? So this corresponds to that. It's so I don't have to continually write out recipes photos. I can write something shorter. And actually after this, I'm just going to do single letter characters because it's just way faster, but we're going to be a little bit explicit for this first one. Okay, then we're going to do an inner join. Okay, we're going to inner join recipes recipe. So notice the first one I have an S, the second one I don't. Again, I just chose the name recipe. We have to tell it what to join on. We're going to tell it to join on photo.recipeid equals recipe.recipeid. So now you can see here I have a title, I have the body, and I have the URL for all of these photos. Empanada, all of these, right? So that's what the join does. It allows us to reach into tables from two different tables and get combined data back for both of them. Because there's more in the photo table, that's why you get multiple copies of cookies, right? Because there are multiple cookies one. So later in code, we'd have to go back and collapse those down into one thing before we sent it down on the API. And that's like 90% hit for at least inner joins. I would say most of the joins that I do are this inner join. We're literally about to talk about left join, right join, outer join, all of those kind of fun things. But inner join basically says like there should be a one-to-one matching, right? If there is a recipe with an ID in this one, there should be a corresponding one in the other table. And if it's lacking, don't include it. Notice there's no Chow Long Pao in here, Chow Long Bao, because it does not have any photos, right? Therefore, it is left out of the results set because there are no photos for it. Well, since we're already here and we have this, what if we wanted to include it? What would we do? It's in the from table, so you do a, nope, wrong one. See, this is the thing that I always get messed up on, left or right. It's right. So we do what's called a right join, which basically means that anything that exists in the recipe table, the recipe, oh, that's why. Anything that exists in the joining table, not the from table, the original table, I want to include anything that doesn't have a corresponding thing in the other table. You would do a right join to include things from the joining table, the right table. As you can see, I can never keep it straight in my head, so I normally have to do both to make sure I'm doing the correct one. But you can see here, now this is being included even though it doesn't have a photo to include. You can imagine this being useful if we're trying to include like a result set for all of our recipes, We want to include recipes that don't have photos. That's totally fine that they don't have photos. They should still be shown on the site, and we'll show some default thing. That's what a right join is useful for. If for some reason we had photos that didn't have recipes, then we would use left join, right? If you want to include both, I think it's full join, if I remember correctly. Not generally one that I think a lot about, but it's out there. Like I said, I think 95% of what I do is inner joins. The last 5, let's say 4.9% of it is left and right. And 0.1%, I'd have no idea what I'm doing. One thing that I didn't show you here, technically it's a right outer join. So you can actually include that outer there, but the word outer is optional, as opposed to inner join, right, which is only include the thing, everything that matches up. There you go. So I was right. It is a full outer join if you wanted to include everything. This is not going to be any different than our right outer join because there's nothing that exists in photos without recipes, because that wouldn't make any sense. We wouldn't have photos that don't have recipes. But if you did, full outer join would include both. In other words, full outer join is left plus right join, or left plus inner plus right, whatever you want to call that. So let's go look at, there's a really cool graphic I got from Wikipedia that's helpful to look at. This one right here. You can think of it like a Venn diagram. This is inner join, most of the time what you want between table A and table B. A right join includes everything in the middle plus everything that's not included in the left table but that exists in the right table. There's a left join here, and these top ones are most of what you're going to do most of the time. If for some reason you wanted to include, like you wanted to use a table to exclude something in there, like maybe you have like a user that has chosen to ignore a bunch of other users in their timeline, right? So you have this table that user A has ignored user B, C, and D, and you're trying to make their timeline. So what you would basically do is you do this right here, this right join, and then do a right A key is null, so you're just including the outer side of it. So you would exclude all of those people in the middle of the users that were ignored by user A, and get everyone for the rest of their timeline. That's how you would kind of do like that ignore list sort of pattern, right? Or deny list, or whatever you want to call it. Does that make sense? That's where you would use something like this. There's a full outer join where basically you can say like exclude everything where they overlap. This is the full outer join right here. We just looked at that rather, and vice versa there. So that's kind of the full possibility of joins. Again, this one's the most common. These two are a little bit more common. I fathomed the only example I can think of to do one of these, right? And yeah, cool. Any questions?
I'm still a little confused. So right join returns a bunch more stuff because it's the inner join plus what again?
So you're just saying, if you have a row that doesn't have something to match with it, what do you want to do? Do you want to include the right side? Do you want to include the left side? Do you want to include neither? Inner join is just include the inner part of the Venn diagram. Left and right is saying take from the left or take from the right, and then full is include everything.
And the left and right is basically the left side of the on or the right side of the on.
Left is going to be stuff from the from. Right is going to be stuff from the on.
Okay.
Yeah. But I have to check that every time because I can never remember. Usually I just run both queries and see what I want.
Is that opposite though? Because
It might be. See?
I think it might be opposite. Because we frommed on the recipes photos.
And we don't want to include those.
Yeah. So it was the Oh my god, good. I'm confusing myself. Never mind.
Yeah, I'm also confusing myself too, and you are not helping. I'm just kidding. I'm just kidding.
But theoretically, you could switch the from and if you switch the from and the on one, like which one you listed first, like you could still do from recipes instead of recipe photos, and then left join on recipe photos, and you just switch the join direction.
Yeah.
To get the same thing.
Correct.
Okay.
So, let's look a second at recipes for a second. I called this recipe ID, which is kind of weird. Normally you would just call this ID. But I did it for a very specific purpose because I wanted to show you natural join, which I almost never use because it usually doesn't work out and it's kind of ambiguous. But let's do it. Select star from recipes, photos, natural join, recipes. So this query here, when you say natural join, is saying like look for columns that are called the same thing in both tables, join on that. So because I have recipe ID in both tables, it's smart to say like, okay, I see a recipe ID here and a recipe ID here. I can join on those things. Nothing else is called the same, so it ends up working okay. But like if I had title in both of them, it would try and do join on both of those. So this is why I don't use natural join hardly ever, because it's pretty ambiguous. And imagine later that this works now, but my coworker later goes and adds a title to the photos. Maybe they have like captions or something, or body, right? And they have captions. All of a sudden it's going to try and match up bodies, and that doesn't make any sense. So I wanted to show you that that exists, that people sometimes use it. It's really nice for just doing queries like this where I know they're called the same thing, but I don't suggest using it. And let's talk about cross-join because it's silly and it makes me happy. Let's say we had a set of 3 things, dog, cat, chicken, and we had a set of a second things, colors, the red, yellow, blue, or something like that. And you wanted to make red cat, red dog, red bird, blue cat, blue bird, blue, and like you wanted to make every permutation of all those things put together. That is called a cross join, and SQL can do that for you. So if I say select r.title, r.body, rp.url from recipes, photos, rp, cross join, I'll just put that into the top line, cross join recipes are. This is now going to go make every permutation of all these that exist. It's a lot of rows. So despite the fact that I only have, 15 photos and 6 recipes, I just made 78 rows of all of them joined together in every possible permutation. You might be asking me, why is that useful? And the answer is, it's not super useful. Maybe someday you're going to come across some problem and you're going to be like, I'm so happy Brian taught me that. Other than that, it's just a curiosity that that does exist. But just be aware that it quickly blooms out of control. If you cross join a table of 10,000 to another table of 10,000, you're going to get a lot of rows. Let's talk about foreign keys. So we have our recipes table. What happens if we delete from it? So this is the khachapuri. If we delete that, we still have photos in the other table. That's a problem, right? We don't want orphan photos. So let's just run that. Okay, and now we'll select them. we still have photos here, right? That's a problem. We don't want to have photos just hanging out in our database if they don't correspond to a recipe. Wouldn't it be good if we could like constrain that if we delete something from our recipes table, that necessarily those things have to go out of the photos table? Well, lo and behold, there's something called a foreign key that actually will do that for you. So I'm actually going to like reset my table right now because I want to make sure everything works the same way. So if you run this little query here, it'll just reset your table to everything being good data again. This is kind of an interesting one here, the if exists. So if it didn't exist, this wouldn't do anything. So this just adds like a bit of resiliency to say like, hey, if this exists, drop it. If not, do nothing. Okay, so we did that. Now we're gonna recreate our photos table a little bit differently this time. So create table, recipes, photos. Okay, we're gonna give it a photo ID of integer. You could also just give it ID, either is fine. Integer, primary, key generated, always as identity. Okay, we're going to have a URL, which is a varchar 255, not null. And then we're going to do this recipe ID, but we're going to make this one a little bit different. It's going to be an int, but it's going to say references, recipes, the recipes table, and specifically the recipe ID in that table. Then you have to tell it what to do if a delete happens. So you could do on delete. There's like do nothing, I think. There's set null. So it's not do nothing. It's no action, which basically means, hey, if someone's trying to delete out of this table and has not already cleaned up the other table, just throw an error. Make them go clean the other thing first before you come back to me. Now I'm lazy because if someone deletes something from the recipes table, I just want to delete those photos, right? So I'm going to say on delete cascade. This is basically saying, hey, if someone actually deletes out of the recipes table, just delete everything that this references in the other table. So now if I run this delete that I ran up here, what would you expect to happen to its photos in the other table? They would go, right? They would delete. The delete would cascade to the recipes photos tables. If I put no action, then what it would do is this would error until I ran the delete on the other table first. And then if I did set null, what it would do is it would just set recipe ID to be null, right? So then I would have orphan photos, but they don't have any recipe IDs that they do, hook up with. So I just showed you here on delete. You can also put on an on update if there's some sort of like synced state between the two. Let's say I have like, I don't know, I'm making stuff up now, but like, let's say I have like English photos and French photos. And if I update a photo to be French instead of English, and you want that to update to cascade to the other one, you can handle that with the on update part of it. We're not going to do anything with that today. We just care about the on delete. But that's what's cool about a foreign key, is now I can have this like tight relationship between table A and table B. What's also cool about this, if I try and insert into recipes, photos, values, I guess I have to put here recipe ID, title, body, and I put values, some number that's not realistic, thing, other thing. Did I not create that already? Or did I call it recipes photos? Oh, yeah. D recipes, photos, and it's URL, not title body. Photo ID, recipe ID. So I just need a URL. Anyway. Now, what it's going to tell me here, this violates the foreign key constraint, which basically said, like, hey, you're trying to put something into the photos table that's trying to reference something in the recipes table, but that doesn't exist. I'm not going to let you insert this until you fix that. So now I can't accidentally insert orphan photos as well. So that's what this foreign key constraint does, is it makes sure that these things stay in sync. So we just did one-to-many relationships. Now we're going to do many-to-many. And we already discussed what it is. It's a recipe contains many ingredients, and ingredients belongs to many recipes. So how do we model those things together, right? There's not like a one-table to one-table relationship where if I have something here, it exists over here. I need another intermediary. So we're actually going to add a third table to model that. So let's go ahead and do that. We're going to create a table called recipe ingredients. It's going to have a recipe ID. That is an integer that references recipes, recipe ID, on delete, no action. Why am I putting on delete, no action here? If I have an ingredient and I delete like the connection between the recipe and the ingredient, I don't want to delete both recipes and the ingredient, which then have cascading deletes, which then go back and delete things. You would eventually kind of like wipe out your entire database accidentally. So if you're trying to delete a recipe, basically what you're saying is like you have to go clear out the recipes ingredients table first, all of the connections first, before I let you delete the recipe. So you would start by deleting things out of this table first before you go delete recipes or ingredients. Okay, I'm going to have an ingredient ID, int references ingredients on its ID, on delete, no action. Okay, you need some sort of primary key because every table has a primary key, but I could just insert like a connection ID or something like that, or just give it like a normal ID. However, we're never going to query this table for a specific connection. We actually don't really care about the individual connection objects. We care about all about is just joining the two tables using this intermediary table. So instead of having some third ID, what I'm going to do is I'm going to have a combined or a compound index that combines them together and asserts their uniqueness. So I'm going to say constraint recipe ingredients. I'm giving it a name. That's what this is. PK for primary key. Primary key of recipe ID and ingredient ID. You need a comma. So what this line is asserting is the primary key of this table is the combination of recipe ID and ingredient ID. That should be guaranteed unique in this table because it doesn't make sense that flour would be the same ingredients twice in one recipe. It's just the one recipe, right? So if I try and insert like egg twice into the cookie recipe, it's going to say you already have this in here. There's no need to connect it again. You don't need multiple one connections. You have one connection. That make sense? Okay. So now if I look at my recipe ingredients, I have this recipe ID and ingredient ID, and then my foreign key constraint is that recipe ID exists in recipe, the ingredient exists in the ingredient one, and the combination of the two is unique. This is how you model many-to-many relationships using SQL. All right, let's go ahead and go insert some things into that database. I'm just going to copy and paste this because it's not that interesting. Okay, so now if I select star from recipe underscore ingredients, I have some rows in here. These are guaranteed to be in ingredient. These are guaranteed to be in recipe. However, the connections themselves are wholly uninteresting, right? I would never want to return this to a user. I want to see what's in the recipe, and I want to see what the ingredient is. But notice I have 1, 1, 1, so these are all the same, and then I have 13 and 13 here. So ingredients can exist in multiple recipes. Recipes can have multiple of the same ingredient. It's just the combination of the two that's unique. Okay. Now let's say instead of having recipe ID 1 here, I want to have the actual recipe. Instead of having the ingredient ID here, I want to have the ingredient. How do I do that? Joins, you might have guessed that. Good job. But the second thing is we have to do multiple joins. We have to join a couple of times. So we're going to select i.title, and you can actually give them names if it's a little bit easier for you. So that's what this as keyword does. Select the ingredient title as ingredient title, if that's clearer to you. This is just going to be the name of in the table that it returns to you, right? i.image as ingredient image. i.type as ingredient type. Okay. So first thing was I'm just going to do the ingredient part first, and then we'll go back and we'll do the recipe one. So from recipe ingredients RI, inner join ingredients I on I.id equals RI.ingredient ID, where we'll just grab one of them, ri.recipe ID equals 1. And what did I mess up here? Recipes ingredient. See, I mess this up all the time. It's recipe ingredient. There we go. So I went and grabbed all the ingredients for recipe 1, which I think is cookies. So in case you didn't know, carrots, cauliflowers, and chicken go into cookies. These are nonsensical recipes, so don't worry too much about that. So this got us all the ingredients, but it doesn't tell us what the recipes are, right? So how do we get the recipes in here? We're going to have to do another inner join. So let's do that. We're going to do, okay. Let's do this in code because this is going to be so much easier for you to visualize this. Change language mode, SQL. So I'm going to do select i.title as ingredient title. We're going to do i.image as ingredient image. And then we're going to do i.type as ingredient type. But we're also going to grab from R, which is going to be recipe, we're going to grab r.title as recipe title. And what else do we have in that? Recipes, the body. So we'll grab the body as well. So we'll grab r.body as recipe body. And if you want, you can grab the IDs as well. r.id as RID and I.id, except this is recipe ID. Recipe ID. And I.id as IID. Okay, we're going to do a from. We're going to do recipe ingredients, RI. Okay, you have to inner join. I'm going to try and space these out a little bit so it's a little bit easier to read. Inner join ingredients I on I.id equals ri.ingredient ID. Okay. Inner join again. Recipes are on r.recipe ID equals ri.recipe ID. In theory, you could do a natural join here, but don't. And then here, you could, after that, you could put your where clause if you wanted to. You could say where ri, whatever, blah, blah, blah. We're not going to do that. We'll just grab all of them. And let's see if that works. And there you go. So the recipe here, cookies, cookies, cookies. This is coming from the recipe table. The ingredients type is coming from the ingredients table. And we have all of these connections that exist because of that recipe ID, or the recipe ingredients table that exists there in the middle. Right? If you remember, we inserted, where are we? Up here. We inserted 5 different rows of just numbers that correspond to both tables, and then we used the joins here to grab the information from both tables, so therefore we can see all of the ingredients in all of these recipes. So 5 insertions, we have 5 rows here that matches up. It's a lot, I know. But this is kind of how you use these like relational tables to join information to build each other up into these big things. And then using foreign key constraints, we can kind of guarantee that everything stays in sync. You can see here when you start joining a lot of tables, it's really useful to have these short table names. Frequently people make them 1 to 2 letters. It's probably a little bit excessive. In a very short query like this, it's probably fine. But if you're writing like 100-line queries, which is not that uncommon, you probably want to have a little bit more description. Like I might call this like ing and recipe or something like that, but typing out recipe ingredients 50 times sounds wholly unappealing to me, so I don't know. It's kind of up to you what you want to do. But yeah, this is how you model many-to-many relationships. So let's go talk about constraints. We already saw this constraint here, which is basically, a constraint is exactly what it sounds like. You're saying this column has some sort of rule about it, as opposed to something like body, like the body of text, right, that exists on recipe. There's just no rules for that. You can put literally whatever you want there. Constraints is basically saying, like, in order for this to be inserted here, it has to satisfy this rule before I'm going to let you do that. So we've seen one. One was that there must be a unique combination between recipe ID and ingredient ID, that's a constraint. Unique, if you remember unique that we did earlier on the title of ingredients, unique is considered a constraint as well. Primary key, that's a constraint technically. Foreign keys, technically a constraint, right? Because you're constraining that this has to exist in the other table. Let's do one for our types, right? Because we either have meat, fruit, vegetable, or other. So we can basically say this has to exist amongst these things or I won't let it in here. It's essentially an enumerated type. And I use that word kind of cautiously because there's actually a separate concept in Postgres called enumerated types that you could also use here. There's a bunch of ways to do it. I'm just going to show you the way to do with this like check thing. So let's go ahead and type that into our table. We can say alter table ingredients, add constraint, type enums or type check or enums, whatever. It's just whatever you want to have it show up as, doesn't matter. Check, and you're going to say type has to be in, has to be one of these, a meat, a fruit, a vegetable, and other, and that's it. So now we have a check constraint in here. So if I try and do something like this, which I'm just going to copy that, insert into ingredients where title image type. So this right here going into type is obviously not a type, right? It's not in our meat, fruit, vegetable, or other. It's going to fail because it's going to say this failed, that obviously not a type is not in our meat, fruit, vegetable, or other. So it's just allowing you to set some rules and boundaries around your data. And at this point, it kind of bears mentioning, this is like one of the primary points of using an SQL database, particularly Postgres or MySQL, one of these, is that if you have highly structured data with schema that have a lot of rules around it, like this can be this and can't be that, and should be this and can't be less than this, SQL is really good at stuff like this. It's really good if you can give it specific rules of enforcing that those rules stay consistent. If you go into things like Redis and MongoDB and some of those other ones, they have some ability to do some of that, but it's not necessarily as built for it, whereas SQL is it just thrives on constraints and rules and stuff like that. So yeah, this is like the primary use case of when you want to use SQL.
I'm assuming that this would work similarly to the not null constraint, where you could probably give it a default. Like if you had a type, I'm wondering if you had a type in there that didn't meet that constraint, when you're adding a constraint, I'm assuming you can default that similarly.
Yeah.
The check. Okay.
Well, hold on. The answer is it's going to fail if we try to do this and we had like a, I don't know, spice in there or something like that. I imagine, and I've never tried this, that there's something to say like on fail, do something like this, on conflict, set to be a default. But really what you'd want to do is you just want to go update all those yourself before you do that. So I'm showing you all these like alter table kind of commands, just so you know that you can, once you set a table, you don't have to like live and die by that. You don't have to drop it to recreate it. You can alter them. It's really expensive on big tables. Like I remember when I worked at Reddit, we had to run like database migrations from one schema to another. It would take hours because the Reddit has huge tables, as you might imagine. It has every comment and every user and every upvote that's ever existed in there. They're huge tables. So you really don't want to run alter table haphazardly. Right? You need to like plan for it. You probably have like scheduled downtime and things like that. So if you're adding a constraint that didn't exist before, in that case, I probably wouldn't even add it. It's probably not worth it. But if I was going to do it, what I would do is I would go update manually all the things that were in conflict, and then I would run the alter table. We just did constraints, and now we're going to go do another little project. So one thing before we hopped too far into the project, I wanted to tell you a little bit about distinct. So let's say we wanted to do select distinct star from recipe photos. Recipes photos. Oh, not that one. Maybe recipe ingredients. And you want to do it on recipe ID. Okay. So what distinct does here, look at these two different queries. You can basically ignore the top one. Let me just redo that without the distinct there. What distinct does is it's going to find the first incantation of whatever we're looking at. So I said on recipe ID here. So notice that there's only one recipe 1, or recipe ID 1. There's only one recipe ID 2, whereas down here there's 3, and then down here there's 2. That's what the distinct part does, is it basically says, I only want the distinct, interesting one of these. Or another really useful one of these would be select distinct type from ingredients. I didn't need the on because I wasn't doing anything like window func, like I wasn't looking at other parts of the table. I was just looking at just the type, which is what this is. So this tells me all of the distinct types that exist in the ingredients table. I only have fruit, meat, vegetable, and other. That's it. So that's what the distinct keyword does, is it means just give me all of the individual distinct versions that exist of that. Right. Whereas if I just do select type from ingredients, I'm going to get a lot of repetition, right? So the distinct collapses that down into just the distinct various items. So grabbing that and looking at this, let's say I wanted to just get the first photo of every single item in the database. I can do select distinct on that recipe ID like you saw there above. But this is actually now only going to give me the first photo instead of all photos. So if I do that, notice I only have one of each of the recipe IDs. You know what we didn't do? We did not add back the photos. So let's go ahead and do that really quick. That was in the relationships. Yeah, so down here, this one. So you might need to insert this again. I need to. So insert into recipes photo. There we go. So now notice for every single one of these recipes, I only have one photo. I have the first cookie, the first empanada, the first jollof rice, the first shakshuka, khachapuri, and then the chow long bao. I have the, because I did the left join here, right? But it doesn't have a photo, which is fine. We still got it, even without the photo. Does that make sense what that query is doing? It's going to be necessary because I want you to grab the first primary photo for each one of these. And I can actually even show you how to make this a little bit even prettier. So let me grab this and put this over here in VS Code because it's a little bit easier to read. So you need the r.title and the rp.url. You probably need other things as well, but I'm just going to show you these two. This chow long bao doesn't have a photo, Now in my code, I could handle that, right? I could say if there's no photo, do a thing, but I can also have Postgres do the heavy lifting here for me, and I can say coalesce. If it doesn't exist, then give me default.jpg as URL. Pretty sure that should work. And now you can see I got cookies, I got empanada, jollof rice, khachapuri, and notice that even though chow long pao doesn't have chow long, I've been saying that so much today that my brain is not connecting all of the, I probably wasn't saying it right in the first place, so it doesn't matter. Anyway, soup dumplings now has a default.jpg, and that's what this coalesce does. It basically says check this to see if it's null or null-like or something like that. And if it is null, give me this. If it's not, then just return that. And that's what coalesce does. Does that make sense? Cool. So that's a nice little trick so that you don't have to go and like check to see is this null across all of your rows that you're returning. Okay? The on recipe ID means only one of these is allowed per row, right? So I only have one cookie, one empanada, one jollof rice, so on and so forth. There's a bunch of ways you can solve this. You technically could solve all of this with one query. I actually ended up doing this with 2 queries in my completed results because I felt like it was more clear and it made more sense. That is going to be totally up to you of how you choose to solve this problem. It's fine to do multiple queries in one API request. In fact, I would even say it's common. So use your best judgment. Sometimes writing the biggest, weirdest query is not the best way to get there. It's better off done in multiple different queries. And faster, frequently, as well, right? Because if you have complex joins, it means Postgres is doing a lot of work for you. Sometimes that's not what you want. I am going to have you do one thing with me. So come back here to the project, and I want you to click on this big SQL query with a bunch of recipes thing right here. That's going to download recipes.sql. I've downloaded it a few times because I make sure it works. Click on that. This opens in my VS Code. This might open in a different thing for you. All I want you to do is I just want you to copy, Command-A, Control-Copy, and then I want you to paste this into recipe, your database. It's a long query. So you can see here I put a lot of stuff in your table because I want you to have like a lot of recipes and stuff to draw upon, right? But if you want to look at, this is literally everything that you've done before. I just put a lot of recipes in here. Nothing here should be surprising to you. Yeah, nothing should be surprising. So now if you say select, just so you know, count stars, how you count how many things are in a table. From recipes, we have 56 recipes. From ingredients, we have 126 ingredients. From recipe ingredients, we have 170 connections, right? So just so you know, the other container that I provided you that we're going to use in the second half just runs this query exactly. It's actually literally the same query. So you can also just use that other container if you feel more comfortable with that. That's up to you. Okay, so let's walk through our second project here. So you've already done the ingredients portion of this. Now we're going to go do the recipe portion of this. So go into your recipes. Same sort of thing here. We have a client and we have a detail client. They're 2 different pages, but you only have to worry about api.js. Okay, you're going to have to connect to Postgres again here. You can literally copy and paste the one from the other one. That's fine. Here you're going to have to return the recipe ID, title, and the first photo as a URL. You're going to use that distinct magic that I was showing you. And then for the recipes without photos, return the URL as defaults.jpg, which I showed you how to do with coalesce. Okay, that's the first one. That's for the search page. which let me just go ahead and show you that first. I'm going to have to run npm dev again. Oh, it's already running. Localhost 3000, that's here. We're going to go into recipes. Actually, can I just do this here? Yeah, I can. This is just going to be a list of all the recipes. It's not paginated or anything fancy like that. And then here, you're going to click on like one of the recipes, and that'll take you to one of these pages. It'll show you all the ingredients, the instructions, and then like a rotational picture of all the ingredients as well as the images. So looking back at our code, so the search page, you should just have to do this one, the recipe ID, the title, and the first photo. Again, that's going to take probably 2 joins to get that. This one, you're going to return all ingredients. This is going to be a top-level item that you return. So instead of having status not implemented here, you're going to have ingredients be an array of the ingredients from the API, right? Make sure that you can use as, right? Remember as to rename things. Return the ingredient image as ingredient image, ingredient type as ingredient type, and the ingredient title as ingredient title. Probably going to be your first query, I would imagine. Okay, then you're going to have a photos row that you're going to return. This will be an array. Return the title, body, and URL as named by the same. Right, so you don't have to rename those things, title, body, and URL. That's totally fine. And then finally, return the title of the entire recipe as whatever, and the body as whatever the body is. So actually, you probably don't even have to turn the, you can actually just return this as URL, because I don't think it actually uses the other stuff. So I'm kind of letting you, cluing you in on how I did it, but you're welcome to do it however you want. All right. Any questions? Make sense?
For search, what are the query params?
There are no query params.
So this is more like a list.
Yeah, it could have been called list. Yeah. I don't think I even have a search box up there, do I? I don't. Yeah, there's no search. It's just listing all of the recipes. So the first thing I'm going to do here, I don't want to write it out again, so I'm just going to copy and paste the exact same pool kind of thing here. And we're going to put that right here. So now I have this pool that I can query from. Again, make sure you are connected to whatever you called your database, right? Make sure your database is running. Make sure it has all the data that you expect. None of this is going to work until that works. Okay, here we're going to put the search functionality or list functionality, as it was aptly pointed out to me, since we're not actually filtering at all. Okay, then I'm going to say const rows equals pool await pool.query. And then here, I'm going to put this on multiple lines. If you use backticks in JavaScript, you can put things on multiple lines, and that can be helpful for me. Select distinct on recipe ID. I'll say r.recipe.id, just to be extra specific. We're going to say r.recipe ID, r.title. We're going to coalesce rp.url to default.jpg as URL. Okay. From recipes are, we need a join, but we also need to include all recipes, not just ones that have images. So we're going to do a left join to include everything from the from table. We're going to left join from recipes, photos, RP, on r.recipe ID equals rp.recipe ID. No parameters here because we're just listing everything in the database in this particular case. A useful thing to do later if you wanted to go and like expand your knowledge is you could do pagination on this. And then here I'm just going to say res.json rows, which is what came back here. And then we can get rid of all of this. Cool. Let's take a look, make sure I'm not out of my mind. So recipes, and I crashed it. What did I crash? This needs an extra, let's try that. I forgot a, oh no, that's not it, because that's what it's supposed to be. So let's actually see what I did wrong. Unterminated string, which is the default.jpg. That is actually what's wrong. So you make sure you have both of the single quotes there. Now let's try that again, and there you go. So see, these have photos, the ones that do, and you can see some of these have this like photo like that looks like this one. That is the default photo. Whatever. That's when your app just is giving up and it says whatever, I don't care. Let's hop into the get. So again, I broke this into two photos. I broke this into two queries, and that just made sense to me. But just like programming, there's like a ton of ways to do the one thing. Same thing in SQL. There's a lot of different ways that you could have done this. You could have definitely done this in 3 queries, right? One to the recipe table, one to the recipe photos table, and one to the ingredients table. And I would have definitely accepted that as correct as well. Const ingredients promise equals pool.query. This is just how I like to code JavaScript. You don't have to do it the same way. You could definitely do an await here. But here I'm actually just going to grab the promise. And then I'm going to say select i.title as ingredient title, i.image as ingredient image, and i.type as ingredient type. I'm going to grab that from recipe ingredients RI, inner join. I like to put these extras like white space things just to let me know it's like I'm kind of starting like another little clause, right? Like you can basically think this is like a comma in my speech. Ingredients I on i.id equals RI ingredient ID where ri.recipe ID equals number 1. We've more or less already written this out together, right? But the idea here is we have the ingredients table. We're grabbing all of the various ingredients that exist for any one recipe based on what the recipe ID is. So here we're just going to give it the recipe ID. Okay, this is the first query that I chose to write. The second query that I'm going to choose to write is the photos one, const photos promise equals pool.query select r.title, r.body. This is what I'm saying. This part could have been a third query where you just get the recipe details. I chose to put it together with the photos because that made sense to me. It's one query. It wasn't that hard to do. Here I'm going to say coalesce rp.url to default.jpg, like we saw above, as URL. From recipes R. I can put that on a new line or not, either way. Here we're going to say left join, right? Because we want to grab all recipes no matter what. Or rather, this is like a single detail page. If there is no photos, we still want the recipe. That's what the left join means in this particular context. Recipes, photos, RP on rp.recipe_id equals r.recipe_id. And then lastly, we need our where r.recipe_id equals $1. And then you need to give it the recipe ID as well. Okay, so now I have these two promises. Here's my thinking here. You can say await here and await here. The way that await works is it's going to pause execution until this happens. Then it's going to go here and it's going to pause execution until this happens. I actually want both of those queries to go out at the same time, right? Because it doesn't matter what order they come back to me in. And I want to pause and wait for both of them, right? Does that make sense? So you can do this with something called promise.all. This is just a JavaScript thing and how I would write this code. So I can say this is going to be photos response and then ingredients response equals promise.all. And you're just given an array of promises. So this will be photos promise and then ingredients promise. And then all I have to do here is I say await. So here's what's going to happen kind of in real time. It's going to call this, but it's not going to wait. It's going to immediately call this one as well. So two queries are going out like not simultaneously, but in quick order of execution, right? It's not going to wait to call photos promise for this one to complete. Here, when I say await promise.all, it's going to wait for both of these to finish. Once both of these have finished, then the execution will resume. Okay? And then now I have photos response here and ingredients response here. And I can just say const photos row equals photos response dot rows and const ingredients rows equals ingredients response dot rows, right? Then down here, res.json ingredients, and we're just going to give it ingredient rows. Photos. So if you remember here on the photo rows, if you look at the code here in the detail.js, it's expecting them to just be direct images, just URLs. It's going to give them back to you as objects. So I need to transform them. There's a couple ways you could totally do this. You could say for, and I'll just leave this. This might be the easiest way. Let I equal 0. I is less than photos rows dot length I plus plus. We'll just call this const photos equals blah. And we'll just say photos dot push photo rows I URL, right? So then this photos array will just be URLs, right? It's just going to be strings instead of objects. And then here I can just say photos, photos, right? These photos that I created up here, or I can just say photos like that. Title in photos, rows, we can just grab the first one, right? And grab the title off of that because it's going to be the same for all of them. And same with body. It's going to be photos, rows, 0.body. But if you did a separate query for that, you would grab it out of the separate query. So if you're reading through my completed code, it's a little bit more clever in terms of how it does it, just because that's how I write code. I tried to be a little bit more explicit here as we wrote it together, but just to walk you through it really quick. Oh, I have it here as well. API for completed recipes. Here I do all the destructuring in one line. But notice it's grabbing photos rows and ingredients rows the same way. It's just doing a little bit more terse syntax. And then here, instead of doing like a for loop to grab all the URLs out, it does a map, which does exactly the same thing. Otherwise, exactly the same. So let's get rid of that and get rid of that. So now let's go look at our project. This still works okay. Let's look at cookies. We get butter, eggs, brown sugar, milk, sugar. And notice we're getting all of our photos down here, and all of the ingredients get put in here as well. So, works. Hopefully it's fairly demonstrative of this is really what it's like writing SQL code together with backend code. This is generally what it feels like. For those of you that are either joining us for the first time or just getting restarted, or you need to just need a fresh copy of your database, from this point forward, you can actually just use the complete intro to SQL container that I set up for you. So let me just show you how to get that up and running really quick. Okay, so I have multiple of these running. I'm just going to kill my PG one because I'm not going to work on that one anymore. And I'm going to say docker kill SQL as well. All right, so what I'm going to do is I'm going to say docker run. I renamed mine SQL just so I could differentiate between PG and SQL. You can call it whatever you want, it doesn't really matter. Basically everything's the same. I'm going to put this on 5432, but this is relatively the exact same command that you ran, except I changed the name to SQL here, and then instead of Postgres:14, I put bt/complete intro to SQL. I already had you pull this one at the beginning of the course. So if you run that, that'll come preceded with all of the various different database things that you're going to need. You might see a warning about something like this isn't built for your computer. It should still work, so don't worry too much about it. You might lose some performance, but it's not a big deal. If your database is fine and working as from yesterday, you don't have to change that. That's totally fine. You will at some point, but you don't have to do it now. And so now if I say docker exec, make sure you're running against SQL, not PG, if you called it the same thing as me. If you called it PG, then you'll put PG here. This is just whatever you called the container. You could also literally copy and paste this whole hash here. That would be fine. And then you run that, and if you hit \L, you should see OMDB. That's a new one for you. You should see recipe guru, which is what you should, it's a copy of what you did yesterday. Just to prove my point here, you can see these are relatively the same tables. If you're running that and you're not seeing the recipe guru one, let me know, because I'm curious, because someone else saw that. But you might have to pull again. Just which when I say pull, you'll kill your container, and then you'll say docker pull bt complete intro SQL, you might even put latest there or something like that, though that's implied. You can see here for me, it's just saying yours is up to date, so don't worry about it. All right, so I'm going to reconnect to mine, Docker exec, that. I'm going to connect to my recipe guru, that. And then I'm going to clear my screen. I just hit Control L, by the way, if anyone's curious how I'm clearing my screen. I don't know if you care, but that is what I'm doing. Okay, we are going to start in the JSON B chapter, or section, which is section 5 here. Right here. So, JSON B. So I imagine most of you have probably heard of MongoDB, right? Or have used some sort of document store before. When MongoDB came on the scene, I don't remember exactly when it came out, but I remember when I had first heard of it, which would have been probably 2011 is when my company that I was working at said, like, this is a really interesting piece of technology. We want to put this into our stack. The first tech conference I ever went to was Mongo World in San Francisco. It's the first time I went to San Francisco. I was so excited. It was a really, really cool piece of technology because we could do databases, but they didn't have to have these like hard schemas. You could put objects in there. You could have heterogeneous objects, like this object has this shape to it, this object has this shape to it. They exist in collections. It was all really, really exciting. It still is. It's a really cool database that has really good uses for it. I still use it today. Stripe uses it a bunch in a bunch of different places. And if you're interested in a course on it, I left a little link here to Scott Moss's course on Front of Masters if you want to learn more about specifically the Mongo database. I also talk about it in my complete intro to databases. So it's a document-oriented database. We talked about that. Postgres is a relational database, but Mongo excels at data that is unstructured, which is to say you have data that's incoming that you don't have like a future knowledge of, like, this is exactly how this is going to look, right? That's where Mongo is really, really useful. So a great example of this is our photos table. We have a separate table for our photos because we don't know how many photos we're going to get, right? If we knew it exactly up front, we were going to have exactly 5 photos for every recipe, we wouldn't need a separate table. We would have 5 columns in addition on our recipe schema. But we don't know that, right? It can be 0, it can be 1, it can be 100. This is where Mongo would be really useful because in Mongo you can just put an array, right? You can just say this is going to have an array of photos and I don't know how many photos it's going to have, or maybe even if it has photos. So you can do this with Postgres now. I think it was Postgres 9. Don't quote me on that, it doesn't matter, so no one check. But at some point, Postgres added the ability to be able to attach a column to your database that is JSON. And then you can query not only the column, but you can query into the JSON. This is called the JSON data type. So it's actually a data type where it will verify that it's valid JSON, and then you can actually make queries into the column and into the JSON structure underneath. And they came out with this JSON data type. People loved it, but they found out that they could actually make it even better. What they were doing before is they were just, as far as I know, storing it in plain text. And then later they went back and said, we can actually make this better. We can actually optimize how much space this takes and how fast it is to query. So they came out with a second data type called JSON B. The B literally stands for better. I'm not joking, it actually stands for better. So it is JSON better. In other words, you should basically never use the plain JSON data type for Postgres. You should always use the better one. I thought that was hilarious that they had literally put in the name that this is the better one. You might ask, is there any reason to ever use the plain JSON data type? Because it does more processing on those JSON B ones, the better ones, if you don't care about querying it very frequently, like if you don't actually want to see that data very often, it actually technically is faster to store the JSON ones because they do no processing on it. The other thing is that if you care about the white space in your JSON, which one, why? I have questions for you. But if you do, JSONB drops all of the insignificant white space. JSON will preserve the white space for you. I think there's probably some other like minor nuances, but those are the two big ones I could research when I was looking it up. In other words, I'm just going to tell you, just don't use JSON. Even those are such minor like things that you can probably still just get away with using JSONB. The one thing that they called out on their particular website is that if you're doing it for like logging purposes, right, and you're just if you're writing a lot and not reading a lot from it, which is like what people do with logs, JSON could be potentially useful in that situation. But everything I'm going to show you after this point, you can actually literally do on JSON or JSONB. All the querying works exactly the same on both of the columns. It's just how they're stored that's different. There's a whole blog post here from Citus Data, which is like one of the best Postgres companies. It's actually a company that Microsoft bought because they were better at Postgres than Microsoft was. So I got to work with those people. They were nice people to work with. I'm going to throw out here that there's another thing called HStore. And this is closer to like Redis. It's like a key value store for Postgres. Every time that I go to use HStore, JSONB is a better fit for my like thought modeling. So I ended up always using JSONB. So I decided to not talk about it because I think JSONB is just overall a more useful thing. But if you're finding yourself like I need some sort of key value store like Redis, but I don't want to use Redis or Memcache or something like that, HStore would be for that. Yeah, you get basically all the functionality of HStore from JSONB for the most part. Okay, that's kind of an overview of what we're about to talk about. I'm going to show you, we're going to add a little bit more to our Recipe Guru database. We're going to add tagging, but just so you know, I showed you how to do like the one-to-many relationship from recipe to many photos, right? These days I would use JSONB to do the recipe photos. I would not use a separate table. I would actually use JSONB because it's way easier to deal with. You don't have to do any joins. You can just query the column, right? So if you have those one-to-many relationships, high probability that you probably want to use JSONB instead of trying to use another table. The many-to-many relationships, you're still going to have to do like the intermediary table, so like the ingredients to recipes connection. That's still going to be another table. I guess you could model it in JSONB, but I probably wouldn't. I'd probably still do the relationship through the tables. The first thing that we're going to do is we're going to alter our table recipes to add this JSONB column, and we're just going to call it meta. You don't really have to give it much more information than that. You just have to say, like, I'm going to give you a column. It's going to be called meta, and it's going to be a JSONB one. And then at that point, it's kind of unbounded. You can make these columns as big or as small as you want. So let's head back over here to our database. You can see here I still have all of my tables. So I'm going to say alter table, recipes, add column, meta. I just called it like meta because you could have anything in here, like any sort of like metadata, but this is just the name of the column. You can call whatever you want, and there's nothing special about meta, either the name or the company. JSONB. And you can see now if I say describe recipes, I have this meta column that is of type JSONB. Now imagine if we wanted to add like tags to our recipes. This is gluten-free, this is good for keto, this is chocolatey, things of that nature. That's what I'm going to use this for. So I'm going to say update recipes. I'm going to set meta equal to, you're going to put a single quote here, still, right? It's basically going to take your string that you provide to it, and then it will process it. And then it's just valid JSON at this point. So you need to use double quotes appropriately and things like that. Like it's not a JavaScript object, it's actually JSON. Tags, and then we're going to give it an array of chocolate, dessert, and cake. Okay. And so that is what I'm going to put there. Then I'm going to say where recipe ID equals 16. So I updated exactly one column here where the recipe ID is 16, and I set the meta to this. So let's just see what that looks like. Oh, I actually do a couple more here. So if you followed along with me, just grab a few more of these here. Kind of the same thing, I just wanted you to have a few to query. So I'm just going to copy and paste those in there, hit enter, and you can see there I updated 3 more. Actually, you can copy and paste all of them because that first one would be, you'd just be setting it again to the same thing, doesn't matter. So first thing, let's just say select meta from recipes where, and you can just say where meta is not null if we just want to look at all of them right now, right? Because the rest of them, it'll be null because we haven't set them yet. And you can see here, it actually just gives you back this like JSON object. Notice it's not a string, it actually is giving you back this like JSON-B object. Now let's say if I wanted to select just the tags, because you might imagine this is like meta info, this is a JSON object, we can put anything in here, right? We could add another column, we can take back another column, it's like JSON, right? It's a JavaScript object that we can just keep adding and deleting things from without altering our table. Right now it has just one top level key, but we could have many top level keys. Okay, so let's say I just wanted to select from meta here, I want to select just the tags. I'm going to use this arrow. So it's a dash and then a right pointing angle bracket. And I'm going to select just tags. And I need to put that in a single quote here because it's actually the value that we're looking for. And then here, now notice I'm getting back these arrays. I'm not getting back the whole object, I'm just getting back the array. We selected just the tags out of meta, right? So you can see here we're getting back just the array. What if I want just the first one, right? I just want the first thing to come back. So I want dessert, dessert, chocolate, and dessert. You can actually keep going here, so I just give it another arrow and ask for 0. You can see here now I'm getting back dessert, dessert, chocolate, and dessert. As you may imagine, you can do 1 as well. If you get 2, you should get probably empty strings, I imagine. Let's see. Yeah, empty string, empty string. This one had cake, so it actually did have a third one. So I got cake back here, and then I got nothing. If I asked for the 10th one, it would just give me back a bunch of empty strings from where meta is not null. A couple things to notice. First of all, notice it's giving me question mark, column, question mark, because it actually doesn't know what this is called. So you actually should give it as like an as, right? So here you should give it like a as first tag, so it actually has like a good useful name up here, right? Otherwise you get that weird question mark column thing. The other thing to notice here is it's giving you back still, this is technically a JSON string, right? Because it's thinking it's like you might query like later and more deeply into this. So on your final terminal thing where you're actually trying to get out just the thing that you want, give it 2 angle brackets like that, and it'll actually give you back now. It's like, okay, you're actually getting back a real string now, right? This isn't a JSON string, this is just text. In our case, it doesn't really matter because we're just reading out of this, but when you're actually trying to get it out of your database and into your code, it actually will make a difference. So yeah, the last thing that you're trying to get out here, when you're actually trying to get a string out of it, you'll use this like double angle bracket looking thing here. So that's that. You saw here, we can get the different array indexes. And it's the same thing. Imagine you have nested objects, because you can have infinitely nested objects. You could have like, you know, user, then address, then state. You could go multiple layers deep inside of that using keys as well, right? It's just JSON. Okay, so let's say that we have like search facets on the side of our application, like our recipe website, right? And we wanted to look for only the cakes, right? We wanted to exclude all of the other dishes. We wanted to search by tag. So we want to search into this JSON object to grab only the cakes. So what we can do here is we can say, and I'll just clear this so you can see at the top, select recipe ID, title, and then meta, and we're going to grab just all of the tags so you can see that we're not lying here. From recipes, we don't want that last comma. From recipes, where meta tags, and then you can do this question mark to say, I want to find ones that have cake. So I select from recipe, title, or meta tags, right? So you can see that I'm getting all of those here. From recipes, and then I'm selecting into meta, where it's looking into the tags, right? And it's asking, do you contain cake? That's something I frequently ask a lot of things, do you contain cake? And so notice it's not giving me back the other ones, right? Like if you really go back up here, this is a dessert fruit, so it doesn't give me back this one. This one's dessert fruit, it doesn't give me back that one, right? It gives me just the two that have cake in the tags. So that's what that question mark does, is it's asking, do you have any cake? So specifically what that question mark is asking is like, do you have a top level thing called cake? So in theory, if I just did meta here, and I could ask it, give me only things that have tags. Notice we got back all of four of them because they all have tags. If I had like a different thing in a different column that had meta but didn't have tags, it wouldn't get that back, right? So that's what this question is asking, is like, give me everything that has a top level thing called, or top level key, which works with arrays, right? That contains tags. If you want to do it specifically in an array contains value, there is a thing for that as well. So what you do is meta, and then you can do this like ampersand angle bracket, and here you would ask for, I think you have to put double quotes inside of this. Let me check if that's actually true. No.
Should it be meta tags?
Yep, not meta, thank you. There you go, thank you. So here we're asking for meta, we're asking for tags, and then we're going, does your array contain the string cake? That's where the outermost single quotes means you're looking for some sort of string inside of Postgres. The inner double quotes means I'm looking for the array in a string cake. So I just gave you a pretty rudimentary overview of like what JSONB is. We're not going to go much further than that, but I think you kind of get the point, right? You can kind of treat it as like a document on all of your rows. You can have like multiple JSONB columns per row, but why? You can put them all into one JSONB. That's what I tend to do, but that's totally up to you. It's how you want to model your data. So I use it a lot when I'm doing Postgres personally. I showed you everything to this point so that you can write Postgres just how Postgres and SQL historically have always been written. And everything that I've shown you besides the JSONB stuff works across all databases, basically. A lot of the queries that we've written will work just copy and paste directly into MySQL, into IBM DB2, all that kind of stuff, because they're all SQL spec compliant. The JSONB stuff is actually specific to Postgres, so this doesn't exist necessarily in other databases. Part of the reason why I chose to teach you Postgres as opposed to like SQLite or something like that is because I think this is one of the most compelling things about Postgres.
Why would you use JSONB in Postgres instead of Mongo?
If you still wanted to have like all of the power and like the joining and the unions and all that kind of stuff that comes from Postgres. The other thing is Postgres, I might get a little, this is an opinion at this point. Postgres is way more reliable than Mongo. Like, I think it's just a better product. It's been around longer, there's more eyes on it. It's a very war-hardened database. All of Reddit for years and years and years has run on Postgres, and they have billions and billions of rows. There are other companies that are doing big things on Mongo. Stripe is one of them, right? It's just problems all the time. Yeah, I think between the reliability and you have both the power of a relational database meshed together with the power of a document database, I just think it's better. If I was going to build a company today, definitely would choose Postgres as just like a general purpose database. So I just wanted to throw out there when I think you should use JSONB. I use JSONB a lot. I have throughout since it's been out and available. When I have one-to-many relationships, I tend to use it quite a bit. Specifically, I tend to not use a second table. I tend to just throw it in JSONB. It makes it really easy. If you ever have like heterogeneous kind of information, it's a really good place to say it, to use it. Like, let's say our recipes, like we had like nutritional information, right? And we have like a bunch of different types of nutritional information, and some is going to have some parts of the nutritional information, other parts, like these things all have like iron and like, I don't know, potassium, whereas these other things only have vitamin C. And rather than trying to store every single permutation of nutrition on every single row, that would be a really good use case for a JSONB kind of situation. I probably would have done our photos in JSONB. We did tags. That's a pretty good use case for it. So the thing that you kind of want to think about when you're choosing, should I put this in JSONB or should I put this just as like a normal column? If every single row has it, make it a column, right? Because then you can do things like joins and other things like that. You can do joins on JSONB. It gets weird though. If you have any sort of like constraints that you need to enforce, like not null, or if you need to enforce so that it's unique or things like that, that's a really good use case for making a column, not necessarily JSONB. If you have unbounded data like tags, where you can have 100 tags or 5 tags, that's a good case for JSONB. And if everything you have is like a heterogeneous piece of information and you're never doing any joins, you should just use Mongo and not use Postgres at all. If you're doing joins at all, never use Mongo. Just from the depths of my soul, I implore you to never use Mongo if you're going to try and do joins. I will not work at your company if I go in there and I see that it has Mongo and there are joins. That's actually real. I would not. I'm probably making someone feel real bad about something right now, but I have just scars, which is why I'm saying that. Aggregation. So we've kind of already been cheating a little bit. You've probably already seen it. It's just a really common kind of query to run. But let's go ahead and do a few of these right now. So I'm going to say select count star from ingredients. If you ever want to know how many rows you have in a particular database, that's what this does. It's aggregating all of your rows together and then returning to you a number. You want to know how many recipes we have? 56. You want to know how many recipes photos we have? 44. And recipe ingredients? 170, right? The count star is something that you're going to see very frequently. What if I wanted to know how many different types of ingredients we have? I don't want to know what they are. I want to know how many different ones we have. Well, here from ingredients, I can say distinct type. And this will return to me that I have 4. It's not going to tell me what they are because I didn't ask for that. It tells me how many different types we have. So this is where we're actually telling it like what we want you to count. When you put count star in there, you're just saying count everything in the result set and give that back to me. Just for clarity's sake, if you want to see what those types actually are, you can say select distinct type from ingredients. And this will actually give you the 4 different types. What if I want to know how many of each type there is? Seems like that would be useful information to know. So here I would say select, let's control L this so you can see. Select type, right? We want to know the type, and then we want to know the count of how many of each type there is. So count type. I think that tracks, right? From ingredients. Now we have to give it like a little bit of a hint, is like how are you going to group these things together, right? That's where you enter this group by. A group by is always going to be accompanied by some sort of aggregation function. A count is an aggregation function. Another one that you might use a lot is average or min or max, right? It's taking a bunch of things and kind of condensing them down, or in other words, aggregating them into some higher level insight, right? Here we're going to group by type, right? Because that's actually what we're trying to count here. We have 29 vegetables, 78 fruit, and meat 6. Now you get into this weird situation of, let's say I was trying to do a query of something like this. Select title, type, count, type, from ingredients, group by type. This query doesn't work. Why?
Because the title could be different for all of the different groups.
Yeah, it should be different, right? It actually must be different because there's a constraint on the table that forces them to be different. So you need to ask yourself, like, what is this actually really asking? The title here is nonsensical because the title is being aggregated away into this type and the count type. So asking for the title here, it's nonsensical to ask for one because it couldn't possibly, you're not really asking for anything, or you're asking for something that doesn't make any sense. So if you do this, it's going to be like, I can't do that, because the ingredient title at that point would have to actually show up in the group by for that to make any sense, right? So in other words, if you're going to be asking for something in a select and you have a group by, everything that's going to appear in the group or in the selects probably needs to be in the group by as well, because you need to be grouping by things. Grouping by title wouldn't make any sense because everything would have a count of 1, right? So I found that really confusing when I was starting out with SQL. I was like, I want to select things that aren't in the group by, and then I kind of had to have this like light bulb moment of like, what am I trying to do here? And it didn't make any sense. We'll see more of this as we get into using the movie database. We don't really have a lot of things to count in the recipe database, but I'll show you how to do things like averages and other things when we get into like window functions, which are closely related to aggregation. So another thing that a lot of other SQL courses will talk about way before now is what order things happen in. So let's say let's just put this query in here. I'm going to put Control L. This one here, I think it's the same one. Oh no, we'll type it out. Select type count type from ingredients where count type is greater than or equal to 10, group by type. This query doesn't work either. So I haven't talked about the order of execution of things in SQL statements because when I was learning SQL, all it did was confuse me, right? do I need to care? Does the select happen first? Does the from happen first? Does the where happen first? To this point, it hasn't mattered at all to any of the queries that we've been doing so far of what order things happen in, which is why I elected to not tell you about it until now, when it actually is going to affect you. Here it's going to be like, this is the problematic part. I think it's reasonable for us to ask, let's say we're trying to aggregate by type, but let's say we have 600 types of things and 550 of them have just one. And we want to eliminate all of the ones that have just one, and we want to see larger macro trends in our data rather than just groups of one, right? So it'd be useful if we could say, hey, give us back all the counts that are greater than 1 or greater than 10 or something like that. But we can't do where because the where happens before the counting. So the where happens before the aggregation. So you can't say where count type is greater than or less, or is like, filtered here, right? Because the counting here actually hasn't happened yet. So if we're asking for where here, it doesn't make any sense because it can't give you back numbers because it doesn't have the number yet. And if you think about this, this is actually kind of a useful thing for you because you can filter before it gets counted. Makes sense, right? Let's say we wanted to count all of the types, but we wanted to eliminate things that didn't have images. That's where you would use where, let's see, ingredients. Right, so I have image here. Let's say for whatever reason I was trying to say where image is not null. This is a sensical thing to ask, right? I mean, I don't know why you'd want to ask it, but you could. So this is going to be filtering on the rows that are going to go into the result set. So we need another thing, another concept here to filter on after aggregation. So again, I think this might be the same because I think literally everything has an image, but you kind of get my point here. Actually, is that true? It is, but who? So how would we do that? Well, you can add an additional thing here called having. Let's see, I can just copy and paste, I guess. Having count of type 10. Or we can go the other way too and say greater than 10. So you can think of having as basically the post-aggregation where. Does that make sense? So the where is going to filter the things that go into the result set. It's going to get aggregated, and then you can ask questions about, and then you can filter further on the result set using having. So yeah, you can use both of them together. Or this is another one I had in here. Instead of saying where image is not null, because it ends up being the same thing, but we could say where ID is greater than 30. So you can see that actually does modify the aggregation of it if we're only looking at things where the ID is greater than 30. So this is my maybe pragmatic advice to you. I'm not I don't live and breathe in SQL. I use it as part of like the tool set that I use to write applications. There are people out there like data scientists and DBAs that they live and breathe SQL. I don't really bother too much of learning the exact order set things happen in SQL because it's a really complicated decision tree of what happens when, right? If you really dig down into it. I only look at it when it affects what I'm trying to do. So in this case, it made a big difference, right? Because we need to know that where happens first and then having, and then aggregation and then having. But do you really need to know the exact minutia of it? Usually not. Usually it doesn't affect you. which is why we're not going to talk about it, I don't think, for the rest of the course. But if you're curious, you can go look it up. It's like explained out in depth on the docs and in Wikipedia and stuff like that. The other thing I'll just tell you up front, I have everything here in the correct order, right? You have to have having at the end. If you try and put like having in front of where, it's going to say like you're doing this wrong. I never remember the order of things coming. I have to test and retest until things work. And I have to look it up frequently because it's not a part of my brain that I don't know, I don't commit it to memory because it's not important to me. So I'm throwing out there that I think that's fine. I don't think you need to memorize the order of which SQL things happen. I'm probably making some DBA really mad right now, but I have so many other like Pokemon facts that I just have to keep in my brain that I just can't fit it. God, I wish that wasn't true, but it's actually a little true. Anyway. All databases have this concept of functions and procedures, and then we'll talk about triggers, which have to relate to functions. So imagine you find yourself doing the same query over and over and over again across many parts of your application. You can basically use a function to kind of basically store that query as something that's kind of ready to go. So let's say we're focusing on a recipe site with a few ingredients, right? Like, I don't know, I have a couple recipe books that are basically like, you live at home by yourself and you only have like a pan and 5 ingredients. I like those books because I don't live by myself, but I'm also very lazy, so I like those kind of recipes. So imagine we have like a filter for that on our recipe website. So we'd be selecting from recipe ingredients. We'd have some sort of like count title between 4 and 6. So let's just go ahead and run that. And you can see here, this is ingredients where that works, right? Where we have like 4 to 6 ingredients or something like that, right? So by grouping by r.title, which is a unique key, we're grouping by the ingredients. We're getting something that has 4 to 6 rows worth of ingredients. And then therefore, because we're grouping by the title, we can return that up here. So these are all recipes that have between 4 and 6 ingredients. Feel free to pull that apart, but I promise you that's what it does. So let's say that we're doing our recipe website. Users start hitting that specific page a lot. It gets really popular. It gets way more popular than the rest of our website. As a good, product owner and trying to pivot into market fit, we just say like, let's do that entirely now, right? Like this is our entire website. We're going to focus on these like low ingredient kind of recipes. So what we could do then is we could create a function that gives us that, right? So we can create this function here called get recipes with ingredients. We can give it a between 4 and 6, between 2 and 3, between 1 and 10, right? It gives us some flexibility and some reusability to it. This is what functions are for Postgres. It's one of the things that they can do. We'll see other things that they can do later. But that's kind of the idea here. Now, this is a language called PLPGSQL, programming language PostgreSQLs, right? So basically, it's a SQL kind of like programming language. So you can see here, all of this looks really similar to SQL, right? There's a couple of new things like return query. That's not a part of SQL, but there's a bunch of stuff in here that's made to feel very SQL-like. You can actually do JavaScript here. You can do Python. You can do Java. You can do Perl. And those are the ones that I'm aware of. It requires you to download like an extension to Postgres and install it. I thought about doing JavaScript because obviously this is front-end masters. That would make some sense. But in the end, I ended up fighting the config so much. I was like, I don't want students to do that. I haven't used it actually personally to do it with JavaScript, so I'm just going to show you how to do it with PLPGSQL because this is actually built into Postgres directly. And it's SQL. It's an SQL course. It makes sense. But just know if you're like really getting into this, you can do it directly with Java, JavaScript, and so on and so forth. So let's talk about several of the things in here. You don't have to have the or replace, but I put this here so you can copy and paste it multiple times if you decide that you messed it up or want to fix it or try different things. But you can put create here. If it exists, it will fail, right? So that's what you need the or replace for. You can also drop them. So you can say drop function get recipes with ingredients, and it'll get rid of it. Okay, these are parameters, low and high. I think that makes sense. You can provide it with the low, like the least amount of ingredients that you want to select for, or the most, which would be high. You have to give them a data type. In this case, they are integers. You have to identify what it's going to return, which is going to be a set of, which is, right, this is a set. It's a result set of what? Of varchars. They're going to be strings. You have to tell it what language, which we are doing PLPGSQL. And then here you have to return the as basically as the function. Let's talk just a moment about $signs. So this is not just related to functions. This is in general throughout all Postgres. It actually has this concept of dollar quotes. Not making it up. That's actually true. It's basically a quote. So I can actually come in here. Let's just show you. Select meta. And we were seeing here that you could do this with single quotes, right? Because we were doing like JSON, but you can actually put $signs here. We put it on recipes, right? And where meta is not null. Okay, so just to prove a point here, same thing as single quotes. Kind of weird and neat, right? So why would you ever want to use dollar quotes? It's for things like this, going back here, where we actually don't have any single quotes in here. But the nice thing about doing dollar quotes is you don't have to escape single quotes, right? So if I was doing things where I was asking for single quotes inside of this, where I was asking for like meta tags, right? I'd have to double quote those because you're technically giving Postgres a string to invoke later, right? So by using the dollar quotes, we're getting away from having to escape our single quotes. In other words, I really only use dollar quotes with functions. I really don't use them other places, but they are useful for that reason. Here we're telling it where the beginning of our function is, where we're going to end our function. Notice that this has a semicolon and this has a semicolon. That's because we're doing like a query here. This query, so this part is actually here, the query. This is definitely not going to be a course on the PLPGSQL language because I don't know it very well. I have to go read a lot of Stack Overflow before I get these functions correct, but they are useful. All right, and then here, this is just pretty normal stuff. The only thing here is we have low and high, so we actually are using variables directly in our query, but that seems fairly reasonable for us to use, right? Okay, so I'm just going to copy and paste this whole thing because I sincerely do not want to write it all out. So now I have a function. Now how do we query it? How do we use it? Well, specifically with functions, you're going to say select star from, and then you're going to call the function. So get recipes with ingredients 4, 6, and notice it's the same result set, right? But now it's flexible. I can say 2 and 4. Turns out that's a lot of them. That's 42 rows. But now we have this flexible thing. If we were using this everywhere on our website, this was like a really important like search facet for us. I'm sure you can imagine this being really useful to you. First thing I'm going to say is like this is just one of a couple ways that you could accomplish this, but it's a way to accomplish this, right? Let's make sure I covered everything I wanted to here. So yeah, PLPGSQL. It's a full language. It can do a lot of stuff. It has for loops. It has conditionals. It's a Turing-complete programming language. I'm probably, like, someone's probably written Doom in it, right? Like, I can't prove that, but I just assume that if it's a programming language, someone ported Doom to it. Now I'm scared to Google it because it's probably true. Yeah, it's very SQL-like in nature, and most of the time it reads very SQL-like. There's a lot of really powerful things. I'm showing you just kind of the surface here, but there's a lot of like really powerful stuff you can do with it that, frankly, I've not written enough Postgres functions to really tell you too much about. But let me tell you, oh yeah, and then I was going to show you here. So if you click on like one of these links, PLv8, this is where you can actually use JavaScript as the language as opposed to the built-in Postgres one. You have to like create an extension, you have to download it, you have to, you know, there's a bunch of stuff to do, and then it's like a flavor of JavaScript that has its own like variables and stuff like that. I've never actually used it, but it is available. And then Python, there's a bunch of other stuff like that. We talked about dollar quotes. Just to show you really quick here in the notes, if you need to drop that function later, you can do it like this. Drop function, and then you just give it the name of the function and the call signature. You can technically overload these, right? So I could have like a low, high, and medium, right? So you actually do have to tell it what parameters, because you have to tell it the whole signature. But that's the function that you would run to delete it. And then, so the next thing I just want to like talk about briefly is do not go overboard with functions. So the first question I'm going to ask you is, if you write this huge function and then you store it in your Postgres like this, it's not going into source control, right? It's not going into the rest of your code base. That kind of sucks. So it introduces this like, it's not unobservable, but hard to observe behavior in your application. So if you're using it a lot throughout your different places in your application and it breaks, it's hard to track down that bug because you expect your database to always be right. So you're introducing user error or developer error to your database. That is scary. It should be scary. There's ways you can get around that. You can store the functions locally, and then commit that to Git. And then when you start up your database, it's pushed into your database. It gets messy though, right? It adds indirection to your application and makes it harder to reason about what's going on in your application. So I'm going to invite you to think about it in things like, if you need to do something that you cannot do in your code and would not make sense to do in your code, by all means, this is another tool in your toolbox to use, right? You could make your entire application totally just in Postgres functions if you wanted. Dear God, please don't. As your potential future coworker, just don't. Just write code, right? They have done like some really impressive things. Like if you've ever heard of like Hazura makes extensive use of Postgres functions to give you like basically GraphQL at the Postgres layer. It's really impressive stuff. I wouldn't want to work on their code base personally. So that's my pitch for you. If you're doing something that really can only be done at the database layer or makes a lot of sense to do at the database layer, think about using these. Otherwise, I'd say just put it in your Node code or your Python code or whatever. Okay, any questions?
If you're not like writing the SQL code locally, how do you view the function again? Like if you want to see what the function actually is?
There's a way to do it. I don't know though. I think you might be able to say just \d or something like that. I don't know. I'd look in this \question mark. \df. So that'll give you the functions that exist. Thank you. But if you actually want to see the body of the function, you'd have to do some sort of querying to get it.
On the result part, or the return signature, can you have it return multiple columns? You just delineate that with a comma?
Yeah.
Okay.
So there's a bunch of stuff you can do that. You can actually write to the database with functions. We'll actually do that here in just a second. Basically anything you can do with SQL, you can do with functions. you're going to find that procedures and functions are very similar, but a procedure is a bit more limited in what it can accomplish. I think procedures came first and then they made functions later. That feels right for me to say. I have no data on that, so someone's probably going to correct me. But there are some, there's a lot of similarities. Functions can definitely do more. Almost everything that a procedure can do, a function can do, whereas the other way around is not true. So a procedure is designed to do some sort of action. A function, its general purpose, it can do an action. It can just do some sort of like selecting. It can do basically anything that you can think of in code that you would run inside of a database. That's what a function can do. A procedure is much more scoped down to doing some individual action. Let's just think about our recipes database. Let's say we have a lot of churn our ingredients where images can get created and deleted, and sometimes images are set to null, right? Let's say we wanted to tolerate that sometimes ingredients could be null, so we don't want to set like the not null constraint on the database. But let's say that we don't want to keep that for very long. What we could do is we could have some sort of job, right, that would run in the background that would just go and find all of the images that had null set on them, and then it would set it to some default image, right? Does that make sense? So you have an ingredient, it has an image. For some reason, the image gets deleted. Maybe it gets dropped out of our cache or something like that. So that at that point, for a brief moment of time, whether that's minutes, hours, days, something like that, it'll have an ingredient that'll have a null image, and then at some point we can run a procedure that goes and sets all of those to be default.jpg. That's what a procedure would be fit for. That is that's like the call sign for when a procedure could be useful. So let's run this query right now. Select star where image is null. Right now we don't have any. But let's just go insert something into our database. So we're going to put venison in there. And now if we run that again, we now have venison that does not have an image, right? So this is what I'm talking about. Maybe this would be another case where we'd want to allow people to insert things, and we don't want to like burden the process too much with all of this like setting things. I don't know, I'm contriving a very contrived example here. You would just in your code say call this default.jpg and call it good, and then make image not nullable. Bear with me for a moment, please. Now we're going to create a procedure, and it's going to be called set null ingredients to default. This is not going to be the programming language. This is actually going to be directly a query, so we can say the language is SQL. It's not the PLPGSQL. So all it's going to do is update ingredients, set image to default, where image is null, right? It's really just running a quick query. You can use PLPGSQL here, by the way. We just didn't need to. So now I have a procedure here that I can call at any interval. We created our procedure here. We haven't called it yet. We haven't done anything. If we call that query again, venison's still there and has no image. So again, we could use PLPGSQL here, but we don't need to. This is a simple query. If you needed to do some sort of for loop or something like that, you would need to use PLPGSQL. Now, we could have some sort of background job. We could have something in our database, or not our database, but our like app that would like reach out. There's a cron. We could have like an AWS Lambda that runs on some sort of timer that would call this. But anyway, something needs to call this function right here, which is call, what did I call it? Set null ingredient images to default. I'm just going to copy that because I don't want to write it again. Call that. It has no parameters. It could have had parameters. We just didn't give it any, right? We could have made it like some sort of like parameter to like what image that we're going to set it to, but we didn't. That's fine. We're just going to call that. So I called the procedure. Now if I come back here and say this again, it is not null. And if I say select star from ingredients where ID equals 127, which is what we saw right there, you'll see now that it has a default JPG. So we use call instead of select here. That's with procedures you call them, whereas with functions you select them. So we can invoke this procedure whenever we want to. And that's it. Now you might ask me, when would you ever use a procedure instead of a function? Because everything I just showed you could obviously do with the function. I don't know. There's not really a good reason. Procedures have just been around for a long time, so people expect them to be there. There's a bunch of stuff that's built on procedures. They are more limited. So if you believe in like the principle of least power, right, where you're trying to use the least powerful thing that can accomplish what you're trying to do, procedure would be that. Frankly, if it was me, I probably wouldn't put any of this in I wouldn't make a procedure, I wouldn't make a function, I would just have my code do it. I'd write some sort of lambda that would just query the database and then update all those things. Because again, if this lives in your database, it's not in your source control, it's really hard to track that business logic outside of your application. So I don't really suggest it. But I wanted you to know it's there. It is kind of fun. And when I'm doing stupid projects for myself, I really like to write stupid things like this.
Can you call functions and stored procedures from other functions and stored procedures?
Yes. You can do both. I don't know, I assume you can call a function from a procedure. You can definitely call a procedure from a function. Vice versa, I'm less sure. That seems like a cascading effect of terror.
Yeah.
But yeah, it sounds plausible. Yeah, question, Dustin.
If a procedure or function has to update millions of rows, will it be a blocking operation?
Let me answer that with a hand-wavy response, which is it's not any different than just calling a function, right? So if you have some sort of function that's going to tie up your database, doing it through a procedure or function is also going to tie up your database. So the call, the way it's called isn't going to make a difference in that particular case. The performance profile does not change coming from a procedure, function, or just a normal query. If you're in those kind of cases where you're like updating a lot of things and alter tables and things like that, you need to be more thoughtful than just writing a big query. You kind of have to like do that piecemeal through code. So triggers. Let's say you have a function that you want to run on some sort of event. That you want to, as soon as some event happens inside of your database, you want some sort of effect to happen afterwards. This might be one of the better reasons to use a function. Let's say we needed an audit trail of the names of our recipes. We wanted to see that this used to be called Bob's cake and now it's called Alice's cake and then it's called Eve's cake, right? And we wanted to have that kind of audit trail of names so that someone could go mouse over it and see what this used to be called. This would actually be a really prime case of where I would use a function and you would not be able to do this outside of, well, you could do it outside of a trigger. You could query like the name of what it used to be, then you could write it, and then you could write it to a different table. This would actually be really easy to write as a trigger. I might lean towards doing that because having the database handle this makes some sense to me. So create a table called updated recipes with me. There's nothing interesting here except maybe timestamp. Timestamp is just, it's a timestamp. There's not really too much interesting there. If you want to see what a timestamp looks like, just say select now like this. You'll see that is what a timestamp looks like in Postgres. It's going to keep the ID of its own ID. It's going to keep the recipe ID. You could technically make this a foreign key. I'm not going to because I don't want to, but this in all likelihood should be a foreign key. I have contrived examples and I didn't want to have to deal with constraints. Old title, new title, time of update, and timestamp. Okay, copy and paste that. I think originally I did have this as a foreign key and my examples weren't working and I got sick of it, so I didn't want to do it. Anyway. So we're going to create another function here. Nothing here is really that interesting. other than it returns a trigger, because a trigger is a specific type of function, right? And then I did a little bit more programming stuff here. So if old title, and old is like a specific name of like what it used to be, right? Because it's a trigger, it's going to provide both of those as these like environmental variables. So if old title is not equal to new title, right? So if it changed over the course of this, then we're going to insert this into updated recipe with all of the stuff that we asked for here. All this function does. Let's go ahead and copy and paste that into our Postgres. So now I have my function here. You can see there I have the set ingredients to null. That is procedure. This one is a trigger, and this one returns character variant. So the key part of this trigger is it's not returning anything because I'm never going to call this trigger. Postgres is going to call this trigger, right? That's why it has to return a trigger function. And then down here, we've created the trigger, but nothing. The trigger is not tied to anything yet. So we have to tell it you're going to react to this event. So that's what this does: create or replace trigger. You have to give it a name. So on an updated recipe trigger, that's what I called it. Anytime that the recipe table gets updated, I want this trigger to run. It's going to ask, is the old title different than the new title? If it's not, it does nothing. If it does get updated, then it's going to run, insert into this table, the updated recipes table. Okay? So that's what after update, you could say after delete. You could do after any of these other events that exist on recipes. If you update 10 rows, I want to run this function once for each row. That's what this for each row execute procedure log updated recipe name. Okay. So now if I run that, I have created my trigger. So now if I update anything, it's going to put stuff in there. Select star from updated recipes. You can see I have nothing there. Did I have a query here that, oh no, I have to make one up. That's fun. Update, let's see, select star from recipes limit 5. Okay, so let's update cookies. So update recipes, set title equal to, oh my god, cookies? I don't know, I'm running out of creative juices at this point in the course. Where recipe ID equals 1. So if I do this again, so it's actually not doing that, where ID equals 1. Oh yeah, recipe ID, rather. Oh my god, cookies. So there we go. So now I should see something. Actually, I have that query in here. And now you can see I didn't insert this, the database did it, but this is the ID of the change. The recipe ID is 1, right? Because I updated cookies, that was the recipe ID here. The old title was cookies, the new title is oh my god, cookies. Hashtag art, creative Brian. And then the time of the update, that happened now, so that's the time that it inserted into the database. And now we can have this kind of audit trail of what the name of recipes has been over time. So why is this useful to do this way as opposed to doing it in code? Now if anything updates updated recipes, we will get an audit trail of that no matter what. Whether that's someone in PSQL doing it, whether that's my app is doing it, my functions, a different part of the app, a different service, anything, this trigger will always fire. So this would actually be a pretty compelling use case for a trigger and a function, even though it is putting some business logic into the database. Like you can imagine, let's say I had someone hack my database and get access to my production keys. As long as they didn't have write access to this, we would still get an audit trail of something happening as long as they were not able to drop that table, right? That's a big if. If you get hacked, you're probably screwed anyway, but it's a thing.
Can you explain where old and new came from again?
Sure.
Are those just like keywords?
Yeah.
In SQL?
So when this is a trigger, right? So as part of the trigger function and specifically an update trigger function, it provides to you old and new of like, this is what it was, this is what it's going to be. You can do stuff based on that. Like something I could totally do here is I could prevent unwanted changes, right? So I could put some sort of like code here that says like, hey, if this is changing in such a way, don't apply the change, keep the old one. There's a bunch of stuff you can do. I just showed you one that's like creating an audit trail, but yeah, we're scratching the surface here because one, I really don't want you to use these that much. And two, it's not something I have a ton of experience doing because I really try to limit what kind of work I put into this. You cannot run procedures as triggers. I think I had that mistake in my last lesson, but that you can only run functions as triggers. Triggers always deal with functions, but there is nothing preventing you from calling a procedure from a function. But I would be upset if you did, probably. Because at that point, just write the function that does it, don't call a procedure. The more indirection you add to this, the harder it gets. So the next thing that we're going to do, I'm going to make you write a bunch of queries for yourself, and they're going to be hard, and it's going to be fun. So we've been dealing with like recipes up until now. Most of the rest of the course deals with movies. We'll have a couple things here and there with recipes because some of the concepts are demonstrated better there. But we're actually just going to use something called the Open Media Database, which is like this project here. See if it comes up. That it's purely like open source. It's just a community of people that are like updating that this website with modern movie information, right? So I found a project here that offers a database dump of it. It's actually specifically called out on the Postgres website as a good database to get started with. It's huge, so it has like 500,000 records in it or something like that, so we can run some really big queries, which is going to be really cool. I took the database dump and I put it on Docker Hub, which is this one. You probably pulled it earlier. If you want to see the Docker file, it's here. It's relatively simple. It clones it. It runs it in Postgres 14. It installs a couple of things. It downloads all of the various different queries, and then it runs the queries. I also put the recipe guru SQL file, that really long one that I had you download earlier. The exact same one is being run in here, so you still have access to the same data. I didn't put the triggers or functions in there. I also didn't put the JSON-B stuff in there. So everything before the JSON-B stuff is in there, everything after is not in there. So if you wanted to mess more with the JSON-B stuff, you'd have to start from there. Okay. So what I want you to do right now, if you're already running the complete Intro to SQL container, you are done. You have to do nothing else. If you're still running the Postgres 14 one, I'm going to give you two options. You can either leave it running. I think I'm actually already running it. I am. I'm actually already running this one, but I'll show you how to start and stop it. So we called the previous one PG. Just say docker kill PG. As long as you're fine deleting that database. You might not be, but we're going to be done with it, so it's fine. Docker kill PG. I don't have that running already, so that's fine. Mine's already gone, but I'm going to kill my SQL one as well. So I did docker kill SQL like that. Mine's not running, so it's not there. And then I want you to run this command right there. Docker run -e environment Postgres password equals LOL. -- name equals SQL. You can call it PG again if you want. actually don't, because we're going to use compose later. Call this SQL. It'll make a difference. The -d is for detach, -p for port. If you're going to keep the PG1 running, this won't run because they're going to be conflicting on the same port. So if you want to keep the other one running, just put this on 5433 or 534 or something like that. It has to be running on a different port. They can't bind to the same port. I shut my other one down, so I'm just going to leave it on 5432. --rm means delete all the logs when you're done, and then it's bt-complete intro to SQL, which will run the latest version of it because that's implied in Docker. Okay, you'll get this, which is just the hash of the container that's running. If I put docker ps, you can see here I have this one running. It was created 8 seconds ago, and it's called SQL. Now I can say docker exec, this one right here. So if you put this /omdb, it's going to connect you directly to that database. So go ahead and copy this whole thing. So psql is the name of the command, and then if you give it a additional command line parameter there or argument, it's going to connect to that database. So if you wanted to connect directly to Recipe Guru, that's how you would do that. But I'm going to connect directly to OMDB. And you can see here it says OMDB. That's how I know I'm connected to the right database. If I do \d, you can see here I have a bunch of movie tables. And if I do \l, you can see I should have Recipe Guru there, so I can do \c to Recipe Guru. That'll connect me to the recipe database. I can do \d here. You can see my tables are in fact still here. So \c, we're going to go back to OMDB because that's the one that we care about. I'll do Command L. So we saw the databases, we saw the tables. So a little bit about some of these tables. First of all, a very useful thing for you to see, if you do \d and then the name of the table that you're trying to understand, it'll show you everything about that table. So I put \d movies here. ID, name, kind, series, runtime, so on and so forth. It's got some foreign keys, that's great. I'm going to say select star from movies, and I'll say limit 5. You can see here, if you make it smaller, it'll be easier to read, but I have a big screen because I'm on, projecting here. But you can see, I can see the budget, the revenue, the home page. Finding Nemo is one of these. And then let's just select count star from movies. You can see we have 178,000 movies for us to select from. This is relatively unoptimized, so some of these queries are going to be really slow. We're going to talk about optimizing queries later. But in the meantime, I'm going to ask you to, and I think this is a useful exercise for you. You have all of the tools already to answer all of these questions. They're going to require you to kind of explore the data, look at the tables, figure out how the tables connect. This is all stuff that I did. But I've taught you everything that you need to do here. It just might be hard to put it together. But that's hard. Struggling will teach you. So I'm going to give you some time here, but these are the questions that I want you to answer. Which movie made the most money? Order by is going to be your friend here, particularly is descending order. And some of these have null revenues. You can use coalesce column name and 0 to say if it's null, give me 0. Or you can also say order by, I think it's revenue is the name of the, and then you can put nulls last. It'll actually incorporate that into your order by. This one, there's no joins here. It's just you're going to do an order by basically. How much revenue do the movies Keanu Reeves act in make? So casts is the name of the connecting table between movies and people. You're going to have to do multiple joins here. And you're also going to have to use something that we haven't used so far called sum. So just like we have select count star, which we did, right? We can also do select sum of revenue. This is how much money all movies have made in this database. That's what sum does. I think if we do average, it might get upset. Oh no, this is the average as well. This is not going to be totally accurate because a bunch of these movies don't have revenue information associated with them, but another aggregation function like count. You treat it exactly like count. Which 5 people were in the movies that had the most revenue? Probably, the answer probably won't surprise you. So these two are really similar, but it's kind of inverting. One's looking at Keanu Reeves specifically, so you're deriving that from the people table, whereas the other one's deriving it from the movies table, right? Which 10 movies had the most keywords? So there's a movie keywords table. There is a categories table that names what's the movie keywords, because if you look at movie keywords, it has a movie ID and a category ID. It actually doesn't tell you what the name of the category is. The name of the category exists in the categories table. So you're going to have to join multiple times here, right? It's a many-to-many relationship. And then which category is associated with the most movies? Another thing to note about this database, there is German, English, Spanish, and French all in this database as well. So this one, for example, I think there's actually quite a bit of German stuff in here. So if the most common one might actually be German. So don't be surprised if that's the case. Bonus points if you can tell me the English ones or the German ones, I don't care. So hopefully the brain is going. You're thinking about this. Just start typing some queries, see what happens. If you click here on the next one, all of the answers are on the next page. So again, I just want you to learn. I don't care if you get it right or whatever the case. I just care that you're learning about it. So do whatever you have to do to get there. So hopefully all this was super easy, no problems. I'm just kidding. These were all really hard. So if you struggled with them, I also struggled with them. So which movie made the most money? This one shouldn't have any joins in it, but let's kind of just go through my process of how I would figure this out. It's obviously going to come from the movies table, so let's describe the movies table. We have a revenue, which is numeric. Okay, so basically we want to get names and revenues back, and then we just want to order by revenue. There's a couple ways we can go about this. So let's try this. Select name, comma, revenue from movies. Then here, let's just naively, we're just going to do order by revenue. And like limit 5 or 10 or something like that, right? This is our first problem that we run into, is it's putting these, well, so right now it's ordering in ascending order, which is not useful because we don't want movies that have 0, right? We want movies that actually have revenues, so we're going to do order by descending. We still have this problem here. What it's actually doing is it's giving us back like series and episodes of TV shows because they're also mixed in there, right? Those obviously don't have a box office revenue, right? So that doesn't make any sense. So we need to get the null revenues to the end because right now it's sorting those as the top, right? We don't want that. 2 ways to do that. The way that I have here in my notes, we just used coalesce again. coalesce revenue, and if there's nothing in revenue, then make it 0. That works, right? Because that makes anything that's null 0. You could also do, and this is probably actually more appropriate, nulls last, I think is what it ends up being. Yeah, nulls last. You're just telling it, put the nulls last when there's a null there, right? You can also do nulls first, right? But that's actually the default behavior, so this is just redundant to put nulls first, but just so you know, that is possible. So even though this is not what's in my notes, this is actually probably the more correct one. But I didn't show you that till now, so I'm not expecting you to know that. Okay, so how much revenue do the movies Keanu Reeves act in make? Which I recognize is a weird question, but like basically what's the box office of all of Keanu Reeves' movies? So we're going to start from movies, right? Because we want to know all of the movies. So that's going to be our from table. So select. Then we're going to do a coalesce here as well of the sum of m.revenue 0 as total. I actually don't know if we need that coalesce, but we'll see.
Wouldn't you want total to be lower case?
Oh, so yeah, you're right. I mean, it would work. It would just be weird. Okay, from movies, inner join. We're going to join on casts, right? Because that's going to be the connection between movies and people. So casts C, let's see, and then we need an on, m.id equals c.movieid, right? Because that's the connection in cast, because cast is just movie ID and people ID.
I don't think you aliased movies as M, so.
You're correct, I did not. So select.
So I found it to helpful to write the stuff in like a code editor and then paste it in.
Yeah, it's typically what I do as well. But we're here, so we'll do it this way first. As total.
I think you're missing a close parens.
Yep. All right, maybe we will just do this in my editor. We'll get nice syntax highlighting as well. All right, here we go. Select, coalesce, sum, m.revenue 0 as total. Actually don't think we need that coalesce, but I'm going to leave it in there because that's what my notes have, and then we'll go back and try it without. Movies M, inner join, casts C, on, m.id equals c.movieid. Then we're going to inner join again, people P, on c.person ID is p.id, where p.name equals Keanu Reeves. All right, let's check that one out. So this is the amount that Keanu Reeves movies has done. Let me try just removing this coalesce. I'm trying to remember exactly why I had to put this in here. It might have not been necessary. It's not. Because that would basically say if this entire sum was null, then make it 0, which is nonsensical in this particular case. So it wasn't necessary. Cool. That sounds good. Any questions about this one?
I was trying to order by his most popular or his highest revenue movie.
Which doesn't make any sense because it's summing them anyway, right?
Well, no, I misread the question. So instead of sum, I was just like, hey, what movies did Keanu Reeves, which one of his movies did the best or whatever?
So, I mean, you could do m.name, m.revenue. I think this will give you back all of his movies, right? With their revenues, which it does.
Yeah, that's where I was at, yeah.
Order by, not order boy, thank you. M.revenue descending nulls last. Was it nulls or null last? Yeah. So there you go.
Cool.
That would be that one.
Keanu Reeves was in Toy Story 4.
Was he? Yes, no, maybe, I guess. According to this database, it is.
That's
Buzz
very,
Lightyear. No, I'm just kidding.
that's very cool data.
Pretty fun, right?
Yeah.
Which 5 people were in the movies that had the most revenue? And for me, when I wrote this query, it was just like a slap on the head. It's like, of course that's true, right? Keep in mind that it's not like starring, right? It's just like the person that appears in the most movies that makes the most money. I don't know, I thought it was fascinating. All right, so we're gonna say select p.name, person.name, coalesce. This again might not be necessarily again. Sum of m.revenue, 0 as total from movies m. Again, we're going to inner join on casts C on.
Would it make more sense to have your coalesce inside your sum to rule out anything that is null and call it a 0?
Yeah, I mean this is probably why I was just like copying and pasting from other queries, which is why this doesn't make any sense, which I think just means that it's not necessary. Because once you start trying to do math with null, it just automatically gets made into a 0. Yeah.
Yeah, I did it without the coalesce and it worked fine.
Yeah. I was probably still hungry from all those recipes that I was writing, so I was just not thinking straight. Typical Brian stuff.
Thinking about Pokemon.
Just think about Pokemon. Okay, so inner join cast C on movie ID equals cast.movie ID. Then we're going to inner join people P on C.person ID equals P.ID. We're going to have to throw a good old-fashioned group by in there. We're going to group by person ID and person.name. Reason being is people can have the same name, right? So you want to make sure that the person itself is named, because this p.name is not guaranteed unique. I'm sure that there are actors and actresses in here that have the same name. In fact, that would be a great query for you to write at some point as well. Find me all of the people that have duplicate names in the database. We don't have that right here, but you could totally write that.
Why doesn't grouping by p.id alone rule out that possibility?
It could, but you need to put name in here because you want to use it up here. In this case, we were talking about like those nonsensical grouped by statements if I try and select for things that aren't going to be grouped. In this case, we know that ID and name are relatively unique, right? So by adding that p.name, you're not actually changing how it's grouping by, but you still have to let Postgres know, is like, I'm going to use this up in the select as well.
I only grouped by PID and it worked.
It does?
Yeah.
That might just be habit of mine then.
Weird.
All right, so we'll try it without. Group by p.id, p.name, order by the total, which is this one up here, right? And then I'm just limiting it to 5, but you could put like 15 here or something like that, whatever you want. Let's try that. L. Oh yeah, and then we have to do total, and then we have to also do nulls last. Oh, you know why? So this is why I had this coalesce in here, is so that I didn't have to do the nulls last. Because that would coalesce them to 0, which means I could sort by this without any additional nulls last logic here. That's why that coalesce is in that query. Which one's right? This one I would say is slightly more right, but they both end up with the correct answers, so. All right, so let's try that again. So Stan Lee, which you think about it because he's in every Marvel movie, makes sense that his movies made the most, right? Because those the Marvel movies make stupid amounts of money. Peter Jackson, the director, he's on like King Kong and all those kind of movies, that obviously makes sense as well. George Lucas, Star Wars. Samuel L. Jackson, because he's just in everything, which I'm not complaining about. He could be in more movies and I'd be fine with it. Kevin Feige, he's the Marvel guy. Hans Zimmer, makes sense. Pretty cool, right? So those people were associated with the movies that had the highest box office. Like I said, obviously Stan Lee is not starring in any of these Marvel movies, but he appears in all of these. I'm also going to say that this database I think is pretty incomplete, so don't be surprised by that.
It would be nice if we could add a where clause for just acting in a movie.
So
Something like that.
That's actually a good point. And how would you model that data? Like, where would you say acting, like where would you put that piece of information in this database?
So you've got the people, and then you have the link between them. What was that? Casts?
Mm-hmm.
Probably in the cast somewhere I would have a like role ID or something in a role table.
Yeah, so let's take a look at that. Because it might even be there.
Oh, job ID might be it.
They actually did there.
As I say, they have a role in there, but that's just like the name of their character.
Yeah, but job ID could
Job
be.
ID is probably that, yeah.
Limit 10. Okay, so what's the position?
Jobs, maybe? Or job names.
It's just jobs.
Okay, so you really could figure out the acting. So this is the point that I actually wanted to get to here. One of the things that you could call these are edges, which is more of like a graph database term, that it's describing a relationship between the table. So for example, in recipes and ingredients, an ingredient is just in a recipe. We didn't actually describe that relationship at all, but the relationships between movies and people is actually a bit more nuanced, right? It's not that just a person belongs to a movie. You have people like Stan Lee that just shows up, right? He's not really in that movie. You don't think of Stan Lee as the biggest actor in the world, despite the fact that he turned up at the top of our list, right? So what you would have to do is you'd have to go and describe it in the edge of basically like, here's the relationship between this person and this person. So here it actually does that. I didn't realize that it did, but that would actually be a great... Another step that you could take here is I want you to go query for the person that acted in the most, highest revenue generating movies. That would be another inner join that you could take, actually another 2 inner joins, right? Because you have to join to, actually, nope, it's just one because it's described here. Anyway, you'd have to join to position to jobs to figure out where it was actors, right? Or you can go see who was in the camera department of the most, best movies. More interesting questions that you can ask here.
The most lucrative cameraman.
Most lucrative camera person ever. Yes, I would like to see that. Someone let me know. Someone, before this class ends, I want someone to send me a message saying who is the most lucrative camera person of all time. Okay, any questions about this query here? So just to circle up why I had coalesce here, sum 0 like this, and then I didn't have nulls last here. Same thing as last time. You have to tell it what to do with null. In this case, I didn't want to tell it when I was writing this query what to do with null, so I just made all the nulls 0, and then we end up getting the same thing. Also notice that this query is a little slow, right? I have a brand new, this is an M1 Max. Notice it's taking a hot half second to run a query, which for my Mac is quite slow, right? It's a big query, right? You have 2 joins, and then you're doing an aggregation step and then an order by step after that. That's quite a few steps. Again, we're not quite to this section yet. I think it's next. But if we put the analyze on here, this is 166,000. That is we'll talk about cost here in a second, but that's a big query. And I'll show you in the next couple steps here of how to optimize that. But you can see it took over a half second, and it'll usually tell you how many rows it looked at. So this looked at least in this part, 261,000 rows. This one looked at 444,000 rows. It's pretty wild stuff, right? How many rows are in casts? Select count star from casts. So there's 1 million rows in the casting table. It's wild, right? We have the movie keywords table. We have the categories table. So we have to start from movies, then go to movie keywords, which is a connecting table to categories. So we have to go from movies to movie keywords to categories. So we're going to say select m.name, movies.name, and then we're going to do a count on c.id from categories as count. So this is going to be like how many different categories are associated with one movie, right? We're going to start from movies M. There's other ways to write this query, by the way. This is not the only way you could do it. Just the way that it occurred to my brain. Inner join movie keywords MK on mk dot movie ID equals m dot ID. Inner join categories on mk.category ID equals c.id. So movie category ID equals the category ID. Good so far. We're going to group by m.id and m.name. Order by count descending. There should be no nulls in here, right? So I don't have to do the nulls last because the count is always going to return a number. And you can limit here by however many you want. I'll just do 15. Let's check to make sure that works. So this is what I'm getting for movies that have the most keywords. I looked some of these up. This is, I think it said Croatian, or according to Google Translate. This one was, what did we decide? It was Hindi, right? And a bunch of these came back as Hindi. Mogambo came back as Basque, which I'm going to guess may not be correct. It could be Basque. Three Idiots. I'm guessing that's English. I don't know what that is. Anyone know what that is? Kind of a cool script.
It looks like Hebrew.
I don't think that's Hebrew. Anyway, those are the movies that have the most categories associated with them. So, I mean, if this was my database and I was running a website with it, I would look at this and say, like, does that one Croatian film really need 200 categories? That's probably more than a category a minute. I have a strict rule that you cannot have more than a category a minute. What category is associated with the most movies? So this is kind of flipping the question on its head, right? So we're going to say select c.name count mk.category ID. There's a bunch of things you could have counted. That one's just one that made the most sense to me as count. So we actually don't even have to join the movies here, right? Because we don't actually need the movie names at all. We just need to know how many connections it have, which movie keywords is more than enough to tell us that. So we're going to say from movie keywords mk inner join categories C on c.id equals mk.category ID group by c.name mk category ID. Order by, again, count will never be null, so we don't have to worry about nulls last or anything like that. Doesn't hurt to put it here. Probably incurs a little bit of extra work on Postgres's part, but doesn't actually really matter. Limit 10 or something like that. All right, so let's take a look and see if we get back. And you get some, I think most of these are German, because most of the keywords I checked were either in English or in German. Unsurprising, falling in love is associated with basically every movie ever.
It's on the list twice.
Yeah, it is, isn't it? I would bet you it's because they're in different languages. So you could put like a where in here. I think this would go here, where, and I gotta remember categories has a relationship. Oh, not, sorry, not D. Categories. Name, root ID, parent ID. So you might have to like describe movie keywords. Okay. One of these tables you can eventually join to that will tell you what language something is in, right? And then you can limit it down to like English. And I started writing that query and it took like a couple more hops. I was like, I don't want to make people write this because I don't want to write it. And so we stopped here. So for now, it's sufficient to say that we have a bunch of German keywords in here and that's fine. But all those father-son relationship movies, they're just great. Or killer movies. That's a lot of killer movies. Okay, any questions about this query?
No, but I will say that I messed up at first because I didn't put the group by on the MK category ID, and that put falling in love together.
See, this is a reason why you'd want to do that.
So, pitfall.
But let's try it.
the first keyword on that list means assassination or murder.
Nice.
So there's more killing movies.
More killing. Nice. Except not nice. That's because I have where in here. There we go. But that's why it's useful to group by, because you can see here falling in love obviously jumps way up here because you probably have a bunch of movies that have falling in love English, falling in love French or something like that, or falling in love German. It's probably German if we're being honest. And it's combining those into one, which makes falling in love look like there's a lot more of it, right? But it's probably double counting a bunch of those connections. That's a guess, by the way. I don't actually know. But there's ways you could write that query to exclude it where it's pointing to the same movie as well. What'd you think? How was this? Was this a useful exercise? Stretch your brain a little bit to figure out how to write some queries? This is honestly my favorite part about writing queries is like having a question and then using SQL to solve it. That feedback cycle is like the most fun part about data for me personally. I'm going to show you how to use a GUI for this. So far, I've been doing everything in the command line. Honestly, this is how I work, but I really like command lines. That's why I teach a whole class on the command line because I like it so much. I know not everyone's in the same boat as me. There's lots of tools. I've seen people using various tools throughout the day, which are all great. I'm going to show you how to use like a web-based one. So having learned MySQL first, it was the first relational database that I used extensively at work. It comes with PHP admin. Basically, everyone that uses MySQL has at least used PHP admin to some degree. There is a very similar project for Postgres called PG admin. There's another one that's also called like a PHP Postgres admin or something like that. That's actually almost a clone. So if you want to use that, you can. Anyway, we're not, but I am going to show you how to set up PG admin. So I'm going to kill my SQL database right here. And then this directory that I'm in right now. It's just the same. It's the same one that we've been working in with all of our projects. You'll notice that there is a Docker Compose file that I checked in there that looks just like this. You don't have to know a damn thing about Docker Compose. I do talk about it in my containers course if you want to learn more about Docker Compose. But all this is going to do is it's going to start two containers. It's going to start the container that you and I have been working with, this one, the BT Holt Complete Intro to SQL. And it's also going to start another one called PG admin, which you can see I'm pulling directly off a Docker Hub. It's just a web server that connects to your Postgres database that can run queries for you. Okay, so keep in mind that I gave it a default email of admin@example.com. You will need that here in a second, and the password is the very safe and secure password. Yeah, highly suggest you use this for all of your passwords all the time. Okay, and then it'll be exposed on port 1234. So you should be able to come in here. Notice I have nothing running in because I killed my container. If you don't kill your container, it's going to conflict on the port, just so you know. I'm going to say Docker compose up. Now I have all this stuff already downloaded and ready to go. There's a good chance that you are going to have to download the PG admin container, which will take a little bit longer than mine. But once you see something like this that says Postgres apps -PG admin-1, well, this part was probably different. But this part, the PG admin-1, is probably the correct one. Once you see that that's working, you should be able to go to your browser and go to localhost :1234. You'll see something that looks a lot like this. Okay, put in your super secure, very top secret admin@example.com. and password, because we are people of class that use secure things. Huh. I literally updated this yesterday and they released a new version. Typical. Anyway, I pinned it to 6.12. You can probably update this to 6.13. I doubt much changed. Okay. By default, it will not connect to your database. You actually have to go and set that up. So I had that step by step with pictures here. You're going to click Add Server. You have to add a couple of things. And then once you've done that, it'll connect to your database. So let's go ahead and do that now. We're going to add new server. Give it some sort of name. Does not matter. I called mine DB. Click on Connection. The host name is going to be DB because this is on a Docker network, so it actually names the name of the host, whatever you called it. We called ours DB if you look in your Docker Compose file. Port 532, that's exactly what we want. Maintenance database is Postgres, that's correct. The name of our user is Postgres, and the password, if you remember, again, very secure passwords here, LOL. And you can save the password there, and you can click Save. Lo and behold, we now have all of our stuff in a nice little GUI for us to interact with. So I am by no means a PG admin expert. I don't really use it very much, but it is undeniably a very useful tool. So if you prefer a GUI, here you go. This is what you get. This is what I'm giving you. You get no more from me. The thing that I did find useful in here is we can just like click Query Tool, which is right here, or you can also use Tools, Query Tool. You can come in here and say, looks like it's connected to Recipe Guru. Let's connect this instead to server DB, database. You can switch it to OMDB right here and click Save. That's fine, I don't care. Postgres, so you can see here now I'm connected to OMDB, Postgres at DB. We are going to select star from movies. So you can see you get like a nice little autocomplete here. Limit 5 and press play. You can see here I get like a nice table output of all the stuff that I got back. Again, I don't really know very much about PGAdmin. But I think if you go back here to dashboard, you'll actually get like a bunch of information about it. You can see the sessions that I've had, the transactions per second, how much it's blocking out, tuples, tuples, whatever you want to call that, in and out. Pretty cool stuff. I showed you how to set it up with Docker Compose because that was easy for us to fit in. But you don't have to use this with Docker Compose. You can just like set up PGAdmin locally on your computer. It's just a web server. I think it's all written in Python and Flask, if I'm not mistaken. All right. So you have the instructions there. You can see how to do it yourself. You can leave this up if you want to. You can write the rest of the queries for the rest of the class on this if you want to. I'm going to go back to the command line because that's my safe place. So you and I just finished the movies database portion here. We looked at the exercises, we looked at the answers, we looked at PGAdmin, all good things. We are now going to get into query performance, which honestly, like, is one of my favorite parts of this because, like, it's cool to see something that goes really slow and then to do something and then watch it go really fast. Like, that's a really rewarding cycle for me. And so I am by no means a query performance expert, but I am going to show you the very low-hanging fruit of how to speed up a query. You've already seen me use a couple of times say explain, analyze on some of these. So I'm going to say Docker PS, you can see here, I would like to connect to this one, which it is calling Docker apps DB1. So if you're going to continue using pgadmin, just make sure you're using the correct name to connect to your database. When I say that, when I say docker exec here, instead of having SQL, because that's what I was calling it, you're going to call it whatever it says right there, which is probably not Postgres-apps. It's probably whatever the name of the folder is that you started your Docker Compose in, which is probably SQL-apps, is what I'm guessing most of you are seeing. It just has to be whatever the name of your container is. So now this will work for me. If that's not working for you, because I'm not going to be using it anymore, you can also just say docker kill blah, docker ps. You can also kill the other one as well, docker kill blah. Then you can say docker run. This is the one that I called SQL, right? So that's running again, and I can just say docker exec SQL. Anyway, point being, you have to call it the correct thing, whatever the thing is. Hopefully I showed you how to do that. That is up to you. You can also, if you're running pgadmin, you can continue running all of the queries in here as well. That's totally fine. But I'm going to stick to the command line. So here we are. Okay. So I want to look at two different queries with you. Select star from movies where name equals Tron Legacy, which I have an abnormal love for this movie. It's not a good movie. I'm not asserting at all. The story is awful. But it's like, it's one, the music. You can't deny the Daft Punk soundtrack is amazing. And two, it's just a beautiful movie. Try that again. Okay. If you see this from time to time here, either your container is having a little blip, or your container could also not be done starting up yet if you connect too fast to it. Because what happens when this container starts is it starts the container, then it runs a bunch of queries to seed all of the data in it, and then it's ready to query from. And if you do that too fast, it's a problem. Okay, anyway, enough about my weird love of the movie Tron Legacy. You can see here that when I queried, I said select star from movies where name equals Tron Legacy. Okay, I'm going to do a second query here, select star from movies where ID equals 21103, which you can see here, they are both getting exactly the same movie, right? So looking at these two queries here, which I just put right there, which of these queries is going to perform better?
The second one.
The second one, this one right here. Why? There's a couple reasons.
Yeah.
Name is like a filter versus ID is a key.
Yeah, that's a good way of putting it. So when you do where name equals Tron Legacy, it doesn't know ahead of time that there's only going to be one Tron Legacy. So it's actually going to look at literally every row, all 178,000 rows in our table, looking for Tron Legacies. ID is a primary key. It knows that there is exactly one. Furthermore, it's also indexed by default because it is a primary key. So it doesn't actually even go through row by row. It actually uses a separate data structure called a B tree, as in like a computer science self-balancing tree, to go and find exactly the thing that we're looking for. Now, how would we ever know that beyond just that you know that? Well, first of all, if you look at movies, oh wow, there's a lot of constraints on this. But let's look at movies P key. You can see this is a primary key that is using the B tree based on the ID. In other words, this has an index, right? So if I say explain select star from, actually I can just add it on the front of anything, if I say explain on this, you can see right there it uses what's called an index scan. Anytime that you see an index scan, it means that you're doing a good thing, right? If the Postgres planner, which is what this is called, if the planner is selecting to use an index, it means you chose a good index ahead of time, or you wrote a good query to use an index. If we go back to here and look at this one and I say explain, you can see it uses the dreaded sequential scan, which just means it starts at the top and just looks at every single row, row by row. This, you can see here, based on the cost, is wildly different than the other one. The second number here, 8.44, tells you the total time. So this took 8.44 units. We'll talk about the units in a second, but just know that it's relative. This took 8.44 units to find this movie, the Tron movie. This one took over 5,000 units to find. This is many like magnitudes better because it was able to use an index. Yeah, so my computers are even running slow today. So that is the one thing about this cost thing, is your computer is measuring itself. So I actually measured this a couple of days ago and I got better performance a couple of days ago. So my computer is just running slower today. So it's not an exact science, it's just your computer measuring itself. So I'm gonna get different numbers than you, I'm sure. I'm sure you're probably not seeing 5,006, you're probably seeing something else, right? Okay, so explain is the abbreviated output. If you want the expanded output, you put analyze. Explain, analyze. And you get a little bit more on here. It'll give you actual times. It'll tell you how many loops it went through, what the filter was, how many rows removed by the filter. That's actually a pretty useful one to know. You can see here that it removed a lot of stuff, right? So let's look at the one where it's the ID is. Okay, this one uses an index scan. It doesn't even have to remove rows, right? So because that's not really a concept. It knows that it's looking for exactly one thing because it's using an index search for it. So let's talk about a few things here. Let's talk about the cost. So the cost here, and I'm borrowing this from another blog post. I left a link to it if you want to read it. It's cost units are anchored by default to a single sequential page read costing 1.0 units. So one page read it considers to be a thing, right? It anchors it to that cost because that's going to differ between platforms, right? This might run, my computer's running ARM, right? Yours is running x86, right? That might run faster on different computing architectures or faster in Windows, or faster on Linux. So it's done so that you can compare apples to apples on one computer. We shouldn't be comparing from my computer to your computer because it's going to be different. So it's a relative unit, and it's meant to just so you can say this one runs faster than this one on this computer. That's really all of the point of the cost. The second number is the total cost that it went from I clicked enter to this ran to completion. The first number is the setup. So you'll notice on the sequential scan, it has a setup cost of 0. That makes sense because it doesn't set anything up, it just starts going. It picks the first row and it just goes, right? This does because using the correct index involves accessing the tree and then going through the tree and finding the thing. That's not free. This is where it gets really confusing for people that are using indexes. Let's talk about what an index is before I get much more into it. You can tell Postgres in advance, I'm going to query using this kind of shape, this kind of pattern in advance. What Postgres then goes and does is it takes all these things, it assembles a separate data structure that is optimized for searching. So if I say I'm going to be searching a lot by name, if that was something that was really important to me in my application, I can say, hey, Postgres, go create an index on name, and the next time I try and do a search like this, it'll use the index instead of using the just sequential scan. And I can speed up this query by quite a lot, which is pretty cool, right? That's the entire idea of an index. And it uses what's called B-trees, which is a type of self-balancing tree. Just to give you a little preview of what that actually means, in my other course, The Complete Intro to Computer Science, which again is on Front-End Masters, I actually teach you how to write one of these. In this AVL tree lesson, basically it creates a tree like this where it can go find those things really quickly, right? So instead of having to look at literally every record in the database, it actually goes and finds it using a tree, which is a logarithmic growing thing. So if you add another 1,000,000 rows to the database, that tree doesn't grow very much. What I'm showing you here is actually what's called an AVL tree, which is a very simplified version of what a B tree is. A B tree is much more complicated, but it ends up being much faster to look things up in. Okay. So that's what an index is. There are other types of indexes besides B trees, and we will look at those here in just a moment. So I just wanted you to see a much more complicated query. I'm trying to remember what this one is. This might be one of the answers to one of the previous ones. Yeah, this is the movies with the most categories, I think. It is. So let's do an explain analyze on this, because this is obviously going to do a lot more. So you can see here, its cost is 53,000. Keep in mind that the one that we did in the previous one was what? About 5,000, right? So this is 10 times slower-ish. As opposed to like our index lookup, which was what, like 0.75 or something like that? No, it was 8.44. So this is magnitudes slower. But here you can see that the sort cost this. Most of the sort's cost was in its setup. It had to sort 183,000 rows. That's a lot. It's sorted by the count. It did a heap sort. I don't know anything about sorts, so I don't know how it chooses that. Grouping, it did the grouping by m.id. Did a merge join, or did a merge condition on this. You can see here we did hit an index scan here using the movie's P key. That's cool. Index only scan, another good thing to see. You hit some, anyway. Planning time, execution time, that's always something interesting to look at as well. So let's talk just a moment about the Postgres planner. One of the reasons I chose this database for us to use in the course of this class is there's a lot of rows on it, which means that we're actually going to hit some occasions where indexes are going to be really useful. The Postgres planner is really smart and usually smarter than you. There are times that like you're analyzing some query and you have some index that you put in there and created for it, and Postgres's planner is like, nah, I'm not going to use that. I'm still going to do a sequential scan. And it's usually right, because it'll look at how many rows it has to filter. It'll look at how many rows are in the table. It'll look at all sorts of other variables that you and I are not looking at. And usually it will select the correct thing that will be the fastest. So that's the point of the Postgres planner, is to look at all the tools that it has to work with and then choose the correct one to do your query. So in other words, if you're working on a really little table, like if we were trying to do indexes on the recipes table, it would almost never use our indexes because it's such a small table. There's like 300 total things in that table. Postgres can just burn through that really quickly with sequential scan. So it would just use sequential scan on everything. Because again, remember, the setup for indexes is not free, which means frequently the cost of setting up to use an index will exceed the cost of doing a sequential scan. So it'll elect to not use your index. Does that make sense? So don't get frustrated if it's not using your index. That's my communication to you, is frequently the planner is a lot smarter than you are when it comes to query performance. So the reason why I show you this big complicated thing, let's say that you were running this a lot. For whatever reason, this was a really important query to your application. You could run explain analyze on this and say, well, this is kind of expensive. I don't like how expensive this is. You can go in piece by piece and figure out where the slow parts are, and then you can try and optimize those parts of the query for indexes. Because this is too complicated of a query to just say index this query. Doesn't make any sense. You have to index parts of the query. So if I was looking at this and this was a really important thing to me, like this part, right? This has like no cost, so you would totally ignore this part of the query. You would not try to optimize this. This one right here, you would totally ignore this because that's really fast. You start getting into these ones, okay, these are things where I could look at them and say, there are gains to be made here, possibly. So you look for these parts that have big numbers, and you're like, okay, I'm going to try and see if I can figure out how to write indexes for these. But just like general programming practice, you don't want to go and try and optimize everything from the get-go. Generally, you kind of want to have a problem before you solve a problem, because if you're trying to solve problems before you have them, you almost always solve the wrong problem, right? So that's my advice to you with indexes. They're not free, because now the Postgres planner has to look at every time, it's like, should I use this index or not? That's not free. And some of these indexes get huge, right? Because you have to think about it. If you have 175,000 rows, there's 175,000 entries in a B tree. It's not free, right? And it has to keep that up to date. Every time that you insert a new row, it has to go insert that, then rebalance the tree. It's additional overhead. So if you're creating indexes, make sure you're using them. If you're not using them, then drop them. So we talked about index. We talked about it that it's okay, sometimes your Postgres planner will choose not to use an index. We talked about a little bit about unique. So if you set unique on some sort of row, column in your database, that actually ends up being, by necessity, an index. So let's go look at, I have a good example here. So if I was creating this American addresses table, it'd have its own ID. This primary key would be the ID for it, right? So this would have its own index because it's the primary key. And then I would have street address, city, and state. And if I'm having some sort of database, or sorry, some sort of table, street addresses, I'd want that to be unique, right? I don't want to have two entries of a person that lives on, 123 Main Street, right? Because I'm pretty sure there's a 123 Main Street in literally every city in America. So I can't have street address by itself be a unique index. It probably can't even be for the city, right? Because there could be in different parts of the city, or sorry, there could be Springfield in Illinois and Springfield in another state, right? So you can't do just street address and city. You have to do it street address, city, and state, which you can do with this unique constraint here, right? And this will actually create an index for you. So when you start searching for addresses by complete, with street, city, and state, you'll actually be using an index. So that unique constraint can be useful for more than just keeping things unique in your tables. It can also be really useful for lookups. It also helps for insertion performance. Because if you had a unique constraint without an index, every time that you inserted something into your table, it would have to look at literally every row in the other table to make sure that it was unique. That's too slow. That's why it creates an index for you.
Sorry, maybe I missed this, but does that create a new column?
No.
No, okay.
This does not create a new column. It just creates a constraint. Going back to my query that I've been writing. Let's do this one. Let's say it's absolutely critical for me that I need to be able to query by movie name. If I'm writing a movie searching application, that seems very reasonable that I would search by name. So let's create an index on it. Because 5060, pretty expensive for something I'm going to be doing a lot, like some sort of code hot path. So I'm going to say create index, call it whatever you want, index name, that's a pretty common one to call it, on movies, the name of the table, name, the name of the thing that you're indexing on. $178,000 rows is actually not that much to Postgres. Postgres can deal with billions of rows, so that's why this is still really fast. Now if I run this again, I went from 5060 to 1230. A little bit of a performance increase, right? You see that I went from a sequential scan to a bitmap heap scan, which is another kind of index scan. In fact, you see right there, bitmap index scan. The reason why it's not quite an index scan is because there still could be multiple Tron legacies, which is true, right? This took 27 milliseconds. This took, well, you kind of have to look at these combined together. So this took, 27.5. This took almost 2 milliseconds. So over a 10x speed up. It's kind of wild, right? That it was that simple for us to do that. So a well-placed and a well-created index makes a huge amount of difference. It's just really hard to pick the right one. But when you get it, it's so sweet. I'm showing you very simple examples. It's on purpose because, one, I have a really hard time myself identifying the correct ones. And normally you have, like if you're doing something like I showed you, that really long query, I usually have to go find someone that's like really advanced in databases. They're usually not even an engineer. They're usually some sort of operations person or like a consultant that actually works for Oracle or something like that. It's a whole separate pool of talent to have of choosing the right index.
Can you just do delete index as well?
I think it's drop.
Drop, okay.
Yep. Okay. So yeah, closing that loop on that, I've created maybe like 3 indexes professionally at my day job in my entire career. It's almost always been an operations person that's gone in and like actually done the identifying the slow queries, finding the index, working with engineering to get that set up, all that kind of part. It's normally a team effort, not just some cavalier engineer saying like, I'm going to write some indexes today and speed up the application. It's normally not that easy. We are going to do some more interesting indexes here in just a second. Specifically, we're going to do some, we're going to use views together with indexes to make some really huge performance benefits. But I wanted to talk to you a little bit about what kind of other indexes you can have. I showed you B-tree, that's the default one. It makes sense for looking for exact matches on things, right? Or doing ordering on those kind of things, right? There are a few more to talk about. We're about to talk about GIN indexes, so I'll leave that for us to talk about GIN indexes. There's hash indexes. That's really useful if you're doing strict equality checks for things and you need it fast and in memory. But it cannot handle anything other than, does this equal this? Whereas like a B-tree can order things, right? You can say, hey, use the B-tree index to sort this for me. It does that really fast too. We did that already. Just to show you, explain, analyze. Order by name, limit 10. So again, notice this used index scan. So it's using the tree to order by. We got that for free because it comes with B-tree. The other cool thing is you're not limited to ascending, descending. It actually is really, you can see it says index scan backwards. It's actually able to use indexes backwards as well. That was not always the case. You can actually tell it to index things backwards if you're going to be doing descending, because obviously it's actually literally the same. So in this case, it doesn't even matter, but you can actually tell it to index it backwards. But apparently in this case, it would have made zero difference. They allow you to do it, so maybe it's useful. I don't know. Gist can be used for full text searches, but it ends up with some false positives sometimes, so frequently GIN is preferred. Once we're getting into these are ones I've never used before, so actually I'm just telling you for the sake of completion, but I haven't used them. There's SPGist, which is more special use case. This is more useful for clustering things and like nearest neighbor. You can actually use Postgres to say like, here's 3 different zip codes, give me the 3 nearest neighbors to those, right? I've never used it like that. And then Brin, I have used Brin before. This is for extremely large tables. You use Brin for when you can't actually fit a B-tree index. It's because it would be too big. You have Brin, which is a little bit more compact, but a little less powerful. So I left a little link here for you if you want to go check those out and read more in depth in them than I've talked about. But just know B-tree almost always, hash sometimes, GIN somewhat frequently, and we'll talk about GIN here in a second. Everything else is, Wild West to me. Now we're going to talk about GIN. I like GIN. That's it. Next lesson. GIN stands for Generalized Inverted Index and not juniper flavored base spirits. I mean, I guess it is that too, but we're not talking about that right now. Maybe later. It is specifically really useful where multiple values could apply to one row. And when I say that, that's like full text search where you could have, like, if I'm searching for Tron Legacy, I could be searching for Tron, I could be searching for Legacy. Both of those values would apply to one row, as opposed to like a strict equality check where you're looking for Tron Legacy as like a full search string. So GIN's going to be really useful for 2 of the things that I've shown you today. One of them I alluded to already, which is full text search. The other one is for JSON-B columns, because if you think about it, if I'm looking for tags that apply to a recipe, dessert would apply to one of them, gluten-free would apply to it, like it would have multiple correct values of what would apply to an individual JSON-B column. So I'm going to show you how to set it up. We actually don't have enough JSON-B for this to actually work, but I'm going to show you how you would set it up. So let's say I had this new movie reviews table, and all it had was an ID, a movie ID, and then all of the scores as a JSON-B. So just copy and paste all of these with me. Okay, so we'll come back over here. So you can see now I have a bunch of movies, I have a bunch of movie reviews. Some of them have Washington Post scores, some of them don't. So if I wanted to search for all Washington Post reviews, or something like that, or let's say Rolling Stone reviews, you would do something like this, right? Select star from movies where movie reviews scores Rolling Stone. So you can see here, this gives me back all the Rolling Stone ones. So here I can do explain, analyze, and it's doing a sequential scan because it's not a very long table. Now, if I wanted to create an index on all of those various different review types, you could do that with this one. So you'd say create index on movie reviews where, or sorry, not where, but using rather, using, and then you say GIN here, scores. So you have to tell it what type of index, which we're using a GIN index, generalized inverted index. Yep. And then that's going to create the index. Now I can run that again, and like I said, the planner is going to be smart enough to say, you don't have that many rows in there. I'm not going to use an index. That would take me way longer than just sequentially scanning through these. Because again, Postgres is really good at reading a lot of stuff really quickly. That's like the entire point of Postgres. So this actually didn't really help us, but if we started adding 10,000 of these rows, it would start using these. And that's the point of GIN. It's really useful for these kind of like multiple values applied to one column kind of searches.
Why was it still way faster, even if it didn't use the index? Like if you look at the planning time, I guess not way faster, but...
I guess it is. It's 25 times faster, though. Probably just ended up... you know what? I bet you it's cached. That would be my guess. So let's say if I ran this with like Washington Post, my guess is it's going to go back to being slow again. Nope. Maybe it did get faster. I was not expecting that. It's still doing a sequential scan, but maybe it's utilizing the index in some way. That one is actually a mystery to me. But my other guess is it's probably still caching. Because even if it's looking for something else, it probably was able to utilize the same cache underneath the hood. You would expect that to kind of like tell you, is like, hey, I used this thing. But I don't know. JSONB, if you're going to index JSONB, you're going to use GIN. Those two should just kind of go together in your brain. I am going to show you how to use GIN, and we're actually going to see some performance benefit now. We're going to use something called a trigram. So let's say we wanted to search for all Star Wars movies and movies. You could say select star, let's just say name, because we don't need all of it, from movies where name I like Star Wars. So you can see here we got 30 rows of things that are like Star Wars. Okay? Now let's explain, analyze this. We looked at everything, so we did a sequential scan on movies. It took about 5,000 units cost, right? And it looked at 178,000 rows. So 100 milliseconds, not great, not bad. What if we wanted, like let's say that's a really important part of our app. So how do we optimize for that? Well, let's talk about trigrams. A trigram is, as you might imagine, it's 3 characters together. If you split a word into trigrams, in fact, let's just show you what that looks like. You can select show trgm of Star Wars. It'll show you all of the various different trigrams that it'll make out of the word Star Wars. Blank blank S, blank blank W, ST, WA, AR, ARS, RS, STA, TAR, WAR. It's showing you every permutation that it can make of 3 characters together of Star Wars. We can then index on that. And then using GIN will then use that same algorithm to do multiple values that apply to one row to index it, which makes it really fast to do full text search. Here's an actually fascinating thing. GIN came before JSONB, so they invented the search algorithm before they invented the data type that it searches on. But it was so effective that they didn't have to invent a new type of index for JSONB. They just applied the same principle using JSONB. I thought that was a really interesting. They were so good at doing the generalized inverted index that they didn't have to reinvent the wheel once this new data type came around. Okay, so we saw explain, analyze from Star Wars. Let's create an index on movies using gin on name, and then we're going to give it a specific type of index, which is gin trigram operations. This is not the only one that you can do with gin. There's other methodologies of doing it, but this is the only one that I'm familiar with. So you can see that was actually a decently hefty operation. It took like a second, which again is really quite slow for 178,000 rows. If you're going to create an index in production, it's going to be really slow. You might be ready, you need to have some downtime. It can be slow enough. So just be aware that creating indexes is expensive. All right, so now let's do, this was about 5,000, right? Let's do the exact same query now, but we've done it with gin. So we went from 5,000 down to 152. Notice this had 0 setup though, and this has 88 setup. 88 setup is a lot, actually, but it's expensive to use these kind of specialized indexes. But we went from 103 milliseconds down to less than 1, so not too bad. So rows removed by index, I don't know. It's always interesting to look at these, but you can see we ended up doing a bitmap index scan, which is ultimately what we wanted. So very cool. Most of it you can see was spent planning, and you know, a little bit more than half was spent to planning, whereas on the other one, planning was 0.2, but it took 100 milliseconds. So again, this is why the planner is super cautious about when it uses an index, because it knows using indexes are expensive. Let's do partial indexes. So we're going to go back here. We looked at gin. We're going to copy this query really quick. Actually, we can probably just grab all of these. So we're going to be looking at category names for just a second. So specifically category names. So we're going to be looking at category names. It has a category ID, a name, and a language. Fathom for a moment this is an enormous table. It's actually not small. So select count star from category names. You can see 36,000. It's not 0. Let's say that we have an English website that 99.999% of our traffic is all English, but we do have a German language as well. Most of our users are going to be querying against just the English part and really don't need to have the German parts indexed. If I say create index on category names, all of the German stuff is going to get indexed, which would be wasteful for most of our users. What do we do about that? Well, you can actually add a where clause in your index. So, and you can see here, select distinct language count star from category names group by language. You can see we mostly have English and German category names, but less than a third of our table is, not less than a third, less than half anyway, is English. So it'd be useful if we could only index on that side. So let's go grab this query right here. If we do that, you can see get a sequential scan, and that's going to be about 832. But let's go ahead and create this index here. So we're going to say create index, whatever you want to call it, index English category names on category names language where language equals en. So now we have an English language index. So if I run that same category or that same query again, notice I get way better times. So I went from a setup time of 132 and a execution time of 641 to 905. Or so, no, this is 132, right? So basically all that setup time ended up being, that's interesting that it ends up being the same. Oh, it is the same as that. Got it. Okay. So anyway.
So will it only use this index when you have a where clause for English?
Correct.
Okay.
So the planner can see that your where clauses matches up and it's able to use those together. So you can see I went from 832 down to 641. A small improvement. The setup time is pretty big, and when you add those where clauses, the setup time gets bigger, right? Nonetheless, it's it's 25% better-ish. It's not nothing. But let's run that same query again for DE. And we're right back to that 832, right? So it's actually only doing part of it. In our case, if I was actually really doing this, it's probably about the same speed. In fact, we can even just try it and see what happens. I actually haven't tried this. What did I call that index? IDX something or other.
IDX English category names.
There we go. And then we will create that again, and we'll just drop this where clause. Try that again with the English names. So we went from, I think, 672 to 674. Nope, 641. 30 units. That's an effectual time. This was 993 to 987. So that's just going to be on the how busy is my computer right now kind of thing. But now if I go back and I do that, this one, this will also get the same benefit. So you can see this one took 3893, probably because it wasn't cached and probably for, I don't know, other reasons as well. So in this case, if this was a code hot path, I'd probably just loop in all the German stuff as well. Might as well. The performance benefits of including German was not that big. But if there was 1 million entries in this database or 1 billion, it would make a big difference. So all these trade-offs to be making in your head. I just want to show you that you can do partial indexes. So fathom for a moment, you're at your job and you work at this OMDB company that's showing people movie statistics. It's some IMDb type company. And you show your boss this really cool query that you can actually show people how much profit movies were making. And people were really interested in this query. That you're like, hey, using this cool query, I can show this database and I can show you, profit of movies by movie, by category, by actor. And people are like, this is amazing. People are going to want to see this. And you show them this query, which is what this does. And let's just take a look at so you can see what the results are. You can see here, this is revenue, this is budget, this is the profit. I'm going to just caution you for a moment that this is all Hollywood accounting. It's all reported numbers, which is to say none of it makes any sense. I left to you the article here of what a Hollywood accounting is, and basically it's just flat lies. But let's say your coworkers are very into this. Your boss says, like, this is amazing, great job, go make a dashboard that we can put on our front page. And literally all 10 million of our users are going to see it every day, several times a day. You go back to your desk, you run explain analyze, and you see, I cannot run a 7,000 cost, a 53 millisecond query 10 million times a day. That's a bad thing, right? So now you're like freaking out. What am I going to do about this? All I've ever learned how is to index individual rows. I haven't figured out how to index any sort of derivative information. You could do something like put it in Redis or something like that. You could query it and then populate a cache or something like that, but who wants to do that, especially if you don't have that stood up already? So there is actually a way you can actually index on derivative values. So you see this derivative value I have here, which is revenue minus budget. you can index on that. So I'm going to say create index IDX movies profit on movies, and then you just give it that part that you're going to index, which is coalesce revenue minus budget 0, right? Because we want movies that had no budget, no profit to be 0, which is fine. And then I need another one, right? Because and I also have to have one in front, which I did. Why do I have 2 at the end here? That's my question. Oh, right, because you need one around this as well. Parentheses, they'll get you. Okay, now I have this index around movies profit, and now I can actually query that, and if I do an explain here, again, doing the same query, I went from doing, what did I say, about 6,000, 7,000, something like that, yeah, 7,300 up here, to now I did it again, and I'm getting 1.33, because it's actually able to index this. And now anytime that I insert a new movie, it'll actually calculate this in advance, and it won't have to run these calculations on the fly. So I went from 7,000 to 1.33. I went from 53 milliseconds down to 0.13, 206, something like that.
So does it make like a hidden column? Essentially, like it's storing that whenever you update either of those columns, right?
Yeah. It is storing that. I'm hesitant to call it a hidden column because it's actually just totally separate.
Okay.
It's in a totally separate data structure. It doesn't get stored necessarily as the movie, it just gets stored as like a index, right? It's stored in a B tree, it's not stored in the table. I guess that's my point. But if you want to think of it as there is a indexed profit, which is a derivative value from the table, that's what it is, right? So I've kind of disclaimed this throughout my entire part of query performance. I am not a DBA. I have shown you a couple of very simple ways of doing indexing. Anything more complicated than this, you should really work with your team to figure out what's the best thing to do, because really big, difficult queries can make that really difficult. But for personal stuff and for simple tables and simple querying purposes, this would be enough. I'm more concerned that you know what's possible and you can identify problems than actually being able to articulate this is precisely the index and how I would use it. More you can say like, I know this is messed up and I know it can be fixed. And if you're using things like pgadmin, or like you can go look at like DynamoDBs or Aurora or Cosmos DB or any of these like cloud databases, and you can ask it to track slow queries for you, and then later you can go write indexes for them. Some of these cloud companies are even starting to suggest, I see you run this query a lot, I see that it causes you a lot of trouble in your app, we suggest that you try this index. So they're actually getting smarter about it as they go. Let's talk about views. We're going to come back to indexes a little bit later. We're going to do a bit of a magic trick. I'm going to show you how to speed up a query by 4 million%, which I'm pretty excited to do. It's the crown jewel of this course. But we have to work up to it. It's going to be the culmination of a lot of concepts. But first, let's talk about views. Let's go back to English category names. We talked a little bit about that, right? Let's fathom for a moment. Again, we have this website. We're mostly showing English category names, and we don't need to show French, Italian, German. We could, every single time, do this query of select category ID, name, language, from category names, where language equals EN. Right? And we can do this literally every single time that we need to populate this database. and like anytime that we have to do any joins, by the way, I don't vet anything that goes into this, like that shows up. So if something weird shows up as like a category name, I swear to God I didn't put it there. I was worried for a second that I saw that something was going to be bad. So far, so bad.
Number 17 looks like German.
It probably is. So the data integrity here is not the best either. But it was free, which was the correct price. So, this is burdensome to have to do this every single time, and anytime that I want to do like a join, I have to join this big, massive thing, and I have to know where everything is coming from. I don't like it. I wish it was easier. It'd be nice if there was just a table that had just the English names in it, right? And I didn't have to do any sort of fun join to get that. Turns out there's a way to do that. And it's as easy as, I'm just going to say in front of this select statement, I'm just going to say create view English category names as blah, as query. Now if you look at my tables here, you can see I actually have a view as an entry here. And it looks just like a table. It has a category name, and a language. So now I can just say select star from English category names. And you know what I did that I should not have done?
The limit 5.
I put the limit on there, so it's actually only going to get the first 5 ever. So let's actually drop the view English category names. And we're going to recreate that. You could alter the query as well, but we're not going to do that. But now we can do that and say limit 5. Or limit 15 so that we get more, right? This is now 1 trillion times easier for us to deal with. Right? We don't have to do any expensive joins or anything like that. We can just get it's basically a lens. If you're familiar with the programming concept of lens, there's some languages that are like really big into it. It's like a way of looking at data, but it's like derived and it can alter the data as it goes through a lens, right? The same idea applies here. If you're not familiar with lenses, then just ignore everything I just said. I showed you a really easy one where it's just like a where, but these can be like big complicated joins as well. It doesn't have to just be just like a simple where. It can be literally any select that you can think of. It's useful for convenience. It's also useful for permissions. So imagine you have a contractor working with you and you have some part of the database that you need to show the contractor and they need to be able to select from, but you can't show them all of the database. You could create a view and then you could give them access to just the view. From their perspective, it's a table. They can do whatever they want from it, but they wouldn't be able to access anything else in the table. So from a securities and a permissions kind of point of view, it's also a useful thing. Another interesting and useful thing is I can actually insert into a view. Category ID, name, language, values, 2. We should definitely have a topic about Brian Holt, right? Absolutely. And just to prove a point to you, despite the fact that this table only shows English, it's not going to verify that as it goes through. So I'm going to put this in as an Italian keyword. So I actually wouldn't be able to select this back out of it because it's an English table, but I was able to insert into it Italian. Again, it's not verifying the where clause there, but because there's a one-to-one mapping of the view to the table, it's just like, okay, you're inserting into this, so you're obviously inserting into the underlying table.
Are you inserting a second thing with category ID 2 now?
So select star from category names where ID equals 2. Or what is it? Category ID. So in English it's source, but in Italian, se dice Brian Holt. I don't know if you knew that. I speak Italian, obviously you don't. So, does that inserting into views? It's a neat trick, but it's obviously you can see it's not the most useful thing. I just thought it was kind of a funny thing.
So it went through the view into the source database.
Yeah, you can see here we're querying from category names because there's a view doesn't exist, right? It's just a lens to look at a table through. It's a query that gets run, and then you're selecting from the results set. That's actually more accurately what it is.
Is it similar like making a temporary table, or?
A temporary table actually can store things. I guess no, it doesn't, because I guess it's purely transitional, right? I guess depending on what you mean by that, maybe. We're not talking about temporary tables today, but like if you're doing crazy things and you have to like create intermediary tables to then select from, and that's more complicated than result sets, then you can use a temporary table. If you're thinking about it as a transitive, because it's not transitive, it's really just what happens is you run your query against a view. The view runs the underlying query, gets all that data, and then you select from the results set as if it was a table. I guess that intermediary there you could think of kind of as a temporary table, I suppose.
Yeah, I guess that question came from I was Googling other ways to speed up queries beyond indexes, and one of them was like use temp tables and don't do nested views. And so I was like, I knew they were different, but I was kind of trying to figure out,
Yeah, you can have views on views, right?
Yeah.
So is it faster to query the view than to query the original table with the where clause for English?
It's probably about the same, I would imagine. This is not a performance tool. That's a good thing to keep in mind.
Okay.
This is a convenience and security tool.
Quality of life.
Yeah. That was 641. What was our original query? Create view. Actually the same.
It's exactly the same.
Yeah. So it's going to be similar, but I could see the point of like if you're having views go through views, the hops aren't free. They're probably pretty cheap, but they aren't free. Let's keep talking about views because obviously you can't get enough of them. So let's go ahead and grab this expensive query over here, which is this one. I don't want to type it all. So we're just going to grab it like this. So basically I went and grabbed from people, P, I grabbed the cast, and then I grabbed all of the roles and the movies that they were in. So imagine I'm making some sort of page that shows various actors and actresses, the roles that they played, and the movies that they were in, right? You can imagine that being really useful, but writing this query over and over, particularly if I have to join it again to other things, that's just going to suck, and I don't want to do that. This is another place where a view is going to be super useful for you. So instead of doing all of this, again, I'm just going to grab the query here again. I'm going to create a view called Actors, Roles, Movies, where it's literally just that same query again leaving off the limit 5. And now, instead of having to do this big stupid query, I can say select star from actors, roles, movies, limit 10, and I just get everything that I had there, right? So much easier to deal with. hopefully you're starting to see as we building up there is like this is where this gets really useful, especially when you have big complicated tables to this where you have to do lots of joins. You can create these views that make it easier to kind of work with data. The nice thing about views is that they are always current, right? All it's doing is it's running the underlying query first, giving you back that result set, and then your query is querying that result set. You cannot index a view. So I can't say create index on actors, roles, movies, because if you think about it, that doesn't make any sense because you're not querying the actual view. The view is just a window to look through. You're actually querying the underlying databases. So if you have a slow view, you need to index whatever the view is querying, right? Does that make sense? We will see in a second that you can index a different kind of view called a materialized view, but that'll be in the next section. Yeah, this is just way easier to look at. Now, the nice thing about this is we can now start joining from this table to other tables. So this actually, you can treat views 100% like you treat a table, which is, part of the power here. Imagine if I had to join this, somewhat gnarly query to this somewhat gnarly query. That would be unfun, is the term I would choose for that. You would have a very, very long query. Instead, what we can do here is we can select from actors, roles, movies, that view that we made, and then we can use that basically as a normal table, and we can do joins based on arm.movieid, which refers to actor, roles, movies, and we can get this kind of built-up query. So this question is asking, what types of actors and actresses tend to act in the same sorts of movies? So the one thing I'm going to say here, because this is joining from a view, which is already kind of an expensive view, this query is going to be the most expensive query that you and I have run so far. So I'm not going to write all of this because it's a lot, and I don't want to write all of it. If you're running on a really slow computer, and you still want to see the results, just comment out this way, or delete this comment, and it'll limit the scope down a little bit, so it'll be a little bit less expensive to run. But now I can run this. You can see that is taking a decent amount of time to run, and surprise, surprise, the actor that far and above acts in the same sorts of movies over and over again it's Jackie Chan in martial art movies, right? But who else do we know in here? Robert De Niro acts in a lot of movies about New York. I'm not surprised by that. And Jackie Chan is in movies about Hong Kong a lot. And Stan Lee is in a lot of superhero movies. Okay, that tracks. And Tara Strong, she's the voice actor for Harley Quinn, right? And she acts in a lot of movies about Gotham City, which is where Batman is, right? So that tracks as well. For fun, let's get it all the way up here to the top. Let's do an explain, analyze on this bad boy. $295,409. It's really interesting that all of this is in the prep. The actual execution of this is 0.05. Or it adds 0.007 execution. All of it's in the setup. But anyway, suffice to say, this so far is by far the most expensive query that we've run. It took it took 3.6 seconds to run. Obviously, this is not something you're going to want to run in production. 3.6 seconds on a very fast Mac is going to translate to crashed servers, for sure. So I'm going to show you in the next section how to actually make this a very fast query. We are going to speed up this query by 4 million%. Not bad. So while views are not tools for performance, a materialized view is a tool for performance. So this is what I saw when I ran it last week, 293,871. That is a too expensive query, no matter how you choose to slice and dice it. But let's say you really, really care about movie or actors and actresses that tend to act in the same sorts of films, and that's really important to your application. We need some way to track that then, right? So you show your boss that scenario, your boss is like, this is amazing, great job, engineer, go build the page that does this. You lose your mind because you are running 4-second queries. You cannot ship something like that. So you know that you need to do some sort of performance optimization here. So I'm a product manager now, so I think of everything in terms of like user requirements and user journeys. Let's talk about your product requirements here. You want to show your user cool graphs and stuff from data from your database. The query that you get is really expensive. But think about it. Actors and actresses do not release movies every day. They release maybe a movie a day, maybe 10 movies a day. Not very many movies per day are released, which is to say that if you have a user that's querying on day-old information, that's fine, totally an acceptable cost, which means that this is a very cacheable kind of thing. So let's talk about what kind of caching strategies you might use. You might have something like Redis, where you just run this query once per day, and then you populate a Redis cache or a Memcache cache. This would be a good use for something like LinkedIn has a product called Voldemort, where it's like stores intermediaries. There's a myriad of others. You could have your app servers cached in memory, right? There's another thing you can do there. I'm going to show you how you do it directly at the database level, called a materialized view. The advantage here is we're going to create a view that's actually a cache. And the nice thing about this is it's still a table, so you can still do joins off of the materialized view as well. You get all of the performance benefits, and you get all of the view benefits of it being useful. The only downfall is that it's cached, right? It's not actually running the query. It's actually making a separate table and storing it. And it's not running the query again, it's just keeping the results. So the only difference on how you make them is instead of saying create view, which I could definitely just leave this out and it would just create another view. It would just be a very, very slow view. But if you put materialized here, it's going to cache it. So I'm going to create materialized view. It's going to be that same query. The only thing down here is I added with no data. But let's do that really quick. So you can see there it took no time, which is suspicious because we know it's a very slow query. When I put with no data here, I created the materialized view and I did not populate it yet. Because again, this is a really expensive query. You may not want to run that materialized view immediately. You might want to wait till downtime, right? So if I say select star from, what did we call it? Actor categories. It's going to be like, you can't do that because you didn't populate it. Just to show you, it does show up here. Here's actor categories. It's a materialized view. So how do we populate it? I actually told us right there. You just say refresh materialized view. I'm going to run that, and I'm going to say actor categories, and then now this is going to be slow. Okay, it's done. So to sum that up, we did it with no data. You can say with data. If I put with data there instead of with no data, it'll immediately run the query for the first time and populate it. But now I have this cached version of this query. And again, this is actually using a view directly in it as well, which is kind of cool, right? So the materialized view is kind of downstream from the view. But if I do a bunch of updates to actors' roles, movies, and movie IDs and stuff like that, that's not going to affect this query because it's cached, right? So every time that I want to update that, I'm going to have to say, again, refresh materialized view. because that data will get stale over time. It will not update that cache until I run that again. But the nice thing is I run it once and then all my users can query from it instead of having every user query the really expensive query. Do you understand the trade-off there? You're trading off slightly stale data for tons of query performance. So what did I have up here? Did I just ask for order by descending? So if I say order by, what did we order by in the other one? Count, descending, limit 10. Okay, so this is what we saw before. If you remember, that was almost 300,000. If I say explain analyze now, we went down from 290,000 to 88,000. We went down from 4 seconds to 200 milliseconds. We are definitely going in the right direction. That's still pretty expensive, right? Why? Why is that still expensive? Well, let's see how many are in the table. Select count star from actor categories. There are 4.1 million rows. That's a lot, right? Because if you think about it, every actor that's been in any category ever has a row. That's a lot of permutations. That's going through a lot of rows to figure out that order by. That order by is actually what's making it really expensive. You can see it's doing a gather merge. That's what the part that's actually going to be really expensive there. One more thing that I wanted to tell you. Every time that you run this one right here, refresh materialized view, if you do it like this, it locks the table, which can be really scary. Let's say I had that actors categories page on my website and I ran this in the background and someone then tried to query it while it was being refreshed. It locks the table, which means that that query would fail or it would wait. One of the two. That's bad, right? And it also, I think it locks the underlying tables as well. That might be true. That one I'm less sure about. Anyway, locks are scary. That's my point. You can do something that says refresh materialized view concurrently. So if I added concurrently after this, it's going to go way slower, but it won't lock the table. Yeah, it doesn't lock the underlying tables. It just locks the view. Now I remember that. But if I did this, I'm scared to even run it. I don't know. It concurrently, let's just do it. Oh, well. Apparently you have to do some stuff to get the concurrently to work, but suffice to say, if you don't want to lock the table, you have to set up your view in such a way, and then you can do concurrently, and that will not lock the table. So, how do we get this to be even faster? This is still pretty slow. Indexes. Surprise, surprise, our old friend the index. Create index IDX actor categories on actor categories, count descending, and I don't think there's actually any nulls in this list because it's just counts, but if you want to, you could put nulls last so that you're always sure of that, or not, up to you. I'm going to put it in there. You could leave it out if you want to. Okay, now I have an index on that. So let's run that same descending. I have to put, because I put nulls last here, I have to put nulls last here. Even though that would make a difference here, it won't use it because it doesn't see them being the same index. But let's run this again. This was 88,000 up here. Let's see what this is now. This went from 88,000 to 0.75. That's a slight increase in performance. Even just from the 88,000 up here, but think of it from the 290 something thousand, this one right here, almost 300,000 up here. So I'm not a math guy, but that seems pretty good. Or I did the math for you. That is a 4 million% increase in performance. That's like, you should get a promotion for that, I think. Or at least, you know, a pat on the back. Like a really firm one, though, that makes you feel good. One of those. Okay. Any questions about what we looked at?
Besides how expensive they are to make, what would be like the downside of just having like a ton of indexes? Like, say you have the downtime, you can do all that. Is it like an organizational thing? Is like, why wouldn't you just index as much as you could?
Space.
Just space. Okay.
Space is number one. Number two is it does slow down the planner, right? Because the planner has to go through every index. Can I use this? Can I use this? Can I use this? Can I use this?
Gotcha. Okay, that makes sense.
Yeah. Those two things. And I guess three is you should keep a tidy house, right? Yeah. That is views and materialized views. Let's talk about subqueries. I was actually pretty impressed that I got this far in the course and I did not actually end up talking about subqueries until now because I end up using them quite a bit. What if you're looking for the cast of Tron Legacy, but you don't remember the ID? There's a couple ways you could do it. I'm sure you could probably fathom it with different things. You could do joins and things like that. Or we can just do a subquery. So you can do select p.name for person.name from casts C, inner join people P on c.person ID equals p.id where, and you just want to say like c.movie ID equals whatever the ID is of Tron Legacy, right? Well, you can do that actually. You can say equals, and then you're going to put a parentheses here, and you can actually put a second query in here. So I'm going to say select ID from movies where name equals Tron Legacy. And then I'm just going to close that particular subquery. That's what the parentheses mean. And I just hit semicolon. So I just wrote my query down to the point where I was like, I need to get a second query here to figure out whatever the ID is from what Tron Legacy is. Because this is only going to return one ID, and I know that, I can just go ahead and do this, and SQL is smart enough to say, cool, we're going to grab this from this subquery, return that back up here. So this one gets run first, and then the result of that is going to be put here to run the second query. Very common. You're going to use subqueries all the time. But keep in mind that you've turned now one query into two queries. There's a performance implication for that. Nesting makes things harder to read. Frequently, you can do this in a better way. I would typically err on what's the most readable query versus what's the most performant one. Typically, the performance profile is not going to be that different. If it is that different, then you need to make adjustments. But if they're the same, then err on the side of what's readable. Sometimes subqueries make it better, sometimes subqueries don't make it better, and you have to be the judge of that. So just to drive home a point, this is this query with a subquery. This is the exact same query using joins. Which is clearer to you? I have an opinion, but may not be the right opinion according to you. I do think this one, in this case, this is more clear. Because this is a pretty simple query with a very simple where, And this select query here is very simple. It's just getting an ID out of the movies table. Two inner joins with an and, there's some gymnastics for my brain to get there.
And it kind of feels like if you did the wrong join at the wrong time on a performance database, you could like...
It can go from, fine to out of control.
Out of control really fast, where like I feel like it'd be harder to mess it up if you're in a subquery. Like you know exactly what you're looking for. I don't know.
I mean, this can kind of suck, particularly if there's no index on name.
Fair.
So it's really going to depend. In my particular case here, the subquery one was 308, and I think this is without the index. And the second one was 175. Depending on what you're doing, that might be acceptable, that might not be acceptable. It just really depends. If it's a cron job that runs once a week, who cares, right? It could be 10,000, I don't care, right? If this gets run 100,000 times a second, I very much care. Your joins are typically going to be faster. Just as a general rule, joins are going to be faster than subqueries unless you have some interesting circumstances that would dictate otherwise. But I'm just going to say, on the whole, you can assume that subqueries are going to be slower. Let's talk about subqueries and arrays. So I showed you one where it's really simple. You're making a subquery. It's going to return exactly one ID, right? And that works because there's just one result. What happens if there's a set that's coming back? Well, you can do that. There is a data type inside of Postgres called array, which we can use to model a set of results. So let's say, for example, you want to see all the keywords associated with any Star Wars movie. You could do joins, you could have rows, you could do rows per keyword, but that would be really annoying. It'd be you'd get into a pretty hairy query pretty quickly. Hairy query. I don't know why that's never occurred to me before. I'm sure that's not funny to someone else, but at this time of day, it's very funny to me. Anyway, hairy queries. You're going to end up with like this mess, and you're going to have to do some aggregation. It's going to turn into a mess quickly. A subquery with an array constructor can do that a lot better. So let's go ahead and write that all together. I'm going to do it over here because it's going to be just easier to look at. So we're going to select, and we're going to select m.name for movie name, and then we're going to make an array here. This is an array kind of constructor sort of thing from Postgres. You're going to give it a list of rows, and then it's going to turn that into a data type that it can use. So I'm going to select English category names from English category names. That's the name of that view that we made in the previous lesson. Inner join movie keywords mk on mk.category id equals ecn.category id. Cool. Where, not white wine vinaigrette, where m.id equals mk.movieid. Now, notice a fascinating thing here. I have not referenced movie in my subquery. It's going to be outside of the subquery, but I can reference it in the subquery, which that's totally okay. Totally kosher to do. And I'm going to give it a limit of 5. I don't want all of the categories. I just want the first 5. So I'm going to give it a limit of 5 here just to make this a little bit more tame. And then I'm going to call that keywords. And then I'm going to say I want that from movies M, where name I like Star Wars. All right, I'll come back and recap this, but let's run it and make sure that I'm not off my rocker more so than normal. So you can see here I have Star Wars: A New Hope, and it has the first 5 keywords associated with it: prophecy, Bannerhoff, obviously, orphan, good and evil, android, Empire Strikes Back, spoiler alerts, father and son relationship, rebel, bounty hunter, monster, and obviously the classic Schnee, which I do not know what that means. I'm assuming it's German. You can see Clone Wars here. This is probably the TV show, has no categories associated with it. But Empire Episode 1, Die Dunkel Bedrung, has underwater and warrior associated with it. So first of all, curly braces here. That means array in Postgres terms. Some of these that only have one word don't need quotes. The ones that have 2 words, are right, and there's spaces in there, they put quotes around those. And that's what this is. This is an array that we're returning as one top-level data type. And again, you can mess around with this. If I did this with 3, it would obviously give me less keywords. All right, so now I'm getting less keywords. Yeah, and again, to call attention to that, we have where MID equals movie ID. Notice the movie here is coming from movies here, not from the subquery, but from the outer query. Totally okay to do it that way. These kind of queries can get really expensive because you can think like, this is not cheap. This has an inner join in it, right? And you can quickly spiral out of controls of doing subqueries within subqueries within subqueries. It depends if you have, a performance tolerance for that. So we just talked about subqueries. We are going to talk about transactions. So we're going to pop back over to the recipe database just for a hot moment. If you hit \L, you should see Recipe Guru here like I do. If you don't, let me just show you how to recreate it. Just say create database Recipe Guru like that, right? You'll hit enter. I think mine's going to say, I already have one, so I'm not going to, but yours would say, okay. You would hit \C Recipe Guru. Okay. If you hit \D, you would see nothing. If you do see something, then you're fine. Don't do anything. If you see nothing there, then come back over here. If you remember, what section was it in? JSON B, maybe? No, the project. So under joins and constraints project, there's 2 projects, this is the second one. There's this link to this big SQL file. If you click on that, that'll download it. That's my 4th copy of it. Just copy and paste that. And you can paste that here. I'll do it because it just recreates everything from scratch. And there you go. Now you should see this. Select count star from recipes. You should see I have 56, something around there, good enough. Okay, now that we're that, you should see Recipe Guru here. We should be good to go. If you see OMDB there, you're still connected to the wrong database, \C Recipe Guru. Let's talk about transactions, because these are actually really important, particularly for certain classes of database activity, particularly if you're in financial tech like me. So imagine you are writing banking software. You have Bob, who is trying to give $10,000 to Alice. You have 2 queries there, right? you're going to have to subtract $10,000 from Bob's account, and you're going to have to add $10,000 to Alice's account. Those are two separate queries. You're not going to do them in one query. What happens if you subtract $10,000 from Bob's account, and then in the middle of that, before you can run the second query, your database crashes? Well, you have a massive problem. Bob has lost $10,000. Alice has not gained $10,000. The bank has robbed Bob. I'm sure Bob is not happy about that. Furthermore, Alice doesn't have her $10,000. And if you did it in the opposite order, where you gave Alice the $10,000 first and your database crashed, oh no, the bank is giving away money, right? Both of those are wholly unacceptable outcomes. So we live in this situation now where both of those have to succeed or both of them have to fail. If both of them fail, they might be annoyed that the money didn't get moved the way that they wanted it to, but no one's going to call a lawyer just yet, right? So we need what's called an atomic transaction. Atomic means, like the Greek word, indivisible, right? You cannot divide this. This either all works or none of it works, nothing in the middle. This is something that SQL provides for. Lots of banks use SQL in all sorts of flavors and varieties. And so transactions are absolutely essential. So you need to think about transactions when you have something where multiple things need to happen in succession and they cannot afford to fail, right? Or like you cannot have partial failure, right? Partial failure is unacceptable. This is where transactions are useful. So what will happen with a transaction is you'll say begin, you'll do a couple of things, and then you'll say end, and then it'll execute all of them. So let's say we're making a new recipe, and we want to add things into ingredient. And for whatever reason, we cannot afford or tolerate ingredients without recipes. Just like fathoming that other situation there. So what we would need to insert into ingredients, we would need to insert into recipes, and then we would need to insert into recipe ingredients all of the correct IDs, right? All of the correct connections. So it's a bit of a long query, so we're just going to copy and paste it from the site, but we'll go through it together. Essential, we're going to say begin. Begin basically means we're about to start a transaction. You can also say begin transaction, or you can say begin work. They all mean the same thing. You can also just say begin because we're lazy. We'll do it that way. Insert into ingredients. Insert into ingredients, right? So we got whiskey and simple syrup. You can replace this with like, I don't know, soda if you don't want to talk about alcohol. That's fine with me too. We're going to insert into recipes, old-fashioned, right? And I have the very descriptive old-fashioned, because again, I should not be writing courses about food. And then we're going to insert into recipe ingredients, and we have to use subqueries because we have to go get those IDs, right? So the first value is going to be the ID, the recipe ID from old-fashioned, and the ID from whiskey. The second one that we're going to add in here is the ID from old-fashioned again, and the ID from simple syrup. Then once we have finished all of that, once we're happy with the state of our transaction, we can say commit transaction, commit work. Those are all the same thing. And then it'll actually go and do all of those. If any part of this fails, if this part fails, everything is canceled. This is canceled, all of it's canceled. But if everything succeeds, then the entire thing is committed in one atomic transaction. So you now avoid the problem of what happens if my database fails in the middle of this, or one of my second queries doesn't work, right? That's what all of this does. So we're going to do this. I'm going to do begin. I am not going to do commit. So I'm going to do this, all of that. I have not typed commit yet. Even though I see all these, this basically means that it's inserted. I'm still in the middle of a transaction. if I say select star from ingredients where name, is it name? It's title, right? Title. Title equals simple syrup. It will come back, right? The reason why it comes back is that according to this session of this person, like this one PSQL session, that has happened, right? However, if I open a brand new tab and I do Docker exec and I connect to it again, and I'm connecting to Recipe Guru, and I say select, I'm going to run the exact same star from ingredients where name equals simple syrup, sorry, title, nothing shows up because that transaction hasn't happened yet. So I'm going to go back here. If I wanted to just blow it up and not have anything happen, what I would do is I'd say roll back. And that would just cancel my transaction immediately. I don't want to. So I'm going to say commit. If I do it again from here, again, it's still there. But now if I go back to this other new session and I say select star from ingredients where simple syrup, now this shows up because that transaction has been committed. Again, there's not really a big performance consideration here. I wouldn't worry so much about that. The consideration here is your tolerance for failure and partial failures. That's where transactions are essential. So, I'm trying to think if there's anything else I wanted to tell you about there. Yeah, I mean, I'm going to copy this. I just want to show you what rollback looks like. We can even just do this. And I don't need that. Well, we'll say this is like, I don't know, something else, it doesn't matter. Okay, so we'll do this again. I've done 2 inserts here. And if I'm unsatisfied with how this is going, you can just say roll back, and all of a sudden everything is back to where it was. That these 2 things are not in the database because I rolled them back. Make sense? And again, you can say begin work. You can also say begin transaction if those make more sense to you. Begin is just short for that. Sometimes it's helpful for begin because begin means several things in SQL contextually, whereas begin transaction is obviously very specific to beginning a transaction. That can be useful sometimes. The question I ask myself is like, this is really kind of burdensome doing these subqueries here. You actually can do this with variables so that I can get like the ID back when I do this insert and the ID back from when I do this insert. And then instead of doing these subqueries, you can actually put the IDs from it stored in variables rather than doing subqueries. You have to do it in PLPG SQL. There it is. Sorry, it takes a second for me to remember how to say that always. So I wanted to just show you how to do that. You can't do a transaction inside of a function, but you can do it outside of it. So let's say I wanted to add mimosas. The way that you would do that is you would begin work here. Again, you could just say begin here. I just did work so that you could say that this begin is different than this begin. This is the beginning of a function. This is the beginning of a transaction. I declare variables, champagne, orange juice, and mimosa. I insert into this, and then I return ID into champagne. So that's how you store this into a variable. Return ID into orange juice, ID into mimosa, and I do those for all of my inserts here. And then here into recipe ingredients, I can refer to recipe ID, ingredient ID, mimosa, champagne, mimosa, orange juice, and then at the end here I can commit. Just to show you, that all worked. Here, the do, this is probably the operative thing that you're looking for. You're telling Postgres, I'm about to run a function. So you give it this body, it immediately executes it, as opposed to like creating a function and storing that like we did, where we are actually just creating a function and invoking it immediately, because we want to do something like run JavaScript or run the Postgres programming language directly. So ask yourself, which one of these do you like better? I'm going to say I probably like this one better, even though the subqueries are a little annoying. Getting full into a Turing-complete programming language in my SQL, not my favorite thing to do, personally. That's really it for transactions. It's just begin and commit or begin and roll back. Everything else here I'm kind of showing you just for fun. And again, you cannot have a function do a transaction. However, you can use functions inside of transactions. That's it for transactions. I promised you we would talk about window functions. I'm finally going to explain window functions for you. We talked about that hours ago. You probably forgot about it. I probably could have just not talked about it and you wouldn't have cared. Well, surprise, we're back. A window function is basically like I have a bunch of these rows, but I want to do something collectively with all of these rows. So let's say, for example, I have my movies, and all of these movies have ratings with them, or not all of them, but many of them have movies with them. And yeah, sorry, I reconnected to the OMDB here. I did \c OMDB. You should do that now. We should be back in movie territory. I'm going to clear this. So I have movies. Select name and vote average from movies limit, I don't know, 20. So you can see here, people really didn't vote very high on New Hope. I liked that movie. They liked Pirates of the Caribbean, Curse of the Black Pearl. Who are these people voting for these things better? Anyway, how dare they? So, I can get these vote averages out of my database. What if I wanted to compare that to like the average, right? Like we're trying to do some like, is it like a standard deviation better or a standard deviation worse or something like that? We can use a window function to do that. So I can select name, kind is like is it a movie, is it a TV show, that kind of thing. Vote average, and then I can do an average function here of vote average, and then you have to tell it over what. Well, I want to do it for the entire result set, so I'm going to say over empty. This is going to be the entire result set, but you could limit it here if you wanted it to. And we're going to do that as all average. From movies, and we'll say limit, I don't know, 15 or 25 or something like that. We'll say 15. So you can see here, let's just run this again with, there we go. You can see this is the average 6.25. So you can see all of these ones that it's showing so far besides Jarhead, which I admit I saw, and I admit I didn't know that. No, Kill Bill? No, yeah, it was for Jarhead. Didn't really care for this movie. So that tracks with what I think. We can see the average of all films versus the ones that we're looking at. That's cool so far. If you do over with empty modifier there, or like empty kind of partition is what it would be, you get it across the entire result set. So if I put like a where here, where kind equals movie, it would not use those in the average. Maybe let's just even do that to prove my point here. From movies, where kind equals movie. So you can see it didn't change a lot, but you can see these two numbers are not the same. So the filter is going to affect that, right? It's over the result set, not over all movies, everything in the movies table. It's going to be just over the result set. So differentiation makes sense to you? Okay. Let's take this a step further. What if I'm interested in the average by kind, right? So I want to compare, maybe I have this hypothesis that people like movies better than they like TV shows, or vice versa. So we can compare it to the average of its kind as opposed to the average of the entire result set. Well, the way you're going to do that is you're going to say select name, kind, vote, average, average, vote average. And then this is where you're going to use the over. We're going to say over, and then you're going to use this partition by. I always have to make sure I spell partition right. It's one of those words that's just like sometimes messes you up. Partition by kind, right? Because we're trying to slice and dice by kind. And we're going to say that as kind underscore average. Okay? From movies, limit 20, something like that. So this isn't super useful so far because all we're seeing is movies, but just maybe we'll get a larger set here by 100. Movie, 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 movie. Okay, you are not helpful. Well, let's just add a where so you can see that it also works for things that are not movies. Where kind is not equal to movie. So you can see here, movie, the average is 6.2, but if you change it to series, its average goes up to 6.7. So people in general seem to like series better. And kind is not equal to series. Seasons, it seems like people don't care about seasons. Okay. And we should say and vote average is not null. Okay, starting to get some more episodes and stuff like that. That's different. Anyway, hopefully you're catching my drift here where these numbers are now different, and they're different by kind, right? And they're partitioned by that kind. What if we're just not even interested in comparing individual titles? We just want to see the average of each one of these, the average movie, the average series, the average of that. Well, you can do that with tools that we already know. Select distinct, kind, average, AVG, vote underscore average, over, partition by kind as kind, vote average from movies. Average series 6.7. Looks like there's no voting whatsoever in seasons. Episode 6.2. Movie series is the devil's number, and movie is 6.23. I like this. I like things where I can ask a reasonable question about my data, and I can use a query to get insights back. Because then my only limit is the imagination of questions I have, not my ability to retrieve the data. I don't know. It's a cycle that I really enjoy. And that's 95% of what window functions are and what they buy for you. If you're trying to grab or derive insight about groups of rows inside of a single row, that's when you're going to use a window function. But it allows you to use things like aggregation functions on an individual row. You just have to tell it what you're aggregating. So I found myself, when I was doing the I don't know, the part earlier where I gave myself the category name of Brian Holt, I was trying to find where there was an English or where there was a German word for something and not an English word for something. So I was like, I can use SQL to find that. You can use SQL to find something that has a German translation in a table but does not have an English translation in the same table. How do you do that? You are actually going to join a table to itself. So you can do what's called a self-join. And I'm going to show you how to do that really quick. So, reasonable question. Let's say you run this multinational movie database, and you want to go and make sure that everything has a translation in it. You could write a query to say, like, give me all of the Italian things that don't have English translations, or vice versa. So I'm going to select C1 category ID, C1 language as DE language, or DE lang. So we're going to do C1.name as DE name, C2 language as English name, EN lang, and C2 name as EN name. So that's a bunch of things that we're selecting. From category names C1. We're going to do a left join because we're trying to find things that have a language of DE. So we want to include those in the results set, but don't have an English translation. So we want to do a left join. We also could have done like a full outer join, and then we would be able to see on both sides and just check where things are null. But we're not going to do that. We're just looking for things that have German words that do not have English words. So left join, category names again, and we're just referencing the same table. There's no special magic to self joins. We're just calling it something else, and we have two versions of the same table. On C1.category ID equals C2.category ID and C2.language equals EN, where C2.language is null and C1.language is German, right? And we'll limit that to, I don't know, 20 or something like that. So what I did is I asked the question, and let's just break it. I recognize this is weird and confusing to look at a table joining to itself. But I joined the category tables to itself, and on the left side I have all German categories, on the right side I have all English categories, and I'm asking, join them together wherever there is both an English name and a German leg, eliminate it from the result set. Leave me with only things that have a German translation and you were not able to find an English translation for. So all of these things here, they exist in the category names table with a German translation, but there's not a second row to represent the English translation of it. So this is easier to read. Just talk about it one more time. I'm treating this, as far as Postgres cares, these are two separate tables. It does not care that it's actually the same table. So that's why we have C1 and C2. The first thing when I do where here, I make sure that everything that is in the result set from this C1, this is just German words in the category names table. So my first result set, my first table, if you will, is just German words. I am left joining the table C2, ignore that it's the same thing. And in this set over here, it's just English words. Just German words, just English words, right? I'm then joining them on the category ID. So it's going to join everything together, and I'm saying eliminate where C2 is null. That means it came in from the left join, right? So that there was a German word and there was no English word for it, which means that there was no translation for it. Little mind bending, but does that make sense? Yeah, Mark.
Could you not do that with a subquery?
You would still have a join. So no, I don't think you could. No matter what, somewhere you're going to have a join. To be really clear about this took me some time of me staring at my computers like, how am I going to do this? So, thought it was a fun little adventure in joins. Nothing here is anything that you haven't seen before. It's just weird because it's the same thing. So you did it. You did it. I'm so proud of you. You listened to me drone on about SQL for literally hours. You deserve a badge, a medal, a pat on the back, a hug, whatever you need. Treat yourself. That's what I'm saying. This is a lot of information to come at you all at once, but I'm going to assert now that you have a pretty good working knowledge of how to be a developer with SQL. I'm going to say that you probably now have more knowledge than a lot of seasoned developers about SQL, because most developers don't bother to go in and learn their tools, right? They just kind of learn by necessity and don't bother digging any further than that. I think what you did is better. I think this is going to make you a better developer, and I think you can do most, 95% of the surface area of SQL you can all do here. There's ways to grow and continue and advance in this, learn more about all the various different inner workings, but this is a really good working knowledge for an application developer. So some final thoughts. Almost all of what you learned, with some exceptions like JSONB, applies to MySQL, Oracle, SQLite, SQL Server. SQL is a general spec. All these things generally apply across most of these. Many of them are like copy and pastable as is into other databases. If it's not that, it's minor modification. This course was exclusively focused on using a database and not setting up a database. If you want to do things like sharding and running multiple databases, there are like ops classes that you should take, and I'm just not qualified to teach on those kind of things. We didn't cover ORMs. We talked a little bit about that. I tend to not use them because I tend to fight them more than, like, it's really useful if like you're in their happy path, and it's miserable if you're outside of the happy path. I would rather just be a little uncomfortable all the time rather than have to fight it. I don't like tools that I have to fight, in other words. So I don't use ORMs hardly ever. But that's a decision for you and your team to make. And then we didn't talk a ton about execution order. That might be something for you to go look into. That's just like, when does a select happen versus when does the where happen versus when does the order by happen. Again, for 99% of this course, other than the having section, you didn't have to care, and you probably still don't have to care. So you can just kind of tackle that when you get there. The last thing I have for you is, or last challenge I have for you as application developers, you have this now movie database that you're now very familiar with. I would like you all to go make a movie website. I don't have them on the website or on the site yet. By the time this gets posted, we'll have it there. I actually have designs for you that you can actually go and adhere to. So, but you'll have to write the CSS and JavaScript. I'm not doing that for you this time. You got it once, you're not getting it twice. And make a movie database. You also don't have to use my designs, but it was done by like a professional designer that designed like the course website, designed the recipe website. So I think I melted everyone's brain. There's not a lot left. I sympathize. I was here too, so there's not a lot left in my brain either. But yeah, thank you. Appreciate it.